stuff is just going south, but I don't want to miss sampling something greener. Dave, is it too early in the dive to pick up a rock?
No, it's not too early to pick up a rock.
The flat one right up here that's green at the very top of the screen, it's a bit ways away. Anything that's like kind of larger and green. That big
right side,
this one right here.
There's quite a big one in the kind of the center of the screen.
Yeah, you can zoom on that one. I like the flatness of this one. I see some bright red iron oxide. Oh yeah, that one.
Right on the lasers. Yeah.
That's the good one. Good eye.
The lasers are 10 centimeters apart, so that's a decent sized rock for our first sample. Definitely got some green color in there. Could be a serpentinite. So we'll get started on our rock collection. The very first thing here.
When I'm concentrating, I get the worst little.
It's that very focused look. It's good because I got Dave looking at the screen there, so
We're coming to you live from the Schmidt Ocean Institute research vessel Falkor 2. This is the first science mission for this newly rebuilt ship. Remotely operated vehicle SuBastian on this ROV dive. SuBastian's capable of diving to 4,500 meters, and we're at 3,900 meters right now. This area that we're in right now has had a pretty significant landslide. Not sure exactly when that happened, but relatively recently, geologically speaking. The foot of this landslide, this is sort of the scarp at the top of the landslide, and down the slope towards the ridge axis, the toe of the landslide covers up some relatively fresh lava flows that erupted from the western side of the Mid-Atlantic Ridge axial valley, neovolcanic zone. On this low spreading ridge axis, eruptions are infrequent. There is a known hydrothermal site called Snake Pit that's maybe 15 kilometers south of here and a little bit to the east. We've been looking for hydrothermal venting that's associated with serpentinization, the reaction between mantle rocks like peridotite that contain large amounts of olivine and the reaction between olivine and seawater produces hydrogen, some methane. At moderate to low temperatures, it produces high pH alkaline fluids. When those fluids mix with seawater, they produce calcium carbonate deposits. That's what we were looking for on the inside corner high Massif. Something, if not exactly like, but then related to the hydrothermal vent field called Lost City, which is on the Mid-Atlantic Ridge axis at the intersection with the Atlantis Fracture Zone at about 30 degrees north. a few hundred miles north of here. We did not find anything like that in this area, but we did find a large hydrothermal field along this trend on the western side of the axial valley, sort of at the, as I said, the southeast corner of the inside corner high massif. The hydrothermal chimneys extend over at least a kilometer, and yesterday's dive we explored about a 500-meter long portion of that, looking at a large hydrothermal chimney at the northern end.
Rock box 1A, please.
1A, Rock. You want to
Oh. See, like, I think that it's
As I was saying, we sampled, surveyed and sampled a hydrothermal field, a large chimney in the north. It was about 22 or so meters above the surrounding seafloor, with a number of high temperature vents on it. Temperatures around 325 to 330, and at a depth of 3,930 meters or so. And then we made a traverse to the south, finding lots of extinct metal sulfide deposits of different forms, chimneys and mounds, and cemented talus flows, rocks that had been glued together by the formation of metal sulfide deposits from fluids that had flowed up through talus slopes like the one we're looking at. Some portions we could see thick layers of cemented rocks with sulfide holding them together, a meter or so thick, in some cases thicker than that. And at the southern end of yesterday's dive, there were 4 more large sulfide chimney towers with multiple vents on each of them, venting fluids that were about 330 degrees, 330 to 339 degrees is approximately the range that we got in the hottest fluids. Okay, we've got our first rock sample in the rock box.
good sample, thanks guys.
See that the shotgun on the back.
Look at how blocky that one is. I wonder if some of the more reddish ones are.
So we're hoping to cover this area. We're at the head wall of this landscape, the landslide feature, looking at the exposures of rock and looking for the source of a hydrothermal plume that we saw that was very intense over this area. It could be coming from features along that curved wall that's on the upper or west side of this area, or it could be coming from a rough topography area within the sediment flow out hydrothermal chimneys. But there's definitely some roughness in the seafloor there that we intend to look at as we go through this dive. And we're starting in the southwest corner of the area at the sort of the southern end of the head wall, looking at this exposure of rocks sliding down the hillside.
Ask for a rock that's unaltered before we get too far up towards the altered stuff. Nice black looking rock.
There's a nice altered one up there sticking
Yeah,
out.
I want the altered ones too, but I need the unaltered ones too.
Yeah.
Yeah, any of the ones on the side on the right here would be great. Oh yeah. Oh, that's cool.
I'm not sure which one is.
Like in
any
this
of those
view, these on the
there
right.
would be like-
Yeah.
Yeah. You could put it in the same rock box. Keep them together. It's like the anticipation where you start seeing like the signs that there's a good system ahead. Oh darn. Some really big.
We have 14 people in the ROV control room right now. It's a good sized room. ROV pilots and co-pilots across the front. Melissa Anderson from University of Toronto is just to my left. She's our geologist for this dive, who's been mapping out the area, making a geologic map, helping all of us figure out how the geologic structures and faults and affect where the hydrothermal fluid is coming out, as well as just understanding how this seafloor got its shape and where these rocks are coming from. Currently we're going to pick up what looks like a relatively unaltered piece of rock, dark coating.
Beauty. Once you bring it up and it's just
We have rock boxes on the front of the ROV. These first two rocks are going together in the same box. They're very different looking, so it's quite easy to tell them apart.
perfect. Thank you. Yes, please.
The length of this dive today is fixed by the fact that we're diving at the same time as the autonomous underwater vehicle from Mbari is in the same general area doing a mapping run. The AUV will be mapping both a bit to the south of us and to the north of us, extending the high resolution map of this area, helping us figure out the geologic context here.
Very nice voice for narrating science guys.
Nice and calm, yes. My 2 hours of sleep voice.
No, I love it. That's really by the time I'm sitting there, I'm like tired and I just get goofy. I'm like, oh, do myself in for
So this area looks quite interesting.
So I think if we just come up and go around this little bit. It is interesting, I just, like,
No, we
if
have
we
to
see
the
some
whole
big
thing.
chimney tunnels, that'd be great. I don't think we're gonna have time to go up the slope or anything, but here the slope's not too high, so we can
We could do fast.
I don't plan on sampling a lot, but I don't want that many altered samples. I don't wanna chimney
Yeah.
So if there's a good spot with lots of alteration exposed to it, I think it's so, but I keep saying that,
Like
it's
if you
interesting,
could,
and you're like,
yeah, sure. Like if you could go really fast and do it all this, and then
then starting
second
to
time around, that was big other stuff.
or if you could do like a photo mosaic, same thing, all it does all the just overlay it all.
That would be nice. Too bad they can't do it from 50 meters up.
If you careful, because I'm always doing this. Like if this whole scarf is really all that, then I'm gonna be out of my mind excited.
Look like it is not right here anyway. There's some altered
This
rocks,
stuff's
but
coming from somewhere. It's actually, when you look at this, like quite a lot of it is.
it does have a lot of altered rocks in it. Yeah.
Some of the really red ones also surround these, but like some of the ones that are a little bit more rough.
Notice that, it's pretty awesome.
What is that? Mm-hmm.
You're at the very base of this group. Wow, those are some big rocks.
Yeah.
But it's that big one on the left is always
Anybody have a spare pen?
I don't know.
No?
Here.
Ah, thank you. What do you got?
Sure. Just to the left side, you see right above the black rock, there's a small white vertical piece. Yeah.
This? Yeah. Right in the middle, right? Right. Right.
We're zooming in on something that's not a rock.
We get to look at the rocks at the same time, so it's okay. This is. That's old.
That's
That one is the older
Is it too big to sample?
that looks too big to sample. It is.
I do want a really close look at it, but I'm gonna have to hire you for the geology. Yeah, it's like J-Rod and his biology.
Yeah, thank you very much.
Thank you. If we're ever in a chance of recycling something else, if we see one of those, can we like poke it or cut it or something?
Oh, I see what you're talking about. That one's exciting. Can we get close to the drop?
So up above that, if you look straight up from there, see that boulder that has the white.
There's one up in the top of the camera. There's something else sticking out. But
Just while it's not a,
we can keep moving though, can't we? There's that. It's like something that's.
Do you want to see if this is our stop or something?
Where?
This big boulder right there.
Well, it's got some interesting color in it.
Yeah, I think that looks pretty. Oh yeah, right there, just a this kind of substrate, I don't expect to see that. I'm happy we can move faster.
We've got a large, looking at that large igneous rock with hydrothermal alteration on it. We're looking for zones of intense hydrothermal alteration along this wall. We do see quite a few rocks that are light in color, reddish in some places, mixed in with occasional greenish rocks that might have either higher olivine or serpentine in them.
Look, it's a huge boulder right there.
And the one on the left has highly altered face. Oh, we need to look at that. Yeah, we need to look at that.
That looks like a fault slip.
That's got vein. Yeah, let's check that one out.
Sit right beside it on the right and then look right at it. We don't need to like stare at it long. We just want to take a quick picture and then we can move on.
Get up close to see the colors on this one. You can see that surface has veins running through it, or what look like veins.
Got a picture? Okay, I'm happy. Maybe zoom just on the top part that's really white, and then we can stop stopping. Oh, nice. Look at how green it is. That's chlorine.
Yeah. You happy with that?
I'm very happy.
Okay.
Yep.
Perfect. Move you on.
It looks so misplaced.
Move you on.
This is fun.
That rock looks like it's been altered at relatively high temperature. Melissa thinks it might be a chlorite type of alteration.
Right at that base of the sediment, there's some white stuff.
Oh, there's some staining. Yeah, some white staining up at the top of our screen right now, and a bunch of rocks with white staining on them. Again, in the water over this site, we found probably the strongest signal for hydrothermal output of anywhere along the section that we mapped with the AUV. The AUVs, as they're doing their sort of lawnmower pattern of runs at 50 meters above the seafloor, pick up signals on a mapper instrument that's a miniature. The mapper has sensors for oxygen redox potential or chemical anomalies in the water column. It responds to things like hydrogen sulfide, iron, and other types of chemicals that are put into the water by hydrothermal venting. Also responds to particles in the water from things like black smoke or chimneys, or sediment that's been stirred up and put into the water. I'm seeing these zones of alteration here and that texture of,
Crusty.
yeah, not quite sure what that is, but
Manganese
rough
oxide
texture. You want to poke that, see what it looks like?
I want to keep seeing what's above it.
Yeah.
I think that it's either just indurated sediment or manganese oxide crust.
This is like a trail of hydrothermal signs that we're following up the slope. Could lead into some actual visible hydrothermal flow. Potentially. There's something coming out of this area.
Oh, look at that, it's a stockwork. Come on.
Yeah, crisscrossing veins in here.
Oh, can we, oh.
Kind of at the base of it here at 3875. This is a really good example of the sort of base of a stockwork zone, or the zone underneath an area of hydrothermal output where fluids are moving through cracks, reacting with the rocks, producing these light colored alteration veins.
I think the chimneys are gonna be on top of them.
I'm gonna put that out.
It would be cool if that was a sulfide plate. The rocks are really iron altered too. It's exciting because we never get to see what's below the seafloor. Oh, that's
This is an exposure, as we were saying, of a zone of hydrothermal alteration where fluids are percolating through these cracks, altering the rocks, producing minerals that leave differently colored veins within the rock. Those fluids migrate up and come out, and when they hit the seafloor, they produce hydrothermal vents.
Is it just alteration through cracks, or are we actually? Well, there's a lot of cracks on that, so
Here, those rocks have been uncovered by a landslide on this slope. This shows us what part of the reaction zone looks like underneath hydrothermal vents. We can try to sample some rocks here that have both the alt.
Let's keep finding cool stuff. Doesn't look like a sulfide vein, but it just looks like there's like a white crust that's being exposed from there. Stuff.
Can you see? Did you see this other camera view?
Yeah. Ooh.
Did you see that?
Yeah.
I mean, it's
Oh
tempting
my
to try to
goodness.
break off a chunk of that.
If there's something sticking up, yes, please.
We're kind of interested to see if we can break off any of that, or
If it's a vein, I'm gonna be so excited. Oh my god.
See where that white line is?
yeah, maybe we swing around a little bit and look at it.
It looks like the rocks are deformed too, like this nice blocky deformation. Sorry,
We've
before we
been-
go over there, can we zoom on this one?
Yes.
Where are you looking?
Right
Oh, the
over
blocky
here.
one? Okay, yeah.
I think there might be some like shearings and fault gouge. Just to the left a little bit more. Doesn't have to be a super zoom, I just want to get a picture of it.
I can.
You see? More to the left, please. There we go. Jen, can you grab a picture back? Okay, and zoom out slowly, please.
That was hardly zoomed in at all.
I'm happy.
Well, what do you see in there?
Seeing really deformed looking rocks, like it could be a lot of, I mean, we're kind of looking not directly at the face, but especially at the top, you can see some like See the like sense of shear?
Yeah, that rock in the background there's
Okay.
flat,
Sorry. Thank you.
scoured.
No, we don't need to keep zooming.
All right, all right.
Micro scale. Oh. This is cool. So the
Continue up along that trend. You mind seeing it from, yeah, swing around and look at it that way.
White that's sticking up or something that we can grab and seal these veins. Yeah, I can't tell if it's just a thin crust, but I think there's more out there to the left. Maybe we can, like, this thing's sticking out here. Yeah, like those big ones. It's definitely very focused fluid around. So I think that one might be the easiest to try to grab, but it's going to be soft. Like,
Yeah, it almost looks
powder.
like it's falling apart.
Yeah.
Okay. So,
So you see all the
see that
tilting of all
ridge
the
on the
rock
left, if you
layers?
follow it,
Yeah.
there's kind of a boulder
These
right
are like
here.
lava flows that are on their side. Henry, you're not excited. Can we try this one?
Yep, we're going into
It might not actually be thick, it might just be like an optical illusion. The sticking up one's
Go ahead,
a
Bridge.
better choice. If I could walk around, I would be measuring the structures in the rocks. You can see everything is tilting
Mm-hmm.
from the top right to the bottom left. So if these are lava flows that were in place and tilted, or if they're massive rocks that have been fractured and get a quite slow. With my rock camera, I could break apart the rocks and see how extensive the alteration is. So is it just a
Did you see
surface
move for you right
crust?
there?
I'd also have my hand lens, and I'd be looking carefully at these veins to see if there was sulfide minerals in it, and trying to identify all the minerals that I see. I'd be mapping out in detail all of the veins.
Yeah, I can hear you. Was it the ship's waypoint that you were gonna move, or was it one of the others? Yeah, I think the Are you good now? Jared's gonna come up there and take a look.
He wants
Thank you for calling Sebastian. This is Zach. How may I direct your call? Hello. J-Rod's on his way up to assist you. Oh, it's too late though. He's already gone. So you just have to make up a different problem when he gets there. Okay. All right. Good job. Thank you. Bye.
Zach, I think the sticky up stuff in the back is going to be something we can grab, and let's do that, because it does look like this is, I thought it was a thick thing, but it's just a thin thing on top of the side of the rock. Either that or like that crust. I don't know if you can get it.
We'll try and get whatever you want. So you tell me.
What we're gonna do
Let us go and take a look at this little bit right here. Maybe we can, like, it kind of looks like it's going on the surface.
There's a bio guy there too. See that little steel one looking dude?
Yeah. Okay, can we try to sample the little sticky outy ledge right here?
Yep. So she's talking
Right
about
near the lasers, just to the right. Aha, that bit there on the edge.
So the starboard arm's still not right.
So looking up the slope, it's still a lot more iron oxide. So this is the high temperature fluid flow.
Okay. Okay.
Might have the minerals. There's
Shall I?
Oh, sure.
Control room. You want Zach? It's using the GPS.
Thanks for calling Zach. This is Zach. Okay. No problem. Just let me know if we need to clear out of here. We're not in any sort of a precarious spot though, so we're fine. All right, bye-bye. A little bit of GPS issues, but for now we're carrying on.
All right. For the navigation of the ROV, we rely on the ship's navigation system, GPS, giving us the exact location. Ship is in contact with the ROV by an ultra-short baseline system. And the ROV also has an inertial navigation system on it to keep track of its movements. Combining those two things gives you both an accurate and smooth track. If you get any strange results from the USBL system, the inertial navigation system can tell you that they're incorrect. You can filter those out. And we have a map that the AUVs have created, as well as a map that the ship has generated with the EM-124 multi-beam sonar system on board. That's probably the best multi-beam sonar currently available. In this area, we've been running that EM-124 when we can, and it's been generating maps with about a 15 to 20 meter scale, picking up this could be a good scoop sample if you want that material.
It was definitely is. Yeah, there's probably just not that much of it. And the biologists wanted to do their scoopers. Okay, can we look at this stuff that's poking out above?
Sure.
I mean, it looks like coherent lava flows until you stab it, huh?
Gives you a sense of how steep the slope is and how smooth the surface of that rock is right there.
Frozen rock. I think we did see some further up that were more solid and had the light. Carry on up a little bit.
Yeah, let's keep moving, eh?
Mm-hmm.
Control room, the Zach.
Okay, we'll keep moving up the slope. .3872. Based on the map, we're getting close to
Roger that. We'll carry on and just let me know if you need us to
the
do
top
anything.
of this wall,
Look at that iron
up
oxide.
onto the break between the.
You know, I'm going to say you're okay where you are. And what we'll move you to the north shortly. To the northeast will be your next move, but not yet. All right, thank you, Papa.
So it's all coming up along the left.
Some of
those guys look pretty solid.
Yeah, we can just look one up. It's probably not worth trying to sample that. We'll look for like solid rocks that are altered rather than the little layers. Wow, behind. Where'd we go?
Nice stripy stripes.
Background.
Coming up sort of where it levels off a little bit on the top of this landslide scarp.
Really solid dip to the southeast. Well, southeast.
Some pretty concentrated light colored alteration coming up. Might want to head for that little light colored zone and see what we have there.
ROV Bridge.
Go ahead, Bridge.
Hello. Would I be able to change the ship setting 10 degrees to port?
That should be fine.
Alright, thanks.
Yep.
Some little rocks you can grab right there
Yeah,
on the
would
left.
love that, or right in the middle there. Any of those I would love to taste.
There seem to, in this camera, those rocks right on the left look like they'd be fairly easy to grab one. In the center, it's a bit larger, but could potentially pull one out of this section. Which section do you want? Left or center up?
Either or. I would like a dark rock and the most messed up rock that they can grab easily. It's all going to be the same minerals.
So I don't know. Just like, I don't know, we get pretty far away.
I think maybe one of these rocks up in there might be. We want a really altered looking one, so
Yeah.
right up in there.
Something really light colored, and then a rock that is more dark colored, not white. So like a pair of rocks.
Okay.
So in the foreground, like right down in there, some relatively unaltered ones.
I think
Is the
this
ship moving
alteration
towards us right now, or is it
They're
just
getting
turning?
ready.
Okay.
stuff,
Trying to settle in.
geohazard people.
Yeah. Yeah.
Yeah, I want to grab one of the light colored rocks.
Yeah, like
Light
this,
and a
this
dark one
up
too.
here looks good, or yeah, the ones up here on the right look really good, or maybe like that guy there. Something that looks as white and light colored as possible, and not just like dust on top.
So like that one there.
Yeah, there's a bunch of them in there. Those look like a reasonable size.
See rock one. Right there. Right in the middle of the screen.
Mm-hmm.
That one.
Yeah,
Beautiful.
right in there.
You wanted the
Round one.
up higher.
Yeah.
Out there.
It's definitely still some green colors.
So,
Minty, yeah, probably chlorite and some Schmidtites.
close enough for you. So,
We don't bring one short wave from Fred's calendar out because the wave is
so high. I know, it's steep.
yeah. You know, on my wish list for this dive was altered rocks, and like this was right now.
You're going striking it over
This
there.
country. Is it too far?
That one's a little out of reach.
Can we move and get it?
Oh yeah. Mm-hmm.
It's a really good one.
You have your way.
Alright.
Just gonna kind of stay ready here. You can put it between rock and solid. That should be very good.
How's that?
Thanks, sir.
Hey, Jonathan.
Yeah.
Well, I don't know if you're busy logging. That's cool. But do you want to say something about the rocks that you've been collecting? You know, the ones that you got yesterday.
I could not.
Sure.
Rock box 1B.
Come on up. Go ahead. Tell them who you are and tell them about the rocks you got. Mostly from yesterday.
Hi everybody, my name is Jonathan Umzar. I'm a PhD student from the University of Toronto. I'm mostly interested in economic geology, specifically geochemistry, so I'm interested in what makes up the rocks in terms of the chemical constituents. Some of the rocks that we picked up yesterday, we got a few sulfide chimney pieces, a decent amount of sphalerite, which is a zinc sulfide ore mineral, as well as chalcopyrite, a copper ore mineral. There's a little bit of pyrite and pyrrhotite in those as well, which are iron sulfides. We also got some altered rocks similar to the ones that we're picking up today, but we just want to get a wider suite of those to determine the extent of the fluid alteration in the area, and just to see what kind of conditions these original host rocks underwent in terms of the fluids that passed through them. Whether those fluids were very acidic or very high temperature, and we can learn a lot about the types of fluids that pass through based on the minerals that are left behind.
Thanks, John.
Can you see Melissa? 'Cause
Yeah, that's good. I'm happy anywhere.
Did you get a salt yesterday, or did you get a gabbro, or
Picked
what
up
were the-
Now one of the dark rocks. Maybe one of these guys.
We picked up one, but I couldn't use the rock slide yet today because woke up and it was already night, so I figured I would wait until daylight tomorrow.
It's hard to see rocks just from the outside. Yeah.
They collected an igneous rock yesterday, but we're waiting to cut through it to see exactly what it is. It felt pretty heavy to me. It felt heavier than a basalt.
Wow, it's very fine grained clays. Yeah, nice dark colored rock from up there. Can you log this one while I log the last one?
And here's a relatively unaltered piece of rock. Jonathan just gave you a good explanation of what we're trying to do. Identify what are the host rocks in here and how much they've been altered and under what conditions.
Perfect.
Oh, this is going in the same one?
Yep. One seat.
So we're sort of collecting rocks in pairs, one altered and one relatively unaltered from the same spot. Okay, well, we probably need to move to the bit to the north. We can get right up on top of this feature.
Do you want to follow the top of the scarp or back down to the bottom?
We'll probably go back down, but do you want to go along the top for a little bit?
Just
Just along the edge?
Yeah, just to see if there's something where there's. Well, we're still a few meters away from the top of the edge.
Let's keep going up a little bit and then move a bit more to the north once we get to the top edge. I kind of see it right up there in the background.
We don't see any big chimney structures.
Again,
They all
this.
went down slow.
Mhm.
We're seeing what was underneath the wall.
This area again was producing a very strong water column signature, so there's something in this area that we hope to find that's putting out fluids.
Perhaps somebody stay at the bottom of this. I didn't say this slope itself would be so exciting.
Okay, now we're just sort of arriving at the top of this scarp. You can see the flat sediment layers or flat benches here.
Looks like the moon. we need to go too far onto the slope here, we can follow the scarp a little bit to the north-northwest and then go back down.
Yep, take a right.
What's that about the move northwest? Sure. Yeah, I think we're gonna be pumping this and then coming back down, and I think that's what it sounds like.
Yep. Just here's something what the slope looked like before the landslide, and we've just come up a steep slope leading to this. We're going to go back down, making our way to the north.
Please stop. All right, right there now.
Or if you want to head back down, I don't think it's.
Yeah, we can turn right a little more, go back down over the edge.
That material wasn't falling down slope, it was just revealing along that scarp what would have been above it. So I think that the chimneys would have been swept down slope.
Yeah, I'm fine with it.
More white stuff.
All right, do you want to zoom? I'm going to zoom down on this.
What is it? What's a sea pig? Sea pig. Why are they so pretty? I think the rope is in front of one of the lasers.
Yeah, we've got half of our lasers set. Okay. There's laser number 2. It's getting blocked by something on the basket. Okay, we're good. We can go. It's got the image. A little more in there. Okay.
Clone yourself. Yeah, essentially. Or 2 PCs.
So I want to get back down the slope.
Oh. It's, I don't know. You spend a lot of cruises where it's like loud with clothes essentially. Let's just ride. Ooh, is it shiny?
Well, we can kind of keep going down to the right.
Slide down this slope.
Yeah, basically, yeah. We want to get back down to the bottom. Whether you, I don't know which direction you want to sort of go sideways or.
No, this way I can tell my head from not. Awesome.
But I think it's a problem. Well, I turned down. So.
It's like a scarp of a scarp. Oh, that is exactly showing the importance of alteration for land mass basically there. Take some pictures, John. It's a big feature. Oh, wow. All the chimneys were above us and they're gone.
What's the white one, is that?
It's altered rock. It's basically the fluids that are moving up to form those chimneys. We're looking at what's happening in the subsurface. Oh, that's amazing. We never get to see it. It's always like underneath us in the chimney. So this is like, I don't know, what's the depth here? 8, 7. So like not even 40 meters above us.
That notebook.
Okay. Again, you can see this layering. What? Did you say the word chimney? Shrimp. Oh, shrimpy. Okay. Because I'm looking at some round things in the background and I'm going, lava tube.
Yeah, going back down.
You want us to move the boat if you
I
start
think he's got moved, but I don't know if he's started moving just yet.
Just so much. Is it manganese oxide that's so dark? Or is it just that the sediment is so light that the rocks are looking dark?
Go and look at that vertical.
Looks like a dike, or is it just flat? Do you see the dark? Can we look a little bit to the left, please?
Yeah, maybe have
Yeah,
a.
I'm set.
Yep, yep. Having a look at this dark streak of rock with white alteration veins in it.
Is it right there? Perfect.
Could be a dike or an injection of lava.
Like, can you figure out the dip of it? Yeah. Do you see anything exposed? Is it a dike? I don't know. It's different color.
Mm-hmm.
It looks like it's. Okay, we're gonna
So
call
the
it
you gonna call it a dike?
I'm gonna call it dike. I mean,
Question is whether this is an injection of magma that would split this surrounding rock in two as it moved through.
I mean, what was our
Certainly looks like it. Heading 305. Well, at the moment.
Yeah, it's 305.
Mhm.
Face it straight on if you like.
Okay.
So it would be potentially dip into the northeast. So the fluids, the hydrothermal fluids, really like contacts and dike injections.
Okay. Now we're looking straight at it. Heading is 242, 245. You can see a contact difference between the smooth surface of that rock on the right and the darker colored rock with a white vein right along the contact. White veins along the contact on the other side. Certainly looks like a dike.
Okay.
So that'd probably be a basaltic composition in the center of the dike. See some iron oxides on the lower right.
What is the width of it? I can't really see the dots. Is that-
All right, where are they?
in
Let's see. Where are those laser dots?
maybe a meter wide?
Okay.
Okay, I'm happy we can move on.
Can you see the lasers? I can't.
Yeah, I think it's about a meter. I'll look at the photo more carefully and
All right.
I'll measure it.
Do you have what the white veins?
All of that is hydrothermal alteration of the rocks. So this is where those high temperature fluids were moving through in the subsurface, following things like dikes. And when those fluids get close enough to the seawater, that's where it'll dump all the metals. But as those fluids are moving, it's interacting with the rocks, making the rocks turbine.
This.
So what we're looking at is what happens beneath the chimneys, and the chimneys are above us and probably wiped away by the landslide.
This dike could have been a source of heat for driving some of that hydrothermal flow that created chimneys above this site. Obviously, there's a source of magma nearby, and we can see below this on the map. We can see lava flows that are less than a kilometer away, I think. Deeper down in the valley, but this looks like a dike that came through this area that's permeated with hydrothermal alteration veins.
It's more for the character, though, right?
All right, Continue down.
We're pretty close to the bottom of this. This is better than seafloor drilling because you can actually see more.
Yeah, instead of just a skinny little drill core.
You know, 1
You can
inch
get-
long section.
Yeah.
Look how great this is. This is so cool.
Really steep wall right here. Great exposure of this highly altered dike. Kind of ends right there and is covered up. Well, as you can see from our position of our waypoints, we do have quite a ways to go.
Yeah, we
What do you
can
say we
just-
go along the base of the contact here for a bit?
Yeah. Looking at the wall, we don't want to go too far down away from it. 'Cause
Right,
we'll just see
stay-
how this-
stay-
Side of depth here?
Yeah, kind of stay right at the edge there so we can see the exposed rock.
Okay.
Yeah.
And we can look up the scarp as we go. If we could point the camera upwards a little bit.
We'll just get a little higher.
Yeah. I keep on like moving my head expecting the camera to move with it. I want to look up.
See those alteration colors in there? It's another exposure of dark rock coming up.
You can move it, but-
Can I move it up a little
Yeah,
bit?
as long
Okay.
as this one and-
Oh, okay.
on that one.
All right.
Definitely tell where it's more coherent.
Something else, anything on the software.
Okay. I think we just keep on going. Make our way towards the waypoint 1 up there. Curious about what that. Oh, that's probably artificial. Yeah, there's some. Maybe some processing that hasn't been removed from the map.
Might want to move the vessels just a bit. I'm sorry to head up to the north here. Northeast. Bridge ROV, doesn't change quick, doesn't move.
More coherent.
Thanks, Chris.
Mm-hmm.
See the lines going across the street. The side scan. The lines going across the street. Got the doors up. Yeah. File right. Kind of see how the boat goes. Boat.
Some sort of contact there.
Mm-hmm.
Thank you.
The remnant of another dike, maybe? Let's see what's
Little signs of hydrothermal flow on the flat sediment filled base here. Exposed rock on the left.
So we've seen a lot of this like tilted layering, and some things that are looking really coherent looking up at them. I'm wondering if these are essentially our sheeted dikes. So we have all of our like clear volcanic material is quite a ways taller than us. There's nothing that tells me anything is a flow. So I'm really thinking, and it's not just one dike, it looks like stacked dikes. I'm wondering if these are sheeted dikes.
Could be. It would explain why we got all these flat surfaces that are
Yeah.
on the scale of meter too thick.
Yeah, and there's been like kind of a consistent, you can see it
It's all
here,
tilted.
like a consistent layering too, so I think that it's all sheeted dikes.
Yeah, could be. Makes sense. So, based on seeing these repeated flat surfaces with apparent thicknesses on the order of a meter or two, and that one dark dike that we just went across a few minutes ago, we might be moving through a sheeted dike section of the crust that's been exposed here. The sheeted dike section, if you think of the volcanic ocean crust as a sort of layer cake, the sheeted dikes are the section between the deeper magmatic bodies that crystallize slowly and the overlying volcanic extrusive layer, characterized typically by pillow basalts and sheet flows. We're not seeing lava flow features here. We're seeing dike injection primarily. Kind of cool to be looking through the different layers of the ocean crust, seeing how the hydrothermal fluids move through them, and imagining the sulfide chimneys that were sitting on top of this section before the landslide probably swept them down the slope.
They're kind of tilting towards us almost. Yes, thank you. My brain was not functioning. Okay, big instance. No, I mean this is a bottom of the slope, so I think this is pretty. I mean, it's coming towards us, but it's also dipping that way. So the strike is to the northwest, southeast, and the dip is to the southwest. Is that correct?
Yeah, striking southeast.
Striking. We also see like, so what's the depth of this sheet? These guys were at the same depth. Cool.
Which ones were at the same depth?
So the over here, I was gripping these to be sheeted dikes.
Yeah.
This is that's being deep bathymetry in the very north. You see this like down-drop topography with all of these guys, and it's all the same depth. I mean, it's even a bit higher up.
Oh, yeah,
How far away is that? That's the deal.
I mean, it's the other side of the same. Like, this is the seafloor, belly of seafloor. So everything exposed around here will be the French head. That's where my colors are. French we're sampling gabbros of the side here. And I don't tend to side here too, so these are probably finer grain than a proper gabbro.
Would agree, yeah.
Yeah.
See a little bit there.
Oh, look at that! Look
Yeah,
at that!
look at that. There's a
This is Geology Disneyland. We could do a strike and dip reading right there. I'm sorry we're not seeing chimneys, but this is cool. Yeah, I mean the scarp is really irregular too, so it's like if we can look straight at that surface, we can get a sense of it. It's zipping. It's hard to know where it's actually going because we are looking up slope. Alright, we need to outfit a Brunton compass on one of the arms of the ROV. Is that what the last observation we had was? No, it was striking northwest and dipping southeast. We can keep moving along.
nice to see a big clean rock surface like that, as opposed to something covered with talus.
Can we look more to the right, please? As we move along. Yep, right there. It's really hard for my brain to figure out the direction of things. So this is dipping this way. It's striking this way, dipping this way. And that is to be
The surface itself, or these structures that are cross cutting.
structures.
The structures that we've been cutting into, I guess, they should be digging towards like the southwest.
Correct. Okay, I'm happy. We can figure all this out from the photos later. We don't need to pause to figure it out here. I mean, with the AUV bathymetry, we might actually be able to bring it into leapfrog or something and figure out the striking depths. Where's our structural geologist when we need him? Wake up, Jeff. Okay, more alteration. Yeah. It's definitely not everywhere than others. So I think that we have like the sheeted dikes and their variable lengths that kind of inject into each other. And then at the contacts between them, you're getting all of the fluid flow. So wherever we're seeing that kind of layer of white, that's actually just like so it's not like thick, but it's surface.
Here's another zone of alteration coming up. So we've been seeing sort of clean, what we interpret as sheeted dikes or magma injections, planar, tabular sort of magma injections that feed lava flows above them, potentially at least. And we've got some more alteration here. We've come about halfway to our waypoint 1 and got quite a ways to go. What are your goals for rock sampling along here?
Oh, I would love. I forgot about rock sampling. Okay.
You actually forgot about rock sampling?
I'm too busy looking at them. Okay, I would like a piece of unaltered rock and altered rock.
I just had to remind Melissa to take a rock sample.
Okay, can we find a nice white rock in there and grab it, and then a nice dark rock and grab it? I would rather have a dark rock close to the edge of the scarp rather than in the middle. Like here we have, looking straight ahead, like talus coming straight down at us. I'm happy to get an altered rock out of there, but I'd rather get an unaltered rock from kind of the side that we just passed where the rocks are more coherent, so I can get a piece of rock from these potential dikes. Yeah, more in situ. So whatever's easiest to grab first. So wherever we have more alteration, we seem to have more of this rubble and landslides material.
And so,
Translate that. Let's see.
kind of back it up.
Yeah.
She said something behind. It'll start to get pretty
Look,
open
it's-
back there here shortly.
Yeah, let's see what's on our left here. Maybe there's something in there.
Kind of
I mean, that's
look
sort of
forward.
intact right there. Maybe, is it that rock? Yeah, maybe something at the
Right in there.
that one right there. In front of that, maybe there's something we can get. If we go up towards that dark one in the foreground a little bit.
Yeah. Looks like shit. I know, like it looks squash green, but can't get anything for it.
Oh, it's tucked in where you can't land.
It looks a lot different.
Yeah.
What it looks like out there.
Yeah.
Well, I mean, we can get.
Can move up a little bit, maybe.
1.5 kilometers with sheeted dikes below the seafloor. We can measure how far we are from something that's fairly. This is probably at the seafloor.
Okay, what might be sampleable here?
Yeah, nice. One of the ones with the dark faces. And when we get away from the alteration again, I'm gonna want another unaltered sample too.
Do you see something right here that we should go after?
One of the dark pieces is fine. So we are presumably about 500 meters below the paleo seafloor. So 500 meters isn't really that much, but if we have some fluid flow, we can get like the chloritic alteration, which looks a lot like beaches. So we're getting kind of into the talus rubble here. Maybe let's just try to grab an altered rock and then move on a bit and find somewhere that's less altered for an altered rock.
Which one do you like?
Can we look to the right? Down a bit. Yeah, I'm not confident that these rocks are from here.
So do you look at one?
Okay, actually, let's pick up this rock right here again.
Okay. So it's where the lasers are.
That's pretty good. Yeah, any of those right where the lasers are. That's 205.
Trying to get it to settle in here.
So, Dave, I looked at the depth difference between what looks like extrusive volcanics and where we are now. So, where we clearly have some volcanic material. It's a depth of 3860. Here we are 3898, so that's not too far below seafloor.
Sorry.
This might be down from and over here, it's about 500 meters from this. That's relevant. So we're below the seafloor, but we're not too far.
Not too far out again.
That's exciting. They did sample the gabbros here, which is stratigraphic crime.
Okay, picking up a dark rock sample.
So I'll just go down Falkor.
Yeah.
Something's been shut up. A lot of liquid
Yeah.
attachment.
Wrap the camera in.
That rock there looks really red.
What would you like?
1D, please.
Five on the gas lights. Do that one stuff to right tomorrow. One D.
Okay, putting the rock into box 1D. And to the left of those, you see two gas-tight samplers, titanium gas-tight bottles. Their triggers are pointing up, so we want to avoid bumping those.
Are the microbiologists interested in subsequent microbiology? I don't know. They said to only know about the They probably weren't aware to accept this.
They're looking.
It's okay if it falls in the other one.
There you go.
The-
Caught on the edge of that.
Thank you. And then somewhere up this slope here, a nice light rock. Bigger is better.
That's going in the same place again?
Yes.
Same box.
So we can compare the chemistry of the altered rocks with the unaltered rocks and figure out which fluids were added, or which elements were added to the rocks by the hydrothermal fluids and which ones were leached. And how much. That's a good oxide sample there, too. I wonder if that's a chili.
We're looking for light colored altered rocks in here. So down in that rock flow there's some things. We can get in that patch there. I'm sure we can find something.
This rock sampling's a lot easier than what we were doing before.
That is
Trying to extract the tooth.
These are nice and loose.
Yeah, nice and loose and altered rocks. There's several light colored ones down there that would work.
I mean, that one boulder looks so oxidized. I would be surprised if there
Yeah,
was
there's
sulfides.
a piece right in front, or I don't know, there's some nice,
Sorry?
there's some veins out there.
that white one right at the bottom there?
Yeah, that should be good. This sort of sharp looking one.
Down there.
Yeah, yeah. You can pick up 2 pieces of light colored rock.
There's another white one to the left.
So I like the
Oh, there's
light
a-
one to the left,
there's
and
a
this
greenish
one here
one.
looks greenish.
Yeah.
That one and that one, we'll call it.
There's also, see what's the left? There's also that one right there.
Yes, please.
All 3 of those?
Yes, please. 6 ABC. So it's pretty hard to actually figure out which minerals are present. We have to kind of separate all of the very fine white clay material and try to separate it by size, and then use an XRD. And we need a lot of material to do that. So crush, but not melt, because I don't want minerals. Yeah, they just clump up.
Far down there.
We are collecting rocks in pairs of altered and unaltered from the same spots. This will be our 3rd pair of samples. How you doing? Probably don't have to stay here too much.
I can text you when I find something cool. Or I can come. Yeah.
On that side, it's vibrating.
Do you prefer a text or a wake up line? I can always just. Okay. Set up a clock. We could set up a cross
Still
pad.
there, No, I mean, it's still doing it. I can see it doing it. Everything's gone down like that.
Hey, how are you doing? I could also give you a wake-up call when we get to the interesting stuff.
Yeah, I would consider that.
I'm pretty happy with the number of altered rocks I have.
Yeah.
I do want one more in situ unaltered rock, just because we've been collecting these like so proximal that they might not be that fresh. But besides that, we can get to like one and see what all that material is. So if you
I
wanna,
mean, I'd like to see this move faster, but it's going okay. But I don't know. I want to. Let's see. We've got until. I think we got to be on deck at 3, approximately.
if we come on the
It is up all
Yeah,
night.
probably leave the bottom 3.
so it's 5:30 a.m. We'll have time. I'm not gonna stop. I can wake you up when we find an active community, and otherwise, if we don't, you can sleep. Does that sound?
Yeah, but it doesn't have to be. I mean, any kind of active fluid.
Yeah, that's fine.
Okay. Yeah. That sounds good. Should probably do that.
Okay. We'll make it go quickly.
So, let's see. We were having tomorrow sleep also until like breakfast time. So,
Just
She'll
tell me your
probably show
room
up
number.
there.
I'll call your. You have your own room, right?
I do. So far, I have not heard my phone ring. I suppose it rings, but most people, yeah, somebody can knock on my door. I'm in 561.
If there's no fluids, you get safe.
Yeah, I'd love to see this.
No,
I had about 2 hours of sleep. So.
I'm fresh.
Okay.
This is all geology anyway.
I like geology.
No. But I think you like fluids more than water.
Well, that's just fluids are my job, so I have to. If you wouldn't mind, keep update this sheet for people who are sitting here so they can tell later on. Are we're gonna get Geo 6 right here too. Okay.
Yeah, what is your room number? Okay, well, I'll text you about that.
Look up
The room list is also by the phone.
Sorry, you ready?
Yeah, I'll text you, and if you don't want to know.
Okay.
Okay,
Have fun.
thanks. Have some good sleep.
Find some cool stuff.
We have been finding cool stuff. Can I move your computer though?
Yeah. Let's put that over here.
Find you some good fluids, I promise.
All right.
Okay. Coffee, important. Also important. Ooh, that red one is exciting too. I'm not gonna take it. Restraint. Restraint. No. No.
Giant red rock.
I want it, but I'm restraining myself.
See you later.
See you. Just 2 rocks is fine. We don't need 3 if it's taking too long. Was it a good size? Or like, do you see that white one that's right in the middle right there? Looking. Yeah, anything like that is fine. You just want something that's messy. I like this one because it looks a bit greenish and maybe it's not as altered, but it's cool. Hello, internet friends. Nice to see all the familiar names again. My name is Melissa. I'm the geologist here who's interested in understanding all kinds of things about hydrothermal systems, spreading centers, volcanism, plate tectonics, kind of all the things. I'm very much a generalist geologist. Here I'm really interested in looking at the elemental exchanges and mass exchanges between fluids and rocks, and you've probably heard me excitedly in the background. Basically what we're seeing here is 500 meters below the seafloor, where we usually don't have exposure on the seafloor. We usually only see what's on the very top. So this is better than drilling. We can actually go and see what's happening in 3D. Jason in Michigan, I also want to rock. So for these altered rocks, I do like ones that are extremely altered, but I also like ones that have some different colors. So the extremely altered ones, my guess is it's a lot of smectites, which are clay-sized silicates. This greenish color, probably a chlorite, but even when we get it on board, we're probably not going to be able to identify those minerals because they're all so fine-grained. So we're going to have to separate out all the alteration minerals, all this clay-sized material. Then we are going to use X-ray diffraction, where we shoot X-rays through the crystal structures, and the way that the X-rays diffract can tell us exactly what that mineral is based on the crystal structure. And yeah, the area that we've been going, we've been seeing basically what we call sheeted dikes. So this is how magma gets close to surface. When we're at a mid-ocean ridge, it injects along dikes, and then we'll continually do that as there's spreading going on. And right at the contacts between these dikes is like a nice permeable horizon for fluids to move through. So we've been seeing a lot of this alteration rate kind of at the contacts with the dikes. Ooh, it is nice and soft. That's good. Gonna be altered. That's good. If you can pick it up, great. If not, we can just do one rock. The other thing we've been noting is areas where there's a lot of more alteration. It's what we would call pervasive. That's where we see more of these talus slopes, these rocky debris slides, rather than coherent flows. So one of the ideas is that when we have a lot of hydrothermal alteration of the crust, it actually destabilizes the surface and makes it more prone to landslides. And that's true on land as well. All right, same spot, please, and then we'll just do those two, and then we move on. Okay, you're full logger. Are you okay with that? Are you awake enough? Great. Bringing you along was the best idea ever. So I have my PhD student, John Umsar, who you heard earlier, who is also in the control room here. There's a lot to do while we're doing this. We are talking to you. We are making plans. We're looking at maps. I am making my own map that's overlaid on the bathymetry of all the geology we're seeing. We are making observations, we're logging our observations, we're logging our samples, trying to figure out the context of all of the samples so that when we get the rocks back in a month from now, actually look at them, we can figure out, why did I pick up that rock? What does it all mean? Okay, just continuing right along the base of the scarp now towards our first waypoint. There are some really interesting red colored rocks. I'm also now noting quite a bit of red in the sediment, so iron oxide. That rock there looks red, but I don't think it's a piece of chimney. I think it's an igneous rock that has just been coated or stained with iron oxide. Yeah, we are pretty busy, and I'm also logging for some fluid sampling and stuff at the same time, so having some help with a student is just incredible. And John is a very gifted geologist, so very lucky. Okay, in relation to yesterday's dive, so we are following this steep scarp. We are pretty close to the axial floor. Let me actually tell you how close we are. Looking at my map. So we are on a steep slope of the axial wall. It's maybe 800 meters to the east of us. It's the bottom of this slope, and that's where our axial valley starts, and in the axial valley, that's usually where we have the most recent volcanism. Sorry, I need to keep making notes while I'm talking to you. And along that slope, basically parallel to that contact of the spreading center, that axial valley wall, maybe less than halfway up this slope, we had all of these chimneys. There were a couple active chimneys and a lot of inactive chimneys and a lot of other signs of hydrothermal activity. Basically, we saw a lot of talus, or rubble that looks like this, that was all cemented together because hydrothermal fluids had moved through and precipitated some minerals and stuck it all together. So that covered a length of about 500 meters. Right at the end of yesterday's dive, was it already yesterday? There appears to be an area of this slope where there's a huge landslide. That big landslide is about 500 meters across, and it looks like this landslide obliterated any chimneys that would have been there. So we are just on the other side of that landslide at basically the head wall of another landslide. This scarp, this steep cliff that we've been following, is basically what we call the head wall scarp of the landslide. Excited to look at it because, again, it gives us an idea of what's happening in the subsea floor when we have these nice steep scarps. And so we are kind of following it along, and then we're gonna go kind of in the middle of this, I guess it would be a younger landslide, where we see some very subtle lumpy features in the bathymetry. There's no obvious big tall chimneys or anything like that. But when we did our CTD work and when the AUV had some sensors on it for mapping this area, this was the strongest oxidation reduction potential signature. So there's clearly venting happening here. So one hypothesis that we're testing is that there was a large hydrothermal system, and basically when we have mass wasting that moves all the chimneys away and downslope, we still have that same heat source at depth. So we can continue to precipitate new minerals at the seafloor. So I'm guessing we're going to see maybe some diffuse venting or maybe some very small chimneys. So it's kind of like the chimneys have to build themselves up. And this is all guesswork. So we're going to see. So we're not too far away from the end of yesterday's dive is basically the short answer. We're currently about 800 meters to the southeast. Southwest, I'm sorry. All right, we can move pretty quickly through this stuff. Lots of tellers here. Hello. Wow, that's a good 3D view. So what we've been seeing on the first roll is the shaded ones, so maybe we'll see some more. And if you look at the bottom, it's like this area that's all big and lumpy, so that's why we put the waypoint there, because we want to know what that is. But you're right, there's definitely like also something coming down. Spike? That could be just an artifact of the data.
Alright, thank you.
But it is like lumpy around here. But all of this is lumpy, and all of this area here has really strong backscatter. So this is probably the most interesting area, and we'll get to it last. Yeah. Yeah. We'll definitely check it out, though. I mean, I think that they've done some more cleaning of the data since they gave it to you guys, so I don't know if that is something that they identified as an artifact. Lots of sediment here. So it's pretty cool how we can just make some observations from the bathymetry, go to the seafloor, see things that we didn't expect to see, make some more observations, and then those observations and the descriptions of what we see, they're really kind of fundamentally important for interpreting the evolution of the seafloor, the whole crust, hydrothermal systems, volcanic systems. So it's really about like learning to read the story of the rocks. So can we, are we at the bottom of the slope, or can we move further down slope? I think we've kind of raised up. Yeah.
People come up to a cliff pretty soon. You want to go down that cliff?
Yeah, I want to go to the bottom because we're just sediment here. So right now it is 5:48 a.m. ship time, and we have to leave the bottom at noon so that we can go and first recover the ROV and then recover both AUVs, which are mapping to the north and south of us to give us an idea of how continuous these chimneys may be. So yeah, 6 hours more, so it's kind of a short one. The science team here, as well as, oh, that's a nice picture. Can you get that? Look how steep that is. They have been working very, very, very long hours and are extremely exhausted. That's why Dave, I sent him to bed so that he can actually get some sleep, and I promised to wake him up if we find some fluids. So it's pretty hard to keep up because we have these very long dives, and then we have all of the samples that we collect off of the dives. Okay, that's pretty close. So, no, maybe a bit more of a scarp. Bit of a flat area and then a scarp. Yeah, lots of sediment here. So once the ROV comes to surface, for example, after a 12-hour dive, we then have to get all of the rocks. John does a great job cataloging them, describing them, figuring out what the minerals are. It's what we call petrology, study of rocks, preparing them for shipping. And that's kind of the least amount of work of anyone on the ship. Everyone else is actually doing full lab experiments and chemistry, and so there's a really big team that you don't hear from on the other side of things, just working in the lab constantly. That looks like an interesting thing. Alright, so we're getting close to our first target, which on the map is a big lump right next to this scarp. We do not know what the lump is. We are going to find out what the lump is. So compared to the first half of the dive, this area you can see there's so much more sediment. It's actually been a lot less steep than the first part, so that's why the sediment is just draping everything and covering everything. Ooh, there we go, getting to the very bottom. So you can see right there that there are coherent rocks just underneath this surface. So it's not that thick of sediment. Ooh, I want a piece of rock. That looks like massive gabbro, maybe? This does not... yeah. I need to see more before I make interpretations. We could still be in the sheeted dikes. Yeah, we like a good mystery lump. That looks super massive. I think this is gabbro. I would desperately love a sample if we see something that's not just pure coherent gabbro. Wow. Wow! We're getting deep really quick. What is this? What? Huh? Is it a pillar? What? Okay, it's a remnant of a dike sticking up, probably. Yeah. Okay, can we take a quick picture? Hold on 1 second. That's a dike. We're just looking at the top of the dike. That is so cool. And that dike is cutting through the big gabbro layers. I think to the right here is another dike. This is incredible. Oh my goodness. Oh, this is so fun. Okay. So, I don't know if we can get there, but down and to the left it looks like there's some blocky pieces of this really coherent stuff. Would love a sample if we can squeeze in somewhere. We're pretty close to the lumps, which are not what I thought they were. We are facing north-northeast, so yeah, trending north. I don't have a good sense of scale on them, but that's okay. We have the lasers about to hit the top one there. If the lasers are visible. If you grab I can grab a quick photo and then we can measure that after. So those lasers are 10 centimeters apart. If you don't hear us talking, it's because we're madly taking notes. We haven't gotten bored, we've gotten excited. It does. I feel dwarfed by this. So, we're talking about gabbro. That's basically if you have a magma body, and it cools at depth, all of the surrounding rock helps to insulate it, and then it cools slowly and the crystals grow larger. The composition is exactly the same as lava flows that are at surface. So we go from magma in a large body, and then it gets injected like a sheet, and that sheet is what we call a dike. So that's what we see on the right, is basically this sheet of magma that's moved through the rock. So when we see this really massive coherent rock, it makes us think of a magma chamber that's cooled in place. It could be more sill-like. We don't know the geometry of this magma body, but it's really cool. We are kind of looking down. We're kind of at the bottom of this area. You can see in the distance a bunch of rubble and stuff. To the left, we have an almost vertical face.
Could we please get a zoom on the left-hand side of the cracked rock in the back? There's a little maybe scale worm. Please.
We might have an animal on our rock.
Yeah, the very back rock. Just on the left.
There are smaller pieces that we're going to sample. Good eye.
What is that thing sticking up from the rock on the other one?
On the left.
Yeah. We can get a close up on that.
Oh,
thank you.
pouring landslide. We're just gonna see some talent.
That's fine.
You want a crustal section? Here's your
Thank you
crustal
very much.
section. I'm still wondering what these lumpy bits are to the right of us. It's positive relief. Yeah, so I'll show you on the map here. So we are right here. This slope right here is where we have the gabbro. This is right where
I guess.
yeah, something that's. Can we look down a little bit? Yeah, these look challenging. That piece in front of the white one is fine if you can reach it.
In front of the white ones?
In front of the white one, yeah. I keep wanting a pristine sample, and then it's like right next to some altered stuff, so it makes me wonder if it's pristine. Look, mini landslide. Ah. We're wedged in here good, huh? What were the animals we were seeing?
So we think it's a type, the silvery wormy thing looks like some kind of polychaete. And then
Scale worm.
do you think it was a scale worm? Because it looks like more of a general
Less glare on that. That's how it's sit on it.
Yeah.
Less glare.
It could definitely have the rounded shape.
See what I can do for you.
But yeah, so maybe a scale worm or some kind of polychaete. And then the other one looked like
I'm
a
gonna turn the inner catholics off.
Sponge and some sort of worm, polychaete or scale worm. Can you guys hear Megan? Do I have to? I never know how sensitive this mic is. So now that I look at the bathymetry and I see these, and topographically, sorry, the current depth is 3892, and where those are 3842, so we're actually 50 meters deeper. Who knows what happens here? If we went up section, it would probably, maybe in here, be some sheeted dikes exposed. I don't know. I'm sure I'm not allowed to just spend the whole dive looking at these things. We're gonna find out what the lumps are. It could all just be these pillars.
Of dikes.
Yeah, I don't know. Maybe the dikes are these smaller pillars down here. These look pretty lumpy though.
So we're wanting a sample of the gabbro.
Yeah, I just am not convinced that this is a sample of the gabbro, so I always want to take multiple samples. If we're interpreting it as intrusive, let's demonstrate that it's intrusive, but there's dikes, so we pick up 50-50 chance. The gabbro doesn't like to break into small pieces, so.
I know that.
Mm-hmm.
Just from that.
You need a sledgehammer. Yeah, visibility has decreased a lot now. Internet folks say they can hear you, but you're a tad quiet, so you'll have to yell at me next time.
All right, I'll yell next time.
Oh, good. Perfect. We can move instead of waiting if you prefer, and find another sample spot. I don't mind. I'm not married to this sample spot, no. Because if this is super fine, we could be here a while. We're a little bit blind. Yeah, I'd like to survey the weird lumpy stuff near waypoint 1, so. Uh-oh. Okay. Okay, let's put sampling on hold for a little bit, because I just looked at the clock and it's already 6 a.m. Almost breakfast.
Yeah, yes, thank you.
I went to the deep sea and all I got was this rock. Yeah, again we're seeing alteration on the dike. And those huge broken blocks. Oh yeah. Oh, nice. Giant talus.
Melissa,
Yes.
is this the area that you were thinking that maybe we find some diffusive? Or
Not yet. This is an area where there's some lumpy stuff on a map, so we said, who knows, maybe hydrothermal. But the best spot is waypoints 3 and 4. So don't be disappointed yet. Okay, some more alteration to the left. I can see on one camera. Sediment. Little bits of talents. We are now facing east. There's a fish.
Alright, thanks.
Yeah. Yeah, that's a good idea. Oh, that's a great idea. So essentially this entire area, this entire detachment, fault, core, complex, massif, whatever you want to call it, it's basically an entire mountain undersea that we're surveying for the first time. It's like if you found Everest on the moon and just got the data now that there was this huge mountain on the moon. Oh, that's where we were wedged in, huh?
Yeah.
That's a big block. Probably the flat thing in the back on the right looks like an old dike piece. Yeah. Definitely massive. Alright, can we go over top of some of these things? So the lumpies on the map appear to be this. I think possibly exposed intrusions of gabbro. Keep going straight over it. So we're going over a lumpy right now. That's the lumpy. Is it a dike? It's a dike. Is it a dike? Looks thin, but also massive. That's could just be a block. What am I looking at, John? Can we look up a little bit? I just want to see if this is just a big block. It's a giant block. Okay. It's angular. It's not a dike. Interesting. Okay. Awesome rocks. Alright, so we've kind of solved the mystery of what the lumpy things are. We're going to go just a little bit further ahead, and then we're going to move into the middle of this landslide scarp where there's different kinds of lumpy things. Can we just look up to the left? So we are currently in the middle of the Atlantic Ocean at the Mid-Atlantic Ridge. And just look up for me, please. Rocks can smile for a picture. All giant talus blocks. Wow, that's cool. Okay, can we continue to waypoint 2? Yes, but we only have like 6 hours left, so. Wait, is there an easy rock right here? Yeah, something down on the right. Okay, let's try for a rock. I'll regret it if we don't, but also Dave will be unhappy if we don't get to the end. Yeah. Yeah, I think that that's not real. I think that that's more likely an artifact in the data. It's that one probably, yeah. Because we looked at it in 3D earlier this afternoon and it was...
Yeah.
Did you delete the chimneys? Clean it too well? Yeah, so when we are looking at our high resolution bathymetry, we are always looking for things that look like chimney structures, but every so often there's false soundings that are above the seafloor, below the seafloor that we have to clean. So sometimes we get excited saying, oh, there's something there, but it's really just a data anomaly. A nice big angular chunky dude. Not the hugest one though. Yeah, there's a nice one just sitting there saying that it wants to come home. Okay, the rock will be gabbro, question mark.
What's attracted you to this rock?
I'm sorry?
What has attracted you to this rock?
So this whole section that we came to, it's the scarp, and we went through a section where there was a lot of alteration, kind of along some veiny looking things, and as we moved through it, we got to the sheeted dike complex, and alteration right between those dikes, like huge ones. And now we came down in stratigraphy, and we are in some rocks that look really massive, so we think that we're now in like the underlying gabbro intrusion. We collected a bunch of very altered rocks. You can see some of the white stuff around here. There were areas where that was like pervasive. So it's basically like seeing that crustal section again. So being able to look at the alteration in the subsurface. So there would have been like a chimney complex above us, but it's moved away. Here's a dive map. Do you want to come and look? So maybe the furniture. So we came up here, lots of talus, hydrothermal alteration, sheeted dikes. We come down here. Here's the intrusion. We wanted to hit this waypoint where there's a bunch of lumpy stuff, and it just looks like giant gabbro blocks and a couple of dikes that are still standing up. We're going to come across here and see if this is anything. There's nothing super chimney-like. And then down here, there's an area where there was high back scatter and also a couple little lumpies. So if we see anything, it might be diffuse flow or maybe some small chimneys if there was venting and now it's still going through that landslide.
So we should keep those things up above us though.
Unless you happy with
So-
this rock.
Yeah, I'm happy with that rock. It looks like there's Biobox 1A. Yeah, this we thought could be interesting, but it is interesting geologically, but not hydrothermally. So this scarp right here is basically all of this is going to be our intrusion. So we know that we're not, like there's nothing that's been a flow feature. These guys here are all the sheeted dikes. So we're not at the paleoseafloor, we're well below it. So if there's recent hydrothermalism, it can still intrude, but yeah.
Excuse me.
Yes.
You said box 1A?
Yes, please.
So we have to get where by what time?
We have 6 hours to cross this. I'm just looking at. So I think we're gonna get really fast past here. We're gonna set a speed record, and then I'm not too hopeful about this area. This area looks a bit more promising. So, but we've come all the way up the scarp and surveyed all of this.
So basically there may be nothing hydrothermal on this whole dive.
This is where we have the highest OR signature. So if there was a big hydrothermal system that got wiped away by the landslide, that hydrothermal system could still be active, and this whole area could be like the hydrothermal system building up again.
So we're trying to make sure we leave enough time to sample.
Yeah, that's where we're going right now, after we pick up a rock.
Alright, thanks.
No guarantees though. We want to know why there's a high ORP. There has to be a reason. So one idea was maybe along the scarp, that scarp could be where fluids are moving up, but it doesn't look like that's the case. So.
Anything else here?
No, that was great. Thank you so much. That was Geo07. Okay. Between here and our next waypoint, I expect we're going to see a lot of sediment and some scattered talus. We can fly as quickly as we can until we see something that looks hydrothermal.
To the waypoint 1 and then cut towards Southeast?
No, we don't need to go to waypoint 1, just straight to waypoint 2 from here.
Okay, so in that case, I need to come around.
Oh, there's 27
I just need to come around and get my tether on the right side.
I gotcha, yeah. So there was a question,
so go
have we
up.
seen any squids? We were just out on deck and the lights of the ship attract prey, and then the squid come and hunt all of the fish right next to the ship. So we were watching some squids this evening, just right at surface. We did see a really cool, strange yellow octopus. The biologist didn't know what kind of cephalopod it was, but that was pretty cool too.
What is that?
Yes.
You saw an octopus?
On the way down, a bright yellow one.
Well, that's exciting.
You should look back in the guide pictures.
Like a head with a little headdress.
Almost swap out, then we can go eat, and then so we have to use it after the meeting.
Yeah, just give me a second. I'm just getting facing this way. I'll hand it over. Okay. We're going to be headed southeast on that line.
Quickly southeast. This is going to be a lot of nothing for a while, so
All bets on it.
I want you to go quick over the boring. Post pictures. Yes, I'm sure that they will post pictures of it. There was also a really cool long siphonophore that looked like it had really long, cool hairs on it too. A couple of the ROV teams saw whales off the side of the ship. J-Rod's joining us now.
A whole lot.
Thanks, Doug. And he was outside and saw a whale come right up to the ship at nighttime. And he told us, and we all ran outside to look and couldn't see them anymore. But they did get a picture for evidence. And yesterday, during the day, there was some big whales that were breaching right at surface too. I missed all of that because I was sleeping. Good morning, J-Rod.
Are we bridge? Dude, on my way.
When we were leaving port from Puerto Rico and San Juan, there were also some cool seabirds. What kind of seabirds?
There were some boobies, some masked boobies, and there was some storm petrels and some brown pelicans.
And you saw some dolphins?
Yeah, saw them jump once.
It says there were masked boobies. I'm going to take his word that that is in fact a kind of bird. Was the red, colorful, sturdy chimney as cool as it looked, John?
It was pretty cool. There was donations in it, so the inside is lined with copper-rich material, chalcopyrite, and then that grades outwards towards more iron-rich. We got some pyrite and pyrrhotite. There's also a little bit of bornite, which has some nice purplish coloration to it, which is really cool to see. And on the outside, it's more zinc-rich, so sphalerite. Yeah.
Okay, is everyone taking notes about all those different minerals? There will be an exam later. Don't laugh, Megan, you're taking the exam too. Yeah, just as cool and beautiful, like very shiny, metallic looking, beautiful crystal structure. Wow, this is a lot of sediment, like I predicted.
You can see all the way through the chimney.
Yeah, that was the cool thing, is that it's basically a hollow tube where those fluids are moving through, and you can look through one end and right
One
down.
thing's for sure, there was not a recent landslide here.
Just a big straw.
Sorry?
This is pretty flat.
This is pretty flat. So where we were before, it looked like a lot of sediment, but as soon as we went down a little step, we could see that it was pretty thin. So I think the sedimentation rate is just very, very high. But yeah, we're further now from that steep scarp, so we're not seeing the huge blocks. And I guess recent is always just like relative. We can only say something happened before or after another thing, but we can't say like how long.
And it does make you always wonder how long a geologist's parents lived too.
Yeah.
What's that?
Alright, so this little lump exposes a bit of talus on this side.
We're going to the east.
Do you need coffee or anything? Oh, you don't need coffee.
Do you need anything?
No, I'm good. There's a bowl of snacks if you need it too. Breakfast is nuts. Can we move this map so that we can zoom in? Thanks. Okay, so we're getting to the very start of more rugged terrain coming up. I'm guessing for a while it's going to be sedimented talus. There was a comment that after we broke it, it had grown like half an inch along the rim when they came back to do fluid sampling. Oh, that's cool. Yeah, these things can be pretty efficient when they precipitate. I had to go to bed at some point, so I missed the end of the dive, but I'm told that we found the most exciting stuff when I was awake, so I'm good with that. Just a lot of fluid sampling. That looks different. Looks crusty, indurated sediment. So we do see a bit of that white alteration. At the very bottom we can see like some layering, which looks a lot like the sediment crusts that we saw before. So there have been fluids coming through here. So part of the reason you hear me talking with observations, we are noting them on a logger where it's recording all the things we see, plus the latitude, longitude, depth, heading, altitude above bottom. Oh yeah, some iron oxide. and I'm following along and making a little geology map as we go. So the idea is that we can't dive everywhere on the bathymetry that we have. So we go and see what we can see and what we can interpret, and then in areas we haven't been, if the morphology of the seafloor looks the same, then we can say, well, it looks like this area over there where we know it was, you know, this kind of feature. So we can extrapolate and interpret the geology of the entire area. So we call this ground truthing as well. So it's not just about going and picking up samples or just making random observations. It's about putting it all together and coming up with kind of a coherent story for the whole area. So we have to be pretty strategic in where we want to plan our dives to see the most. Okay, I see some altered material poking out. It's looking good. Okay, little bits, little bits. So this is this indurated sediment, crusts, some alteration, some buried talus. They're working on white balance. More sediment, which matches kind of our smoother topography. More crusty.
Background, that's pretty steep.
It's like a beach on the seafloor.
Melissa, do we want to be further north on that line?
Yeah, it's okay. We're just crossing this big.
Do you want to go all the way north? I can.
If you can you, let me just look.
Trying to get up and over all this.
Yeah, if we head straight east now, that would be great. Sorry, I didn't realize we drifted so far south.
Yeah.
It's good. We know where there's more sediment. Sediment confirmed. What is mangapina? Mangapina footage. I don't know what that means. Oh, that's the name. I get it. We are kind of going the wrong direction.
I'm lateral.
You're lateral.
Yeah, because it's all just down. We would see nothing if I followed your path. It's just a.
Okay, I see. It's very steep. I get it. Okay.
I mean, if I turn and go that way, you're not going to see anything.
Can we go straight north then along this contour?
Absolutely, we go north. That's
Okay.
especially because there's a spot. But yeah.
Yeah, it's
Going-
little steppy
Back
scarps.
the ROV would just be hitting the whole way down.
Ah, yeah. Oh, interesting. So we have these little scarpy step features that's kind of difficult to fly down. That's... So let's try to. I do want to be in like the kind of rugged area. We don't have to go too far north, but just a little bit. Just to avoid the smooth part. Yeah. It is the rugged terrain we wanted to investigate, unfortunately.
Which is fine, it's just going down.
Can we go backwards?
You can, that's what I was trying to do.
Backwards, but east. Okay.
So you ready to grab along?
Yes, can we crab along going straight east now? We're back in the lumpy stuff. That's cool. Okay. Sorry, I didn't really understand. I wasn't paying good enough attention.
See right there?
Yeah.
I would be looking straight down all that way.
Yeah, my brain was interpreting these as like topographic relief features rather than like steps. So we do see some altered talus again that's being buried. Yeah, we like. No, we don't. Well, we can just see it from afar and wave at it. It doesn't look like a chimney, so let's just keep moving. Alright, so we're going down the landslide right now. So you can see the really big blocks in the back. This would have been very energetic and crashing down. Most of the talus is covered with the finer sediment. So when we're moving material, the size of the material depends on how much energy the system has. So we're going to at first entrain all of this in kind of this debris flow, then the big stuff settles out first so it doesn't move as far, then the finer and finer and finer stuff, and then at the very end all of the very fine material. It really needs to be quite still water for this very fine material to settle. So after all the turbulent material comes out, then we can get the fine stuff. We have some really crazy blocky talus here. That's cool. And also I think from what we've seen in this area, there's just a huge rate of sedimentation from biological activity. So we're still like burying a lot of things. It sticks up, but that doesn't look like a chimney. That's fun. Okay. Now we know what this feature is, just blocky talus. So that was always one of the things that we were considering, that this kind of more rugged terrain in the bathymetry could just be landslide blocks. We're still hopeful though, because we did get a plume signature here. There's nothing that we've seen to suggest that fluids are leaking out of anywhere.
Still just east, right?
Indurated, yeah, that's true. But
Still just east or a little bit?
straight to waypoint 2, please. And I mean, we do see white patchy alteration. But we haven't seen actual fluid anywhere, so I guess to be more concise with my language. Where is the plume? We are plume hunting. Yeah, comments about the white balance. I mean, it's honestly not super important in this area. The sediments are kind of light colored, biological. Rocks are dark, altered stuff is light, so the tones matter more than the actual colors. And chimney material will be obvious. And iron oxides are always pretty red too, so not too worried. Yeah, once we have more time. We just want to cover ground here, so we want to see what's here and keep moving. Big block.
They didn't leave the instructions.
We have a couple of fluid chemists in the room, Joe Reesing and Pam Barrett, and they're itching to find some nice diffuse vent sites to sample.
I'm very curious where our ORP signal is coming from.
Yeah. They're like, okay, geology's cool, but let's find the fluids. I'm trying. I don't know where they are.
Biology for biologists, that's all we care about.
Oh, biology. There was a worm. We saw a worm.
All these sediments probably came from biology, is that good enough?
Yeah, let's just scoop you some sediments. And it's the kind of thing with exploration is you never really know until you visit somewhere. More sediments. Just imagine that you're on a beach. It's a very wet beach. It's a beach. White sand beach. Somewhere tropical. We are close to the equator. We are approaching 4,000 meters water depth. Good thing SuBastian, the ROV, is rated to 4,500. Have you ever gone to 4,500?
Just before you got there.
Have you ever tried to push it? No.
The cans are like rated for 4,500.
What's a can? What do you mean by that?
It's 1 atmosphere housing that holds a lot of electronics.
Oh, the sensitive stuff.
They are rated for 4,500. Not much of a what's it called? Thinking.
How do they test that? Do they put it in some sort of pressurized system and then see when it explodes or implodes? That's fun. Lots of engineering goes on behind the scenes to allow us to do this work. Oh, baby. Okay, we have maybe more coherence though right now, question mark? No, big blocks.
Too bad we don't have an ORP sensor hooked up to the... Oh! It's kind of funny. Some of these things are consistently making suggestions.
Alright, we just passed 4,000 meters. We are 4,006 meters. People online, what does your depth reading say with the overlay? We want to see if there's still a discrepancy.
There says 4083.
Sorry?
There says 4083.
4083. So
Yeah,
they're
they're the same as mine. Using that as-
okay. But is this one the correct one then? This is what Eric or Carl has?
Yeah.
Okay, so the actual depth is 4,009 meters below sea level right now. More talus. Steep slope, big blocks. No fluids. Yeah, 40. Yeah, so you are off by quite a lot. So we're at 4011, 4012. So you can just subtract 70 from whatever you're reading.
Yeah, we're gonna do the CP test with the guy one day, so do that.
Okay, let's get to a little flat area here and then head to the next waypoint. I think we've eliminated this whole area as being perspective.
We get to start heading south.
Yes, please.
Hey, look, I found the pyramid.
Oh yeah, aliens have been here. Nice blocky rock. That's what these huge peaks are. So all of our little lumps are just giant boulders. Those big ones are probably all of our gabbros, all of our mafic intrusions, basically. All the magma that cooled below surface. It's very strong. You can imagine like your granite countertop. That's an example of an intrusive volcanic, or an intrusive igneous rock. Very strong. Okay, we may need a plan of where else to survey if we get to 3 and it's still just tell us. Hey, that's like a piece of a sheeted dike, I think. So anything that we saw along that scarp, we're gonna see boulders of the same thing around here. Fish, yes, there was a fish.
That'd be great. All right, sounds good. Thanks.
I'm gonna get a white balance before we do it, or?
Yeah, mine as well.
Hold on, let me get on the other side of it. I gotta spin around it.
Oh, yeah. And then when you turn around, if you could just clear the second laser as well.
Roger that.
Thank you.
So in this area, a lot of our rocks do have a coating of manganese oxide, but there are some areas we've seen that are really interesting where there's very thick layered manganese oxide, lots of iron oxide, and sediment that's been cemented together. We call that indurated, and it's way too much to have just precipitated directly out of seawater, so there must have been some very low temperature hydrothermal fluids precipitating that and kind of cementing stuff together. So in this area, since there seems to be more pervasive low temperature alteration, the manganese coating isn't always super helpful. But certainly we don't get a good idea of what the rocks are most of the time when they have this coating. The sediment cover here I think can be tricky because it can be thick or thin and we couldn't tell. And it's not just like pelagic clays that settle very, very slowly either. They're quite large fragments of biology. So it's accumulating pretty quick. Okay, we'll find more life. I think my initial guess of more prospectivity at the top of the scarp is probably better than this.
In the base.
Mm-hmm. So it was always just a chance that it was debris. But there's definitely something onlapping. This was high backscatter. It can't just be from the slope because the UV was moving this way. So this could be just a big area of indurated crust. But don't know. But
It's at the ORP anomaly.
area. So we can't really narrow it down more than this big area with that ORP anomaly. So if we come here and rule that out, we need to have a second plan for the rest of the dive. We don't have that much time.
If we lost it, that's okay.
Oh, no, yeah, that's definitely.
We have lost it. Sorry.
Would you want to go further to the east?
Yeah.
I can't imagine west is.
I don't think that we would have time to go back up here.
Where do you want to go to?
The waypoint, we're just talking about if the waypoint's not interesting, what we would want to do next. I mean, I would love, we have young lava flows down here, but I don't think we'd get down there either.
Oh, yeah, that's what just happened.
Don't really understand what this is. It's all sedimented, whatever that contact is.
Is that not just like different phases of mass waste?
Yeah, but it's maybe just slump. The finer stuff slumps down more.
If it's something down.
Yeah. Or pouring down from this side. Just makes sense. Okay, more sediment. Yeah, carbon dating rocks. So carbon dating only works for very young material, mainly organic material. The half-life of carbon isn't very long, so you can get like maybe 50,000 years. For the most part, our rocks are much older than that. So carbon isn't a very useful isotopic system. In rocks, we tend to use other radiogenic decay series like uranium-lead dating in different minerals. We try to find minerals that are kind of gonna survive all of the upheaval and temperature and pressure changes during geologic processes like plate tectonics. So minerals like zircon, for instance, and we look at uranium lead because there's different decay chains of uranium and lead. Oh, this is that scarp. This is the exciting area. And so we can date rocks that are much, much older. We have alteration. Ooh, picture. Oh, is it Yeah, alteration. Can we just pause for 1 second so we can take a picture and make some good notes?
Like that?
Yeah, right there. 1 second.
I'm in Maine. Yes. But I can change it.
Okay, I'm happy. Let's continue. So, oh,
Yeah, go ahead.
it is a lovely layer cake, yeah. More hydrothermal alteration in the rocks. Fine callus.
Some rusty patches.
Rusty patches? You saw some rusty patches?
Just below the camera.
I see green. Yeah, I like the green, but right now the ROV is working on navigating, so we're gonna give him a minute. We might come up a little bit here.
Do you want to look at anything right here?
Yeah, sure, that green layer in the middle. We can look closely at the green layer while... does the ship need to move?
Yeah, they're on the way.
Yeah, okay. Can I show you what we're looking at here? Yeah. That gives you an idea of how thick that sediment is too. Look at that. Clear cross section.
What escape? Was that escape? Can we?
Yeah, we're setting down, then we can zoom.
No, it was a. It was.
Oh,
Yeah, it was up on the top.
Oh no.
But, sorry, I'm just getting slammed into the wall.
Yeah.
I'm not even.
Yeah, I get it. Do we need to? We can move up if you need to go up.
No, there's actually a good spot if you wanted to look at this thing. I can just hang out here until the vessel catches up.
Okay. Can we look closely at the seam when things settle a bit? Did I almost fall off my chair? Yes, I'm also slightly distracted by listening to biologists talk about fish, and listening to the ROV pilots with their challenges with navigating and waiting for the ship to move, and then also like cool geology, so my attention is a little everywhere. So we're going to wait for the ship to catch up, and meanwhile we're going to look at these rocks. It definitely looks rusty, but we might here need a white balance adjustment. We're not going to try to sample that. That's definitely not an easy sample. It's just all loose. Kind of where we are, and we know what we want to do. So we just came over here along this scarp right here, and this whole area has this kind of figure 8 shape. It has the higher backscatter, so potential for fluids making stuff solid. So coming down to the waypoint and then just maybe surveying along here. Seeing.
And this is all deeper, right?
Yeah, not too much.
So like this area, I need to get the boat in deeper water.
Yeah, we are heading to a waypoint that's at 4024. The deepest part over here is 4067. So kind of continuing south and then swinging up around
And that
to the
goes back up
northeast. Yeah. No, it's actually a little bit downhill. Okay. But basically this whole smooth surface here, we're just right at the very top of it here. And if there's nothing here, then the mystery continues. Ooh, it's white, green. Either that or the white balance is weird. Yeah, they're going to. Well. So what we have here is a bunch of loose-looking material. Anyone who's pointed that out can get a gold star. It's a lot of landslide rubble. There's some biological sediment on top of it. All that rubble is from very, very old volcanic processes. And then we have this nice little horizon where there's light-colored material that's from hydrothermal alteration. It does look kind of crusty at the base. Do you see that? Like the bottom on the right? And it's kind of like layered and crusty, so where these fluids are moving through, it's probably precipitating some different kinds of materials and making a bit of a crust. So we're looking at the interactions between the fluids and the rocks. Do you want to poke some rocks while we wait? Do you see? Oh, there we go. Oh, let's get a better picture of that now. Can you go all the way out for a second? Sorry. Can you do a picture? There we go. Okay, and then a zoom in. Can you reach the wall from where you're parked?
Absolutely.
Cool. Let's do some rock poking while we wait. Right in the middle on the right where you're looking, do you see it looks kind of layered and crusty? You want to just poke it? Yeah. So you kind of see these like two little holes. You can like maybe grab something in there and just see how easily it breaks apart. Yeah, you do have to make the noise. Sediment is all dead matter. Yeah, it's the biologists have taken a close look at the sediment and found a lot of biological debris. Don't think plants, I think just animals.
Pteropods.
Pteropods, I've been told. Oh, you can hear her. The wall is going to crumble. That's kind of what we want. We want to see whether or not there's some crusty stuff if we poke it, whether or not this white material is pervasive through that crust or just on the outside of the crust. Basically, we're not trying to get a sample, we're just trying to poke the wall. We're not trying to cause a new landslide, though. Yeah, just give it a scrape. A good scrape, and then we can let the debris settle and see what the scraped part looks like. Oh, there we go. Landslide. So again, this is what we've been noticing, where we have more hydrothermal alteration, we have more of this mass wasting landslide. There's a green rock up there too. Unsuccessful poke. Yeah. Yeah, you don't want it to all fall down. It's okay, it was just an idea while we wait. It's not like a super important scientific finding. It's definitely a layer above that looks like just like a layer of clay. I'm wondering if it was like
Just move this rock?
landslides. Yeah. Perfect. Without landslide. Oh, now we can see how thick it is. That's great. All right, let's let it settle. So again, these fluids usually tend to find permeability contrasts. Here, everything looks really loose, so we can just let some stuff fall for a little bit. Landslide in action. So in this case, it may be that there were multiple landslides kind of on-lapping each other and having alteration in different time layers. Okay. Landslide initiation study. A rock avalanche. Ooh! I hope big stuff doesn't fall on our head. Okay, so it's basically we see it as a seam. It's like a sheet of this hydrothermally altered stuff. Yeah, so we'll move like a bit south of waypoint 3 and then just kind of survey up to basically where the ship is. Yeah. Okay, geo note, unconsolidated small talus. We are good, yes. Yes, please. Let's go a little.
Upwards?
No, downwards.
Do you want to move upward?
No. Oh, if they want to look at something, yes.
No, it's probably gone.
So what was it? Did you say skate?
We something moving fish. It could be. Yeah, we don't know. It was too fast.
Yeah, that's it actually.
That's it?
This thing here in the center.
Haha, he waited for us. Worm? Worm? Worm?
Is it bad?
It has legs. Do worms have legs? Worms have legs? Scale worm? Ooh, that's an pretty.
It's massive. Do we have an idea about?
Yeah.
The laser small?
There we go.
Wow, that's like that times 78 long scale worm.
Do we need to chase it?
That's massive. That's so cool.
Massive scale worm noted. I like how opalescent the shell looks.
Sorry, can we have lasers one more time? I missed it with the photo. I got too excited.
It's like I got excited and forgot to take samples earlier.
Thank you.
Is there a difference between a polychaete and a scale worm? Is it the same thing?
Yeah, scale worms are polychaetes, I think.
Okay.
But it's just a specific type that you tend to see on hydrothermal lens.
So all scale worms are polychaetes, but not all polychaetes are scale worms.
Correct.
Okay.
You want to get a zoom in?
It's so feathery looking. What do they eat?
A lot of polychaetes tend to be predators. They usually have jaws and teeth, so smaller.
Let's move on.
Smaller critters usually.
Oh. Okay, cool. God, the sediment looks so fluffy and fine grained. Oh no. Yeah. That's mesmerizing. The tail reminds me of a horseshoe crab.
Thank you. Yeah, we're good. Thank you. That's amazing.
Okay. Okay, we go back into the pit. Pit of doom. So you see how easily the sediment gets kicked up. It's super fine grained. Okay, eyes peeled for any kind of fluids. Anything that looks like a very oxidized, very rough surfaced chimney. These look pretty blocky and massive, not like that. There's some alteration at the top, we've seen that already. Alteration all along the top, very thick. Fine sediment. A nice sediment drape over this pile. Kind of greeny looking alteration. Ooh, nice big seam. Ooh. It's like different layers of the altered seams. That's kind of a cool. Can we look to the right for one? Oh no, back up. Oh yeah. That's a nice shot. Just keep going. I'm fine. I got it. So there's different like stratigraphic horizons where we have the alteration, and it's pretty thick actually. That sediment is thick. Do you think it's indurated? That's why it's sticking there?
Yeah, it looks like rusty.
It does look rusty. Yeah. Good observation. Alteration doesn't look so continuous, but it's hard to say because there's stuff draping on top of it. Zero fluids. We have ruled out fluids. Yes, please. I want to know why our acoustic backscatter was so high. Must just be a slope reason. So I don't think the white patches are bacterial mats. I think they are layers where hydrothermal fluids have moved through and altered the rock. Some alteration products can be green, minerals like chlorite. Okay, big boulder.
He'll be down in like 2 minutes. He's almost finished. Time to get up.
depth is 4,032 meters.
Morning.
Cool geology along the scarp. A lot of boulders and talus the rest of the way in here. But we saw
Yeah, let me ask how much further south are we going?
just keep going for a bit. Not too much more, like maybe another 10 meters.
Yeah, how many meters?
10.
Perfect, great.
Never mind, we thought we were gonna need maybe the wall.
So we can kind of go northeast
Hey, you want me to stay
following
where I am?
Yes,
trend
please.
there.
Thank you.
So all that roughness there was boulders.
Boulders, giant boulders.
Okay.
Okay, so we started and there was a bunch of layered looking stuff and a ton of seams and like almost vein looking bits of white hydrothermal alteration. We got a lot of altered samples and unaltered samples. By the time we came up here, we didn't see any chimneys or anything. By the time we came over here, we realized that the layered material was sheeted dikes, which is really cool. And then we came over here and came down, and then we have massive gabbro exposed. Over here, these lumps are giant gabbro lumps. So I think a lot of the larger lumps and bumps in here are all just huge gabbro boulders. So you can kind of see it, like you can see the sheeted dikes and the bathymetry here. So cool. So we accidentally did a geology transect instead of an exploration transect. But all of this, like there's some horizons of alteration, but there's no sense of fluid. So we still have 4 hours and we don't really have a good next target. So we're just gonna like survey around here and then
Yeah. So you've already been up and down the scarp.
we came up here, so there is a lot of other interesting stuff around here, or even on top, because we can tell that we're in the subsea floor, but there still could be fluids moving. So, like along these sheeted dikes, there was like this nice alteration right between them, following the pathways. So one idea has always been that right between the sheeted dikes and the massive gabbro is like a really great permeability contrast. So it would be like this area was kind of flatter, so it's a lot of sediment. But if there was a place where we could really see that contact, it would be cool. Not perspective for fluids or biology, but still just cool. Fun. I've had a lot of fun.
Okay.
I sent Dave Butterfield to bed when he was like passing out. I'm like, if you find fluids, I'll tell you. So I have no idea where this ORP signature is coming from.
Yeah. It's interesting.
We wanted it shallow, yes, ahead of us. Yeah, we want the.
So yeah, this high backscatter, it really just looks like a scarp face, where it's from sediment to, like this is very deep sediment, and so here we have like the finer talus, so there definitely is like a change in reflectivity, I guess.
Yeah, okay, it'll change in texture.
It's just getting attenuated more over here than here, so it makes it look like this is bright and solid, but it's just that there's so much sediment here and none here. So it's not solid, but it's...
Okay.
We're ground truthing things.
Yeah.
So, do you have any ideas of where we can get to in 4 hours that would be interesting?
I'll go look.
Okay. We're at the fourth waypoint, like, or the last waypoint right now.
We're at the bottom.
Okay, can we kind of crab walk to the northeast towards the ship? You just heard me talking to Dave Caress. He's with Mbari. They brought out their AUVs, making these really beautiful maps, and we've been looking at the maps very carefully. It's 1 meter resolution. We can see those boulders in the maps, so we can see anything like coffee table size or bigger. And he's also a very talented geologist, so being able to look at the maps and try to interpret all the features we're seeing, and then come and look at the seafloor and see whether or not what we thought was happening is true. It's just really a lot of fun. So yeah, fun geology. Lots of big altered rocks, but I think I have enough. I don't really think I have enough. I always think I can use more, but I think that we just gotta cover some ground now.
Curious where all this is coming from, so then we went over this way.
Excuse me. Okay, let's see how long it will take. I think you could cover 700 meters straight down slope in 4 hours.
Sure. If you want to do that, we can do that.
Can you go talk to Dave and see if he would be interested in coming down here to the volcanic material? 700 meters, you'd have to boogie. You have to start moving right now.
Yeah,
It's 4,300 meters, so it's within tolerance.
I'm 90 meters away, so that's pretty close.
We're in ROV.
Not for sure yet.
Oh, yeah, just to let you know, we're gonna be moving in a northeasterly direction, so I'll start having you move as well, please.
Sure, no problem.
So
I'll just move that little waypoint little by little, in case we have to stop.
Okay, sounds good, thanks.
now that we've shown that there's nothing interesting here, this is like the bottom of the axial valley floor right here, and we can see a lot of young lava flows. If we can get to the bottom and see a young lava flow on this little spreading ridge, sample it, see something glassy, that would be exciting. I think this might be our only opportunity to go down there. I think we should do it. Ooh, altered block. What do you think? We can apparently boogie down to the volcanic stuff down here and see if we can get a fast.
Right. So
it means giving up on exploring for the ORP signature, but we haven't seen anything that would suggest that we. It's either that or come.
Well, the two options I see are one, just drop on down to see the volcanics.
Mm-hmm.
That's a little over 600 meters.
Yeah.
And then it's a little over 800 meters to go back up to where we were, where we never explored the lower, chimneys
or
there.
even those ones.
So, how long does it take to move 800 meters?
Right now, we're going 0.3 meters per second, which is 0.7 meters.
But by the time we get there, we wouldn't have time to sample the fluids.
Yeah, that's probably. And also that would be a move mostly to the north. I don't know if there's any difference in direction of the weather currently. It's probably pretty good.
I don't think that would affect the ship at all, and the currents aren't change much. So.
Okay, so it makes no difference.
It's your call, Dave. We have two options. Go back to chimney site, 800 meters away, kind of at this depth straight to the north, head to the east where it gets really deep, where there may be very fresh lava flows. Probably no vents. Dun dun dun. Or top of the scarp, but we could, third option is to just go back to this area on the top over here. That's 600 meters northwest.
The jaws on this one will cooperate with us as well. So port arm was early. Port arm is the one we've been using, but everything's set up to sample gas and everything from start, except for the triggered gas.
Can you continue doing some geology observations?
Okay, so,
I don't know if they were able to do something while we were gone either, so
We can try.
we can check with
We
J-Rod.
can try to see if you can operate it. It's just opening and closing the jaw.
you're talking about for rock sampling or?
No,
Grabbing anything with the starboard.
HFS.
Well, we don't have any fluids to sample with the HFS, so. And I don't think we're gonna see any here, so.
No, I thought if you were talking about going back to the chimney area, you're definitely gonna want to sample fluids, I would say, yeah.
By the time we get there, we probably wouldn't have time to
Okay.
sample the
the
fluid, so
question
it would
was
just
how,
be seeing.
how long would it take us to move 800
Yeah.
meters? And you said 0.3 meters per second is what
Yeah.
you're achieving on average?
Well, that's what I'm doing just at this moment. I can go faster. If they probably want to do is just
Cruise?
cruise, yeah.
Yeah.
Yeah, it's not working at all.
What is all this coming from?
Yeah, I mean, going back to the vents, the only point of it really is that there's that lower set of
The scientific value is, I mean, the geologic value is
Yeah.
going to the face. The value for fluids and bio people is going back to chimneys. The chimneys we've seen and sampled for the most part in a relatively small
yeah,
area.
we got fluid. So the only thing you're getting there is whether or not those lower chimneys are active or not.
And I'm pretty confident with interpreting those features because we covered such a big area of it. I don't know if they're going to be active, but they're chimneys that are either active or inactive.
Yeah, yeah, they are. Okay. Well then, dropping down seems fine. It's gonna cost time coming back,
Yeah.
right? So it's kind of a.
So the maximum depth there, let's do the math.
It's like,
We're looking at 4380. So how much time does that add to our ascent compared to where we are now, which is
24 meters a minute would come up, so any additional minutes would be.
it's another 300 meters. Is that 400 meters? Okay, it's in another 400 meters of water depth. So how much time does that add?
20 minutes.
20 minutes. So we would have to come up at 11:30 instead of 12.
Alright, well if you can make half a meter
I can definitely do that.
a second. So it's gonna take us less than an hour to get down there.
You think?
Well,
Okay.
you know, it's 3,600 seconds. And
Yeah.
6 minutes. Yeah.
That looks more altered right there.
But we can go, I'd say we probably closer to that.
We might have to wait for the ship at different points
yeah,
too.
well,
So let's just do it.
Yeah.
Why not? It's the only opportunity we're gonna have to do it. We're not gonna have a separate dive to go down there, and if we can get some young-looking glassy lava.
So,
I don't know if I'm right.
Okay. Our plan is to go directly east,
Okay.
which is going down slope. We are going to go to a depth of maybe around 4,400 meters, and we don't need to be close to the seafloor when we're going down. If it's faster to stay higher up.
Higher up. I'll keep it in sight.
Up a bit in sight, and
But
it's
nothing.
down slope, so you might want to go sideways or something.
We'll just have the other one.
Yeah.
Alright.
So it is from where we
Oh,
are,
So right now-
640 meters to the east southeast.
So like this area.
Zoom out a lot. I can move your mouse
Yeah, go for it.
anywhere kind of around here or up here.
Over there?
Anywhere in this little basin.
Okay, so.
Okay, so here? This area here?
Right here?
Sure.
So 618 meters that almost due east.
Yeah, so the one thing that I would do is I'd move that a little bit north, but down there on the bottom.
Like the
Since that's
flat
it,
part.
you're coming down a landslide there, so the yellow
Yeah.
final waypoint, move
Right.
that a little to
Just
the
move it
north.
to the north?
North.
About, like right around here?
Oh.
Northeast
No,
a bit more.
Even further north?
Yeah, a little, okay, now drop back down into the bottom, to the right.
East.
Why don't you just move it from here?
Yeah.
Northeast, the
Okay.
flat part. Do you see the like really flat
This?
looking east?
You better
east,
keep going
east,
further
Past
further
the east.
downhill, further to the right.
Further to
Two
the right.
blocks to your right.
Yeah.
east a
A
bit
little
more.
further.
There we go.
So out there, that's
Yeah.
the deep part, and
Yeah.
then on the other
Yeah.
other side of that will be lava flows.
Okay.
That should be a lava flow right there.
Might have
And
sediment,
then,
yeah.
then a little further to the east is.
I mean, if it's a young flow, maybe there's hydrothermal fluids, right?
No, no, no.
We don't
Alright.
know.
So you just want to head that direction and see what you see?
As quick as you can.
Alright.
And we don't need to see anything on the way down.
Alright. Going east like that. You're just gonna follow that track.
Sorry, we're all planning here, so we're gonna be off bottom as we go down slope. You might not see a lot.
Go ahead, RV.
Okay, we're gonna be headed towards that waypoint 11, which is northeast.
Mostly east.
Waypoint 11 northeast. All copy.
And we're gonna be trying to go a little bit quicker, so if we can make our speed 0.7, then we'll work from there. 0.7 knots.
Yeah, 0.7 knots. Understood.
Thank you. Sorry for the.
I have to go upstairs.
Okay, tell Dave. You can
That's
give him
okay.
that
I know
if you
meters per
want.
second
Okay,
anyway.
I don't know if he'll be there or not. With you, depending on when you send him to bed.
An hour in.
Oh, okay, not that long. All right, we'll see whether he's there or not.
Yeah, so we saw sheeted dikes, gabbro intrusion, lots of blocky stuff, some patchy alteration, but no fluids, no indication of recent fluids.
No chimneys falling down the hill
No,
that
nothing, no
suggested.
sulfides.
Okay.
Nothing like that. So let them know we're going down slope to young lava flow. Maybe there's venting there.
That's the ROV on the move. We're working our way towards that track line to head to waypoint 11.
All right, just informing the leaders of this cruise.
Understood. I'll just get her underway at 0.7 towards that waypoint.
The executive decisions we have made. Okay, we're on the move. We're gonna stay off bottom so we can go faster.
609 plus meters to waypoint 11. Follow this track line.
Going deep.
We're going to be going deep. You know how much it's
Sorry?
to right now, Chris?
Yeah, please.
We'll watch the depth as we go, just in case the bathymetry is off. But
Right now we're at 4886 on the depth.
And we're just cruising over there, we're not racing for the bottom.
That's-
No, I'm gonna be bottom of the site as soon as I can get it in sight.
Yeah, he's pretty dang close.
Did you see that rock he's still perched on our lower
Yeah.
starboard rail?
I did.
Did y'all notice that?
yeah.
It wants to come with us.
No good.
And then we have to get as much light as you can.
What's that?
Move as much light as you can. Oh yeah,
Get out or dash, that's everything.
yeah.
You
All
can
good.
We do
barely
about
see them when they
35.
look down. We're just letting them
Turned out.
get organized here. They'll try to keep it in
Keep an eye on our
sight,
sonar.
but you're not gonna see it well. You'll just see
He was also
tails
working.
anyway.
You want me to tilt down your set a little bit,
Yeah, go for it.
something, you know?
Yeah.
No, I'm good. Yeah, I'm good. We're just transiting and then looking at lavas.
Oh, okay.
So I'll keep it like this, like, just eat for us, is that, it's not important.
Yeah, it's going downhill.
Yeah, so we're at downhill, so I got to move it at 0.7.
Okay, there's been a lot of conversations and decision making. Mostly sediment. We're going to be flying fast and high over the seafloor.
Right, remind me that I just turned up my gains, so I turned them on.
We're going to see lots of sediment. We're going to see debris. We're not stopping for anything, even if I see the coolest rock, unless it's a chimney. Flyby observations.
It's just trying to, stick it out of
So that wall that we saw, there was some alteration, there was some colorful alteration, iron oxide. John was taking notes. It kind of didn't fulfill our purpose of finding venting though, so it wasn't really important to stop and sample it. I've already gotten some good altered rocks and unaltered rocks, so finding out what our next plan was, since we've kind of ruled out all the prospective areas for venting. We have only a few hours left in the dive, so what we are doing now is we are basically heading down this steep slope to the bottom of the axial valley right along the wall, because we see what looks to be young lava flows. Those lava flows we think are going to be nice and glassy because the AUV accidentally bumped into something and brought up some glassy lava.
Sure. I got it.
I'm taking notes.
I can see better down.
We can wave at the squids as we pass by. No, we're not going to see anything at this depth. There's no octopus down here. We're not close to any vent or anything that interesting right here, so I think the biology is going to be a bit sparse. But I'm happy to be proven wrong. If it's really cool, of course, we will stop and look. So there's a couple reasons why we want to get to glassy lava. Number one, in a slow spreading ridge, we do not see a lot of recent volcanic activity. The volcanic activity that actually makes it to the seafloor, it's very intermittent. It takes a long time to have an eruption at any given segment of the mid-ocean ridge. Most of the time we're just pulling the crust apart tectonically, amagmatically. So finding a recent flow on a slow spreading ridge is exciting. If it's glassy, we can measure the magma, the original magma composition of that glass a lot easier than of a rock that has started to crystallize. The fact that we have hydrothermalism along this axial wall tells us that it's probably this bounding fault that is focusing our hydrothermal fluids, presumably also focusing magma. So these are coming from the same heat source. The magma chamber at depth that's feeding the lava flows may be the heat source that's feeding our hydrothermal system. So it's something that's been like a tempting thing to go and study, but less important than the vents. So now that we have a bit of time and no vents, we're gonna get down there and take some samples and see what's going on. Our primary mission objective is finding venting. We haven't seen the alkaline Lost City type venting at all. No, we're flying. You can zoom on whatever you want when we get there, I promise.
Very.
We're staying up pretty high off the seafloor. We'd have to drop down. We want to get there quickly because there's not too much time left in the dive, and this area right here is less important scientifically than the bit at the very bottom. Yes, the YouTube depth overlay is off by 70 or 80 meters. It's 4136 on my display. Glassy does not mean obsidian, so obsidian is a kind of volcanic glass. It's the same idea, but obsidian is actually what we call felsic in composition. There's more silica in it, even though it's black. Oh, there we go.
Yep.
You
can't
can
stop.
you can look at the squid quickly if you want.
It was like holding something.
We're on a mission.
I take my orders very seriously.
Oh, I'm gonna have haters online if we don't stop those squids. I'm gonna be the least popular geologist in the world. Oh, there's something down there. Yeah, there might be cool life swimming by. Again, we're like on a clock now because we have a lot of distance and a lot of depth to cover. Because we're going deeper, it's going to take longer to recover the ROV, so we have to end the dive a bit earlier. And really to cover more ground and actually get to an interesting area before we have to end the dive is just the goal. So yeah, we have to make some sacrifices here.
If I can get in front of them, actually, I'll make it a little bit better.
I also think that maybe the video that you're seeing is a little bit delayed from what I'm experiencing. So an interesting thing will be if we get to young lava flows, then it's going to be a nice hard substrate, and the different kinds of benthic fauna really depend on what the substrate's made of, whether or not it's mud or silt or sand or gravel or a nice hard surface. We can see maybe how quickly a young lava flow gets colonized by things like corals when we get there.
We just felt it.
Which camera does the video feed see? That one, okay. Yeah, we're looking at the sediment in front of the porch. We don't see it very well because we are flying pretty high over it so that we can gain speed. So we're trying to set ROV speed records. We're testing we're testing the depth and also the speed capability of this machine.
It's not great flying downhill.
Yeah, flying downhill is always challenging, so our tail is much closer than our head to the seafloor.
No, it's got nothing to do with it. I know. It's just a sail. Yeah, it's just, yeah.
We're making good progress. What's our speed?
It's varying right now.
1.7?
Yeah. Just, if I stop going forward, I know. That's sink.
Do you want to come sit with me?
Yeah, just in a second. I come say hi to you.
Come say hi to the internet world.
Are you lonely?
I feel lonely. Everyone's gone for breakfast.
You want to go eat?
No.
Nice.
I'm good.
I'm full
Thank
on
you.
forward.
Bridge ROV, can you slow your speed to 0.5, please?
0.5. I wasn't. I don't know. I can't see. Yeah, it was. It's like 0.2, 0.1, so no, not really.
So what we're heading towards isn't just lava flows, but volcanic edifices on the seafloor. We're going to look at some very deep submarine volcanoes. We can see where the lava's been erupting from, the different lava flows as they inflate and deflate. Lava flows themselves can provide enough heat to sustain small hydrothermal systems. Sometimes we get high temperature chimneys, but only a few of them. Still could be fluids coming out. I don't know.
I just getting cooled up there.
Oh, it's just a sail.
Yeah.
Maybe you just have to drag that big chain of floats.
Yep. We haven't been by anything.
Oh. I'm surprised that it's mostly sediment and not big talus blocks, but I guess this is kind of a flat area.
Yeah, would be more interesting ones over here.
Yeah.
So John told me that you guys saw sheeted dikes, like the whole formation with like the dike itself and the sheets and everything.
Hydrothermal fluids moving along the sheet contacts, and below that, massive gabbro.
Was there still active flow, or you just had the alteration
Just the
indicating,
alteration,
indicating the flow? That's very cool.
So it's the crustal section, and I would be interested in knowing more about that transition from the dikes to the gabbro, but it was where there was more sediment and stuff like that. But that's a huge permeability contrast.
That's awesome.
Thank you. Geology.
What do y'all think those are? You don't really know. You see in the upper right of this map, there's these like dome-looking.
Those are lava flows. That's what we're going to. They're the pillow mounds. There's also a big cone, and you can see a tumulus, which is where lava is kind of erupted through. To the southeast, there's also a huge flat-top volcano. Young lava flows there. So you see the landslide scarp?
Yeah.
The lavas are on-lapping on that landslide scarp.
What's that? It looks like a crack going down, right?
It's a crack. It's a fault.
It is.
Oh, it's a fault. Okay.
You can also see it kind of going up through the sediments too. So we have this big line of chimneys and then a big landslide scarp. So presumably the venting has been around for a while and then has been wiped downhill by big landslide. And then magmas are on-lapping onto the bottom of that landslide apron. So presumably venting is older than the landslide, and the landslide is older than the volcanic material. It's super rare to see young volcanic material on a slow spreading sand, but you get eruptions once every, what, 100,000 years?
Whether you need one or not.
Yeah, it's cool. And like, so this whole steep scarp, it continues underneath, right? So it's a really deeply penetrating fault. So this is where the hydrothermal fluids are moving up, and also magmas are moving up that too. So the magma chamber at depth that's providing the heat for all of this is going to be the same as that lava. I mean, there might be some magma evolution, but... Okay, anything in the chat I've been ignoring? You are looking at the main cam, the side cam right now. We're really high off of the seafloor, so you can't see much. There was a comment that someone's pillow is calling. I feel the same, but the pillow lava flow.
It's I can move. I'm not really that low, but.
So I'm making the executive decision to go down there, so that Dave's not like, you should have explored more. I'll be like, wasn't he?
Okay. There aren't any RP signals down there, right? It's just geologically interesting to get the whole story.
Yeah, I mean there might be some diffuse venting or something with no...
Possibly, yeah. With flying 50 meters above, it can be that you don't pick up anything diffuse,
Yeah, also like the bragging rights of finding young volcanic materials. It does help us put the whole story together though. But yeah, I mean the other options were not that great because everything is pretty far from where we ended. So we ended right here.
Yeah.
Option 1, go back to the scarp and survey around. That's already 600 meters, so kind of... Well, actually we ended further over here. So you still have to travel a bit, and we've already surveyed a lot. It would add a little bit to the story, but the other option was crossing all of this stuff and surveying just the chimneys of the south.
I vote for that.
What adds more to the story? Like by the time we got there, there would be time for fluid sample.
Oh, that would
be. There always would be. And like we saw most of it, right? So it's just a couple, and they're
that's cool.
So
we know that there
they got
probably
down
some more. Yeah,
we
such a big field. It's amazing.
We know that those are chimneys, we just don't know whether or not they're
I
active.
think what would be kind of interesting, but that's for another year. to actually, well, we don't know when the landslide exactly happened, but to see if you can see any alteration in case the crude flow is still happening
We
underneath
have
the
been,
sediment.
yeah,
and
we've
like,
been seeing patches of white
Oh,
alteration.
also in the, yeah.
Yeah, but nothing like, there's only one area with some like crusty and derated sediment.
So it's not not very warm, it's just a little bit, and no bacterial mats or anything,
Nothing
right?
like
yeah,
that,
yeah.
no.
Just the sediment that was a
So,
little bit stained.
I feel like the most intense alteration was kind of coming up here.
Okay, not
So-
down in the valley, or in the
No.
valley, but
So I wonder about this.
Yep.
Or something up here.
Yeah.
Yeah, I mean, but there's no like clear target to aim for, so
And-
really just be guessing.
And the landslide we were in, that looks like the same age as the other one, huh?
It's
pretty much.
probably,
or
I mean,
a little younger maybe.
so my idea was that if these were all chimneys, then it would have been a hydrothermal system, it gets wiped out, and then it starts to grow again, but it's all just landslide
So,
material. This one, I think, is knocking, like, it's really like,
Yeah, but that looks, it just goes on the side of it and didn't really
Yeah, it
fully knock
goes-
it over.
yeah, it's like an avalanche. So I mean, it's still active, so the chimneys can start to grow and
definitely
build up.
growing again.
And this onlaps onto this, so this is younger than this. This is younger than
Yes.
this. There's also some inactive chimneys, so I don't know how far we're gonna get. We only need like 2 samples maybe if we can get them, and then maybe we can get up here. Because I know that Dave's interested in that too.
Trucking's a
So-
bit of a big word for it, but
Yeah, I wasn't
Going.
confident that I could make an unbiased decision, because what I find to be like scientifically interesting and
Yeah,
important
great,
is
Charlie.
important for me and not for like everybody else's objectives. So making sure that that I had a
I mean, fresh
Yeah,
flowers
less
are always
down the track.
that I had like a less biased, more experienced opinion, so that I'm not just
Continue down the track, maximum speed 0.5.
Thank you, Luke.
So one
Thank
thing that
you.
we were interested in was this little figure 8 thing here had high pack scatter, and we're like, maybe it's inverted sediment. But what it is just over here there's a lot of sediment. Scatter gets attenuated.
Yeah, just different amount of sediment cover.
And
Just
here
a bit steeper there.
it's a scarp,
Yeah.
and there's just like
more
small rubble, no sediment. So
And that road that looks like chimney is right next to the.
No.
This was just big boulders, or?
boulders.
And same here.
We didn't get up to that.
These guys, yeah.
Boulders. This was cool. So this is where the gabbro was exposed, and there were.
Connect the gabbro. I'm going to beat the
I
dye.
hope that I got a gabbro. We only got one sample there, but these things that look lumpy are pillars of intact dikes that were cut in across the gabbro, and a lot of the big lumpy things are huge boulders of gabbro. So it's like you can probably estimate how high up the gabbro comes just because it's mass wasting is different. Like it's not going down slope as far as just dropping out right there, kind of blocking off. And look, you can see the sheeted dikes here. Right? Like, this is unbelievable. So, this depth here of these sheeted dikes is 3820. Here we have the volcanics, clearly seafloor volcanics, 3666, so maybe like 200 meters below sea level, or paleo sea level. And if we come over here, really far on the other side of this complex. Where am I? Just turn on some other. I was interpreting these to be sheeted dikes.
Yep.
They are also.
Did we do that? No, we haven't been there.
You just compare it to how it looks on the
Just the bathymetry. This is clearly a late dike coming through, but and then Sorry, my color scheme is really far off. I'm not about to change it.
Unused, but that's okay.
Yeah. Up here, this whole transect we did was paleo seafloor.
Is your map?
Is there any complaints about the plan?
Well, what happened, Joe felt we should talk with Dave, and so Joe and I went ahead and talked with him, and he's okay with going down. A lot is probably going to be up in the not too distant future, but we did talk J-Rod at the meeting, and he thinks you could do fluid sampling with the port arm and the long.
Okay. So even if we found fluids right now, it's not entirely sure that
Is it the comms again? Is it the comms again that are not?
I am not sure what the issue.
The jaw on the starboard arm is not working right.
It won't close reliably, it won't reliably, but it won't close reliably.
Yeah, so
Only port. Or starboard. Starboard, okay.
So.
Yeah.
So we can get all of your gas tanks, that's not a problem.
No. We haven't fired any skins, but we haven't found anywhere interesting too.
But the lava is fresh, we could.
Oh, that's a good idea. Yeah.
Yeah, we're going really fast here.
We were. I'm stuck in the moment.
How did that rock make it on the?
Okay, well, but I mean, it's almost possible we could get a quick look at the lavas and then still make it up there.
Yeah, there's also the inactive chimneys that are close to the base of it.
Oh yeah, that's true. We could
Like these
we could
guys
head
right
that
over here.
way.
We can try to make
I'm
it
sure
up.
they're inactive, but yeah.
We'll see how
Shouldn't
quick
be
we are.
that short.
These guys are going super fast.
What do I know?
We're setting lines. Okay, sorry, let me see what the chat has been saying while I've been having conversations here.
Okay.
Okay, you're happy?
Yeah.
Do you want me to let you know when we get to the flows?
I'll see it.
Oh, you'll see it.
I'll see it up there, and I'll be. I'm gonna eat really quickly, so.
Okay.
Yeah.
Okay. So we are transiting quickly down a steep slope. We are staying pretty high above the bottom. It makes it a little bit easier to transit down a steep slope. Below us in one camera we can see that it's just been the same old sediment and a couple scattered pieces of blocks. You're not going to see much because visibility is always pretty limited in the water. But trust me when I say it's a flat, featureless plain, at least geologically. Yeah, we haven't seen a lot of creatures floating by, although I haven't been paying that good attention. There you go, you can see all the sediment. Okay, let's see. Is the water more turbid here or just the nature of the shot? Does this look like normal water turbidity to you guys?
That's probably a little bit more so than normal.
Okay, a little bit more turbid than normal. I think it's also a distance thing, so it's like being in fog where something close to you can see well, and then as it gets further away, it gets harder to see. So it's also just that we're further away from everything that's worth seeing.
When we were moving along that ridge earlier, going to starboard, there was quite a bit of digging in the water from currents going that direction. So
Okay. Some strong bottom currents, yeah. Good question. Okay. Question for the ROV pilots. The maximum depth is 4,500 meters below sea level for SuBastian. How hard would it be, and that is correct, right?
Yeah.
How hard would it be to modify it for deeper depths?
For the most part, it would be changing out specific aspects of it that aren't rated for that depth. I'm not 100% sure what our foam, what our flotation is rated for, and that would be perhaps the biggest thing to do. But some of SuBastian can go deeper, some can not, so we'd have to just swap out whatever is the
Whatever's going to implode.
yeah.
The electronics housing.
Yeah.
So it would probably be expensive. It would take the ROV offline for a while, and again, it's kind of like what the objectives are. They're having deeper submersibles, but there's so much to see on the seafloor that we can do a lot of science not going below 4,500 meters. Julie, thanks for answering. I didn't see that you'd already answered. Yeah, they might test it a bit deeper, but we're not going to push it on this dive.
4,500.
Yeah. We're going to get to 4,400 maybe. Right above waypoint 1 to the northeast where it looks all lumpy, that's getting shallow again. So
Okay.
if you're getting worried about the depth, just stay high and go over there. Comment about deep depths. You can find super cool corals in the sand that don't attach to a hard substrate. Abyssal adapted species. Oh, that's cool. I wonder if those would be hard to find. It's kind of like the main guts of the ROV, so you'd have to be wiring and rebuilding it, yeah.
You want to keep them in deeper water.
Of course it can be done, it's just how much money and time you want to spend. It might even be easier to just build a new ROV.
That would.
Yeah, I don't know. But this ROV is doing a good job for us, so we're very happy with it.
We got a high temp alarm. Sense.
Comment from Julie, thank you. There are other ROVs and submersibles that are rated to 6,500 meters. Woo! We are almost at the bottom. We have made a lot of progress. We're about 3/4 of the way there.
The next logical jump for us would be a 6,000 meter.
Mm-hmm.
And once you get to that, pretty much able to reach the vast majority of what you'd be interested in.
Mm-hmm.
So, I mean,
Maybe still cheaper than building and launching a spacecraft. But more technically challenging, I think, to have something rated for high pressure than no pressure vacuum. I'm guessing that right at waypoint 11 it's going to be sediment too. Question, do we watch movies on the boat? What's a fave? There are a lot of opportunities for entertainment. There's some very comfortable lounge spaces in the cinema, and it was nice on the transit out to hang out together, get to know each other, watch some shows. Finished watching The Last of Us. But now that we're like in the heavy work mode, we're working very long hours, eating and sleeping, and that's pretty much our lives right now. So not watching a lot right now. John, did you have a favorite movie that you've watched?
We watched one of the old Batman movies with George Clooney.
Batman with George.
That was
Oh, Megan. Hey, Megan. Why aren't you in the room? Oh, you are in the room. Hey, since you're on the way back. I like to watch, like, I think that it's probably a bit morbid, but I like watching, like, Robinson Crusoe or, like, movies where people are stranded at sea. Yeah. Why not? It's like you can relate more to it. I also have had some cruises in Vanuatu in the Southern Pacific, and it was pretty cool to read journals from Captain James Cook's circumnavigation of the world when he was kind of discovering the islands himself for the first time and meeting all of the local indigenous populations and all the cultural clashes and identifying volcanoes by seeing a glow in the distance and being able to go to that volcano that's still erupting. So it's pretty neat to think about what people were able to accomplish with very little technology.
Did you see Connor's question?
Connor's question. So, on the last dive, you ended up sampling a chunk of white rock. Was it more of that altered clay sediments, or what did it turn out to be, John?
Yeah, lots of altered clay sediments, some chlorite, a bunch of clay minerals that currently can't quite identify. There are some little flakes of some white mica, some cerussite most likely, that forms perfect little hexagons, which are really cool to see. They're very reflective.
Yeah, when the grain size gets too small, we need to use other tools because our eyeballs are not good enough. Even a microscope is not enough to identify clay minerals unless they're some obvious bright color or something. I don't know. Good question. All work, no play. Yeah, so this is why the control room is a bit quieter today, because everyone is exhausted and needs sleep. I'm more on the night shift, so I slept during the day, so I'm able to be awake. Let's see. Other questions to keep us entertained over the last 100 meters?
Trivia question.
Sorry?
It's a trivia question.
Trivia questions. Has anyone watched the movie Dante's Peak?
Yes.
Oh, thank you, Megan.
Classic.
It's Pierce Brosnan, pre James Bond, as the world's coolest volcanologist.
Behind you.
I love that film growing up.
It is so super corny, like the dialogue and stuff, but they actually do like a pretty good job with the volcanology. They dramatize things like driving over a lava flow or outrunning a pyroclastic flow and driving into a mine shaft to escape it. But other things are like actually pretty well researched. So when I watched that, oh no, I'm gonna date myself here. I watched that as a kid with my sister, and we would argue about like who's gonna be the volcanologist. Like only one of us could be. I got closer. I'm not a volcanologist, but pretty close. And I think that movies and media, science fiction, it's really like inspired a lot of scientists to pursue science. So we love it. Ghost ship, no, thank you. Yeah, Dante's Peak was great. If you really like volcanoes, like everybody should really like volcanoes. There is a really cool documentary you can find on YouTube called Nova in the Path of a Killer Volcano, and it's about this huge eruption in Pinatubo in the Philippines and all of the like work that was going on predicting the eruptions and monitoring it and like how the eruption happened and decision making about evacuating people, and you can see that a lot of dialogue from Dante's Peak was probably lifted from that documentary. But yeah, super cool. I love volcanoes. I mean, it's one of the things where they can be so incredibly destructive, which is like one of the reasons why we really want to study them from a hazards perspective, but it's also like such an important process that shapes our Earth, and people think of it as being like volcanoes are far away things that happen in far reaches of the globe, but like that's how our entire seafloor crust is created, through volcanism. So it's like such an important process and a huge process. It's just we don't always see it. So I love it, and I've rambled for a while. Who has more questions?
Did you ever see the other one at the same time with Tommy Lee Jones?
Oh no, that don't watch the movie Volcano. No. It's like a volcanic eruption in LA somehow. which makes no sense. And then they stop the lava flow with like concrete traffic barrier blocks somehow. Oh, no, it's awful. It's fun if you like to make fun of bad movies, but no. Very far from Toronto. Did the more crumbly... Oh, Connor, you have great questions. Did the more crumbly... Okay, language here. Crumbly chimney samples survive, and did they have any cool bio? Comments?
Yeah, the chimney samples all survived actually pretty well intact. There was one that was a little bit crumbly. We got 3 pieces of it, but 3 good pieces, and we'll powder those to get some whole rock geochemistry from them. Any cool bio on the samples? The biologists tend to pick off the bio before the geologists get any chance to actually look at the samples. That said, I think there was one little shrimp that got left behind in a little crevice of one of the rocks.
Did an anemone survive on? Yeah. And an anemone and some bacterial mats. Any other cool bio on rocks you guys have picked up?
I didn't actually look at any yesterday. I was busy with our.
How about elsewhere on the
samples.
cruise?
Pardon?
What about the rest of the cruise?
Yeah, we've had some. Yeah, very pretty corals and sponges on them, but I think that's about it. Really, it's been a lot of sponges on them.
Sponges and corals. Hi, Dave. Good morning.
Alright,
We saw nothing.
Okay, I heard that.
I mean, we saw cool geology, but we saw nothing
Yeah.
else.
And we're currently headed to the lava flow.
Yes,
contact.
we are almost there. At the base here, it's probably going to be sediment, and then we can climb up here, and then we can see about visiting these inactive chimneys. I made Dave Caress make the decision because I said I'm way too biased to decide what's important here.
Okay. And they told me where they were headed, and I thought that sounded reasonable. But what was there any discussion of pros and cons of the other choice versus this?
Yeah, we had 3 choices. One choice was to go and survey more around the scarp area to see if there was any venting. The geology, I feel like we characterized pretty well already, and that we didn't really see any indication of sulfide talus or anything.
Yeah.
So that one we ruled out. The other option was to go across all of here and back to this vent site. So we looked at like how we kind of got to this part. So it was just a little bit down there. They're definitely chimneys. We just don't know if they're active. And that was actually a bit longer. I think it's like 800 meters from where we were. And this was, well, 600 or 700. So it was a toss-up. So it's like down here, interesting geologically, but not for fluid. I mean, there could be some diffuse venting from the lava flow if it's young enough, if there's some heat, residual heat. But we also figured that we could come up here and get to these ones or see how much time we have to go all the way up. So I didn't know. It was pros and cons of everything. So.
Okay, so you're going to a low point.
Yeah.
You're gonna get to.
We're gonna
how
get.
deep are we getting?
4,400. We're almost there. So it's gonna add another 20 minutes onto ascent time. So if we stay at this depth, around this depth, then we'd have to end at like 11:30. But I think we can get a bit shallower as we transect. So, I mean, we don't really need to see much here. We just want to grab a couple rocks and then get up here if there's time.
I think the only thing I would add is if there's any likely area where there could be diffuse hydrothermal flow, we should try to do a transect heading towards that.
Yeah.
Because that completely takes you off of what you're
Yeah.
trying to
So.
look at with the where the lava flows are.
Yeah, we so around here we couldn't find any like interesting features to target because we kind of figured out what everything was.
Yeah.
So it's all boulders and stuff. This high backscatter is just the difference between sediment and rock on a face.
Yeah.
Over here, I don't have a good impression of where there could be flow. It could be along there, or maybe on top where there's this tumulus. That might be a better question for Dave
So-
and Jenny.
Are you going to get to that flat basin and then go up?
Yeah.
Are you going to go up that fault line
We
there?
can do whatever you want.
Yeah.
Go up this way, or we can go up this way. I don't know where there's a better chance of diffuse. I mean, it is like fractured, but not hugely faulted.
And there's no signs of chimneys
No,
anywhere.
There was no
there's
ORP.
not. It's
We
kind of
haven't.
a question of how covered by sediment that is or isn't.
Uh-huh.
Yeah.
I think the nature of the contact between the pillows and the hill is of interest, but maybe the best thing to do is, I don't know whether we should follow it up or go up on top and cut across.
Yeah. I
They've
mean,
made it down here really fast.
Yeah.
and we can continue the pace. Like we can just go to the bottom, survey the contact, go over here, and just zoom around.
I would
like,
do that. I would go like fast as you can, observing.
Yeah. That's
Just
why
cover
we've
as
been
long an area as you
Yeah,
can.
and then when we head uphill, we can go through what we think are inactive chimneys.
Yeah.
Yeah.
We can
Maybe
even
make it back
follow
to the
this.
vents.
Yeah.
That sounds good.
The goal
Go
is to do as
fast,
much
go
as
far.
possible. Yeah.
Don't stop to take many samples.
No, I want a glassy rock sample, but the geology, it's more like confirming things that we're seeing and getting some glass and looking for diffuse flow. It's not going to be like stopping for hours.
Sorry.
Okay. And quick zooms on animals if they pop up. I haven't seen anything on the screen.
We've
Kind of
been
fast.
way too fast, yeah.
Behind us, yeah.
Okay.
Can I give
Yeah,
you
that
a
sounds good.
new waypoint? We're going to continue our
Ready,
fast
Robbie?
pace.
Yeah.
Do you see this crack right here?
Yeah, is it possible?
I want to follow that.
When we get to this waypoint, we're going to be
So
heading
if you
north,
put a waypoint
almost due north. Is it
right
possible for you to also turn the vessel north and come north with us that way, or are you restricted?
Right here.
can
Sorry,
you zoom out a
you
bit?
were a bit broken there. Say again.
I'll
Just
call you on the phone.
yeah,
Yeah, it's very comfortable being great.
right here.
Sorry, I wasn't paying attention. Alright, just right click.
Right click.
Add marker.
Bud marker.
Yeah, that's fine.
Okay.
Okay, so we're gonna have to move the vessel.
Sorry about that. So, are you seeing your screen? I don't know what your screen looks like, but it looks like ours with the all the features that are on the bottom as well. You don't see that? Okay. Okay, so it dropped another. Well, it's just a marker on the screen. They can't see markers.
Oh, we can do a waypoint then. So we've reached kind of the bottom area. We're at 4370 meters below sea level, although we're still quite a bit above the bottom.
It says waypoint 11 again, but we're going to be going up to that one, and it's pretty much a straight shot north. So we were wondering if it was calm enough outside for you to turn the vessel so that it is also facing north, and just keep us right off the starboard side, and we'll stay on the starboard bow.
Yeah, and so the wind is just going to get lighter the rest of the day.
Okay.
Nice.
Okay, perfect. Yeah, if you point north and then just come east so that we're just sitting off the starboard bow, that'll keep you in deeper water, or it'll keep our building in deeper water for us. Okay. Cheers, just let us know when you're finished and ready to start moving north. Thank you. Alright.
Okay, we're waiting for the ship to catch up.
He's gonna keep us off the starboard bow. Sounds great, we'll just scoot right along. Alright.
We can,
He's again, his heading changed now.
if we have to wait, we can see if there's any creatures on this sediment plain. It's very sedimented and very flat because we're very deep, so all the sediments are accumulating here. As we're flying, it's not ideal to do a white balance, I don't think, because it's better to zoom in and focus on something. Otherwise, it's just going to try to compensate for all the blue water. So we are waiting for the ship to move a little bit. We're gonna head towards some young looking lava flows, see how young they are, see what the contact relationship is between those flows and some landslide debris that tells us the relative timing of each of these events. Mass wasting event along the landslide, volcanic eruptions at the seafloor. So let's see. We are still going to, as you probably heard in our discussion, going to transit pretty quickly. Hopefully on the lava flows there will be some cool animals to look at. We don't know how sedimented these flows will be. I want something nice and glassy, but we're not going to stop to sample rocks for too long. I'm just going to pick an easy one. I promised. I think it would be tough to dig here because it's so fine. You would just get a huge sediment plume and you wouldn't be able to see anything. Okay.
We came downhill.
We did not find any serpentinite. No. Yes. There's little tiny lumps. That's probably bioturbation.
Follow that up. Head back towards in that direction. Where the other kidneys were, kind of a long way.
North.
We might possibly get back to it go fast.
Gonna loop a bit.
Yeah, basically straight north whenever there's some opportunity.
Fast. If you see an animal, ask for a zoom. She's playing with that.
If you can communicate how important the animal is to you, like I really, really want a zoom of that versus like, do we have time for a zoom, then we can, like if it's really important, I don't want to just fly by it. We're going to be moving fast though, so stop us. Whatever.
Roger, Dodger.
Roger, Dodger. There's a shrimp.
That's a shrimp.
Now we're looking at benthic ecosystem at almost 4,400 meters water depth. My screen here says 4,375, which is going to be a little bit different than what you see. So yours is a bit inaccurate there. And we are waiting for ship to turn and move, and then we're going to head uphill again. So we've just gone downhill, now we're going to go slightly uphill. The hill is actually a volcanic edifice, and there's lava flows all over it. Pillow mounds everywhere, giant pillow mounds. It's going to be exciting, I promise. Geologically exciting. So.
ROV Bridge, how far to the east do you want me to come?
We'll start coming north, and then if you can come as far east to line up the starboard side with the back of the ROV, that'd be great.
Okay, understood.
You ready to start heading north? The ROV is going to start heading north.
Yay!
ROV stand head north.
If you see cool bio stuff, let us know too.
I've seen a couple of shrimps so far here, that's it. In this flat part.
Good morning, Sophia. I've been chatting with the chat on YouTube. I think I have been ignoring Facebook a little bit too much. I'm sorry, Facebook people.
They can still.
Oh, you see these from other friends.
Yeah.
Sorry about that.
No. I just wanted to let you know that I've been trying to stay on the ball and answer questions and stuff.
You're doing great.
Awesome. We have some lava flow. Tell us. Contact. This will be an
See a little bio.
intrusive contact when we get there. What is it? What is it? Urchins.
Tell me if you want to stop.
Don't stop unless they yell at you to stop.
Cool.
They'll make it.
Two eyeballs.
You know what'd be awesome if we found Bentley out here.
It's kind of like eyeballs with the eyelashes.
I feel even more vindicated.
So you're just kind of on the
Oh, I
side.
can get
Center there, I don't know if they want to go in the center of their one. You know what I'm saying? This is the center, you're just going on the side here.
It's quite some sediment on it still.
You start to go east as well.
No, we want unsedimented lava flows.
Right now we're on the wall.
Yeah, can we aim a little bit northeast?
Yep, move northeast.
Ideally, we'd like to be right at that contact.
Okay.
Or like to the east of it looking to the west, you know what I mean?
No problem.
Yeah.
We're moving the boat over that way too.
Sorry, the ROV pilots have been very busy managing moving the ROV and dealing with the umbilical and the ship and
Complex terrain.
yeah.
What do you think the lower part of the slope is made of?
So far I've seen some black talus, volcanic talus, and then some heavy sediment on top of it. So I think that like it still looks pretty gently, smoothly sloping morphology. So I think when we get to the more straight up areas, like you see where the big pillow is in the top right, that could be an area where we can see more exposure, but we're still right at the bottom. So.
I think we're good for this shrimp and then for the sediment, but a little bit higher up, is this something energetic?
We're gonna see. We can keep
A
going.
little bit higher. What was that?
Is that energetic there, or is that
Rocks. What are you talking about?
That's another shrimp there.
No.
Higher up, there's rocks.
It looks like a grill or something.
I know it looks like a grill. It's just a boulder.
Pretty cool.
You're gonna have a lot of different lava morphologies that you're gonna see. Primarily, you're gonna see bulbous pillow mounds. We're right at the base, so there's going to be a lot of broken talus. So, I think yeah, can we look uphill more with our camera? Can I control this camera? All right. Lots of sediment. Sediment everywhere.
Wow, it's just suddenly very
It's not a clear contact though.
Do you want me to slide one to the left?
Yeah, can you go down the slope to the right a bit?
Down to the right? Sure.
Yeah. I mean, okay, so what's throwing me off, I guess, is the size of the ROV icon there. So I think that it's pretty, yeah.
We can zoom in a bit on that second, but we're just in the middle of that.
Okay, can I change my mind? I'm sorry. I think that we're a bit further east than the contact we want to get to. So can we go over the lumps and to that black line instead? We're just at the beginning.
We're on the slope. Starting up. We're to the east, to the right of the apparent fissure between the lavas and the hill.
So we're only going to look at it and then we'll head to some. We just want one good exposure of it, really.
flow.
Backing up.
Ooh.
Yep.
I feel like the first.
It's a lot of sediment. Guess we're pretty deep though.
Almost 4,400. Almost 4,400. According to ours. I'm not sure how accurate ours is, but.
Yeah, similar. Transmitted, let's see what we have was 19 So,
Brilliant.
place in mind.
Yeah, so where we're heading is to try to find a contact between lava flows and the material to the west. Again, we're interpreting the lava flows to be on-lapping this material, so forming later, just from the bathymetry. If we can image that contact relationship, that would be helpful. And then we're going to move quickly. It's really hard to see anything right now.
Yeah, it seems like this dark line on your topo map might be this very steep sand hill, actually. I think I'm there right now.
Okay, can we just turn due north?
Sure.
Move for a little bit, and then we're going to change our direction to try to find some lavas.
Oh, I haven't.
So maybe like skirt around the edge of it on the right, I guess.
Yeah.
So in the bathymetry, it does look like there's some sediment drape over the contact. So we're just gonna go north a bit.
Can we get a quick zoom on that black thing,
We
please?
can. Let me see if I'm in autofocus. My knob.
It's a strange looking thing. What is it?
It just looks like
Broken.
like dead coral.
A little bit of mistletoe.
Can we move kind of
Biological debris.
quickly, kind of skirting around the edge to the right of this big slope here? Yeah. There we go. That might be
Might have to pay
something.
me in a little soon. Help a fair bit.
I can almost see a contact.
Oh, it might be somewhere around this corner here. Something that's not sounding right.
I mean, everything is just draped in sediment, so we can't see too much.
Ready to ROV?
RV bridge?
Yeah, we're starting to move north now, so continue that slide over to the east and get us lined up with the bow.
Some nice pillows
Don't be that
there,
wooded.
some talus. We're getting there. Ooh. Getting more volcanic. Do we wait? Sorry, do we wait for the ship or can we move quickly? What do you want?
Want to look at the map again?
Yeah,
A little bit?
here. I can change the colors if it's helpful, but we
That's
are,
okay.
We are
So
right here.
back out to where you can see the vent area. Okay. So once you come up this away, most of this first slope, then you're taking beeline
there.
for that.
That one, okay.
Yeah. And it would be great if we could get there
Okay.
and see that last section of chimneys. And maybe we have a chance for a quick you know, collection of animals or diffuse fluids.
Okay, so how far up do you want me to go? Just to the like maximum height, and then
More or less to where it starts to flatten out here, and then
Okay.
just take a
There is
direct
some
line for that other spot.
alteration in some of the chimneys here.
Mm-hmm.
Cool.
Pillows.
Pillows. You be quick. Big pillows. We're gonna see some in situ stuff. Maybe.
Looks like whatever. The flow is going to be all sediment covered mostly, huh?
Yeah, unless we get, so we're still down here. I think this steeper area here, we might get some more exposure.
Mm-hmm.
And we'll just like grab one on the fly and then keep going. I don't need a lot of samples, I just want one. Really basketball looking pillows.
Maybe break your cooling.
Yes, can you start coming north as well?
So we're just going up here. This right over here is like a ton of
Probably
sediment.
break your very broken.
Just
I'm assuming you're saying
unlapping
updated waypoint. I see that. I'm moving towards it.
There's no clear
Roger,
relationship
thank you.
between the two things. It's just too
Yeah.
much sediment.
Right.
I mean, it still looks pretty black. Like, not as young as I'm hoping, but
You want me to slide a little bit to
Okay.
the west?
Anyway,
yeah. Okay, I got
bonus
you.
points if you get to the vents.
I will get you to the vent.
Awesome.
Okay. Can we go as quick as possible straight north?
You can, but this is just about as good as possible.
This is as quick as possible. Okay.
Because it's very, very steep terrain.
Yeah, it is very steep.
So I wouldn't expect to set anyway relative to here.
All right, this is looking more in situ and less talus-y. I see a full pillow too. You logging, John? You see? Yeah, nice. They're in situ pillows here. Nice.
So,
Yeah.
let's see, we characterize this as sedimented, but not so sedimented that it covers everything.
Well, yeah, it's hard to tell because the sediment's always going to accumulate in the low spaces. So if you
Yeah.
have a flat flow, then it's going to look like deeper sediment than something rugged. I do want to pick up a sample, but we can make some more ground up before we do that. When it gets really flat at the top, it's probably going to be too sedimented. But there's also probably like multiple ages, but this contact was totally obscured by sediment.
Back there, see that last patch of chimneys that we didn't look at yesterday, it's just a little bit.
We haven't really looked at the crack, but we will have to cross it at some point.
We tried. We did go up it a ways, and it was like all of this was just sediment coming down slope,
I see.
covering it up.
Okay.
We'll cross it again. No, this is good. We want to just go uphill. So, Zach, we're gonna. Oh.
What you want is a pillow rind.
Yeah, I want something glassy. Pillow rind would be great. I'm keeping my eyes open for something that looks like we can pick it up easily.
I think it's gonna mostly flatten out from
Yeah, we've got a bit more.
not too much higher.
Yeah, I think you're right. We're coming up right here. So maybe on that face over there we'll find a nice space. Or like a small pillow would be great.
Bridge ROV, can you please make your speed 0.6?
0.6.
Little fishy. You can really see the nice scratch marks of the pillow as the lava extrudes. Okay, we're gonna look for a sample right around here. I want something that's like a small pillow. A lot of these look like they might be in situ, so they might not be super easy to grab.
Would you expect these to be able to be broken?
Maybe. Something where we have like that round outer surface. So we can maybe go up a little bit ahead where it's steeper and there's some broken stuff. You see in the top left, you can see some broken faces.
Sure.
Sorry, I didn't mean to touch the mic there. Oh yeah, that broken pillow right there would be good. Okay, can we sit down and try to grab, do you see the laser right there on the broken rinds of the pillow?
Yep.
Or even this thing right here?
Yeah, I was gonna go for that big one up in the middle.
Yeah,
That's an option.
that's perfect.
It looks like there's some loose pieces on top.
Yep. That's a great
Do
sample.
you all be coming to a stop and take a sample here?
It might, like, I don't know which one you're talking about.
Over there, come and come to the
The flat one?
Come a little bit further
Or
north
the
and
crusty
stop
one?
before we get to
The
the,
one you want. Right now, it's gonna land out. See the one that has the broken crust on
understood.
top?
Mm-hmm.
That'd be
Oh,
okay.
that would be great. There's something floating down there. What is that? What's the pink thing? Floating down the middle of the screen.
Yeah. Can you play me out a little bit? Yeah, that's right. It's kind of tightening me a little. Let's land out. All right, so
Whatever crust you can grab.
just to your right here. Like a piece of any of this kind of crust, if there's any, break it off.
Like the outer surface crust is what I really need.
Okay, the outer crust.
I don't know if that's breakable or not.
Maybe that one right there. See to the left. And I can move it wherever you use it. So it's not displaced.
If it doesn't want to come, there are also some options of possibly broken stuff in front of us.
Sure.
It's always hard to say how breakable these things are. My luck is they're always very solid. Or super crumbly. Yeah.
It's like Goldilocks, right?
Yeah. I think that's some indurated crusty sediment on top of it. Some manganese oxide. Oh, nice. I'm happy with the big piece. We're good with that.
Sorry, I don't know where this is coming from. I'm just stirred up earlier or something.
There might be some broken stuff right in front of us that you can grab. One of those blocks. You can see through the debris.
It's brief down there and stuff that's there.
Yeah.
Out to the right.
One of the blocks at the bottom is probably fine.
I don't know what that laser is there.
I think that's just going to break apart. There's a lot of manganese oxide crust on top of it too.
So that's not what you want?
I think that it would be better to just grab one of the blocks that's right below it, if that's not too stuck in the ground. Do you see those guys down there? Just one of those ones? Yeah.
Where? There's swap pumps for HP.
We just got started one for the least amount of hours. Number one was the most.
You're gonna be putting two on with one on and then one off.
Sounds like
So even like right below that, yeah, okay. I didn't see where the jaw was. Okay. Yeah. Yeah. It's like being on Mars. Is it from the dust? Nice sample.
No, we're gonna try it. We can try it. We'll try it now. We'll try it for the rest of the day.
Yeah, it's okay. I think we're not going to stack anything on top of it. There we go. I can grab a quick photo there. Oh, good. So I see some crystals in it, and then manganese oxide, so it's not that glassy, but it's okay. We're not going to stop for another one. Bio box 1B, please.
Box 1B.
Is it Geo8?
Yeah, it was for we get an HPU
porch out
filter. It's full of, that's what it is.
Bio box 1B.
Did we make Dave Butterfield aware of the problems with the phone?
Right. I don't know.
Alright, I'm gonna try it there, okay? Opening BB1.
That's definitely rough.
Back and back.
Okay, we're gonna head up the slope from here. Thank you, good sample. That is fresher than any samples we've gotten probably. Okay, we're gonna do the big transit upslope from here.
Put you in.
I'm wondering if this relationship is the opposite, like maybe this is such a big feature that it flowed down. There's probably an old waypoint if you zoom way out. Do you see where all the chimney samples are in the top left? Yeah, right there.
Oh, we're going all the way over there.
All the way over there, as quick as we
Straight that
can.
way, yeah.
Straight that way, yep.
Holy mother of God, all right.
We're covering ground today.
You're not lying.
There's
I
think we can just shoot to the northwest and we'll get over there.
Okay.
I'm not scared, you're not scared.
I just gotta get the boat.
Looks like it's all uphill, which is good news, right?
Yeah. We're gonna pay attention. So, crossing that black line, I want to stay close to the seafloor, but after that, we can go at any height above the seafloor.
Sure. I need to start moving that.
This is what we call an exploration transit. Covering one side.
Just jump before.
Yeah.
What were you saying about the SOI setup?
Oh yeah. So I'm wondering, like the idea was this was onlapping here, but what if there was a big tall relief feature and this is actually budding, like if these continue underneath? I don't know. It's a very obscure relationship. I think I need to look at that in 3D again.
Just make one that's pretty.
It did look like.
Can you see waypoint 13? That's pretty much, yeah, that's pretty much where we're gonna go, but we're gonna go there from here, so we'll end up intercepting that.
Right. Paper scarf here.
Yeah, that's what we'll do. We'll keep you ahead of us until we get on that track line and just keep coming up, just keeping us still on that starboard bow area.
I think one thing that we should have looked at is the depth of that signal that was over here. Because, I mean, we did see the coverage this way, but I wonder if it came from there.
We're going to.
Might as well, the northwest. Or what's that one? What's that really?
Hey, Jason, so again.
This one?
If
Sorry,
you,
what
it's
do we
like
see?
you can
Yeah.
alter your heading. So
Oh,
that's
the
where
pillow
you're
that was
facing that
screening.
northwest.
Yeah, hey, there's something white.
Okay. Alright. We're getting ready to start moving, so yeah, and if you can make that heading change on the fly, that'd be great.
So even these lava flows have quite a lot of heat and liquids leaking out of them, so you can still get like low temperature venting, diffuse venting. If you have like enough permeability contrast, you can form some chimneys and stuff, but it's not going to have like sustained hydrothermal circulation at that. Okay, approaching contact.
Start moving west, northwest.
Contact is definitely a positive feature. Is it a big lump? So we want to see if we can recognize, like over this little lump that we're crossing, if we can recognize pillow features that stop as soon as we cross it. Because it can just be obscured by all that sediment too. We're crossing it soon.
I could be wrong, but I still kind of feel like that sand cliff might be what showed up this guy.
Sorry?
I still kind of feel like that sand cliff we just climbed.
Mm-hmm.
Mm-hmm.
Yeah.
Okay.
Yeah. I mean, it should be like something kind of onlapping and coming up, but I was hoping that we would actually see where magma is contacting talus, but we're not that lucky. Too much sediment.
Making your way more west. Is that that line or what?
Yeah, well, see my heading right now? I'm gonna be going kind of that way.
We picked up at the side.
Oh, yeah. I think I can speed up now. I was going kind of slow. She wanted to see crossing this darker line.
Okay, I still see pillows.
No, speed up, yeah.
Got a cliff face or what?
There you go.
Yeah.
So you can see what's coming up ahead of you. Sure.
Is that a waypoint or?
You're probably gonna have to.
There's still volcanic material on top of all of this. So this is kind of what it looked like. So this looks crystallized. If there's glass, I think that this is more of the manganese oxide, but maybe there's still some glass. But this is kind of what the, like it looks like there's two layers, like maybe a fine grain or glassy layer with some crust on top. But I'm not that confident with that.
So definitely not looking that young.
No, right? But again, like what's the sedimentation, right?
So we switched to Gabbro here?
I mean, that still looks like volcanics. I still see some pillows down there. But now we are essentially on, right now, the landslide side. So this material could be coming from anywhere. Can I look up? Do you mind? Okay, we can now go in turbo mode whenever you're able to. We do not need to stay close to the seafloor if that is easier for you to fly upslope. If you want to like rise vertically 100 meters or something, I'm cool with that.
So it looks like a profound crack, but it's really just covered with sediment. So
I mean, it's definitely,
depression, but
I don't think it's a depression. I think that it is still like a positive feature because we climbed over something and it's just got sediment drape over top of it.
Okay.
So there's just a bunch of sediment coming down this slope that's obscuring whatever that contact is. But I think like Jenny's 3D view of it, where it looked like it was like here's the slope and then here's something coming up to it, is like as good confirmation as we can get.
Okay.
I don't know.
Here we go.
We still got like a pretty fresh rock from down there at least, so that's good. All right, we are on the move. We see to the right some talus that has accumulated along a little trough as it's moved down. Good little landslide material from above. We are in turbo mode. As we go up this landslide scarp, it's going to range from steep to flat, lots of sediment and talus, and it kind of looks like a stair-step pattern going down. So we are going to have some fun coming up. As we get closer to our destination, which is some cool vents, at least we know there's cool vents there, we don't have to look around for them too much, it will be interesting to see how much of the sulfide chimney material has broken off and come down slope. That's a nice big boulder. So when we were looking at the pillows, I think a lot of sediment cover there was related to the steepness. So in the more gentle places, it looked like there was more sediment cover than in the steeper places. So I think that the amount of sediment is not just a matter of how old something is or how fresh something is. Sometimes it can be topography. I mean, the little striations on that rock looks like it's still pillow talus. Some white material. I mean, presumably this is like not too far under here is where we have the fault surface that fluids would be moving through. That's a little pillow, still volcanic material. We are making good time.
Almost 200 meters above where we were.
Yeah. We're at a depth of 4212. I'm too tired now to make sentences. 4,212 meters below sea level. So this is one of the tops of one of the little stair step scarps. Very sedimented.
Sediment stuff.
What's the most distance you've ever covered in a dive?
Oh, jeez. I mean, sometimes you're doing surveys, like relay surveys with them, or I mean, for weeks, you're just going in straight on.
Oh.
Looking for any obstructions or anything for a construction project.
Oh.
So, I mean, I don't know, I'm gonna tell you.
What about for a scientific cruise?
This gotta be up there.
Can we set a record?
It's gonna be up there for you.
We're also going to be on Sebastian's 500th dive, which will be exciting.
But it's part of it too is because in science we seem to be going to a lot more interesting terrain all the time.
Yeah.
So,
Is that a crabby thing? Oh, something's moving. Bottom right, middle of the screen right. The white thing just skittered away. Io, what is that?
I think it's one of those whitish squat lobsters that we saw at the fence.
Are squat lobsters something that you only find when there's venting, or can they be anywhere? They're everywhere. Okay. Okay.
Sorry.
I gave you a bonus soon. You're welcome. You're like, oh, just a squat lobster. Oh, look at it move.
He's scared.
Nice. Yeah. Nice steep slope here. That's a good pillow tube, so we still have volcanic material coming down. Ooh, good shot there. Are all the little pock marks from bioturbation?
Yeah.
What kind of bio makes those marks?
You have different worms like polychaetes and things like that. You can have sea cucumbers down here. But yeah, those look kind of wormy to me.
Do the worms live under the sediment then, and that's why we don't see them?
Yeah, some species do for sure. Yeah.
Again, we're on a bit of a flatter area here. Big blocks. Big lumpy blocks. It's a nice little scarp. Baby stir step scarp. So all the ruggedness. Can also, when there's a chance, aim a little bit more westerly too, so we're going more straight up the slope. I don't know if that makes it more or less difficult for you.
That would be hard.
Okay,
Just
then.
because of where the boat is, I could move them a little that way.
Oh no, it's okay.
I gotta stay out of that red circle.
Okay. Oh, the danger circle. Okay.
If I get inside of that, I explode within 5 seconds.
Oh no. That looks steep right in front of us.
Take a dip and then dip and a rise.
Dip and a rise.
Kind of skate across it.
Yeah. Fly by geology. Looks like a giant block there. More of a flat area. We're covering ground and we're covering a lot of altitude. So I wonder, Tom, I wonder, so what we've seen with these little lumpy things are just big blocks. But I wonder if we're going to see Geochemicals on this little lip right here. Or if it's going to be at all indurated. Because these are kind of stepping out onto this landslide. Contact would have been here.
Can you zoom out a bit?
Over there.
We are here.
Yeah.
Nice flat step up. This step may be really interesting.
Step platform.
Yeah, and this step is where these form. And there's another step, and then it's not quite clear how these are forming, but there's definitely some. I mean, it's not that much height difference along here. It's kind of following a contour. So when we get to the next step, we keep our eyes peeled for anything that looks orange to take a picture of, or just note. See what this looks like. So this is pretty cool. Like we see this fracture coming through here and also coming through here. It's like actual scarp kind of falling down. So here it's like solid rock that's broken, and here, and you can even see that it's a little bit down. And here it's like scarp continues. This is a little tunnels. Big collapse features here.
That was the flat, or that was the lower.
This is a, yeah, they finished mapping this volcano with the, or they are finishing today's AUV dive.
But like this, like phonetically, is that?
Would still like to come up with an idea of where that ORP could be coming from, and if it's not in here, then it has to be up somewhere. It's clearly not down somewhere. When we get the extension, so they'll fly here and they'll fly up here, then they also will have information from the mapper on the AUV.
Be far enough away because, like you said, we didn't see any talents or so far. So it can't just be like right up on that.
Yeah, I think that it's maybe up here. Again, it's like, let's see what the height difference is. So this is 3853, 3960. So it's 100 meters. So was the ORP 100 meters? So the plume's not going to settle down, right? But if it moves horizontally, if it's 100 meters above, like, I think that this feature could influence the seafloor currents and like kind of make a difference of where it is. But we did go over this and there wasn't anything right there, so maybe there's some currents that are moving it. I don't know how far these things can move either, so like 700 meters. So thinking about it, maybe we should have gone to that, but I also don't know what's real and not on this map, so it does look pretty interesting. And like right here is that transition from sheeted dikes to volcanic features. There's a big structure. So fluids are coming up through those. It could be going right there. Do I regret my decision? Only a little bit. And I'm going to say that it was late.
I'm just basically,
Man, I can't keep all of this down. It's really cool.
I said, as soon as we pass that big crack, just go for it.
Okay.
I think they're worried about running out of time over there. Just going for it.
Until
Yeah, we'll get there. But I think that's also something that we didn't spend enough time like looking at the data and the plume signatures and stuff like that to really like digest it and say where is it coming from. Because it's usually successful if you dive below a plume that there's going to be a plume, but this is a very different kind of, it's very slopey. So. It's worth a look though, because who knows when you look at a map like that. what these kinds of features could be. And even little scarps can be focus fluids, so.
Back in stand like another 60.
Yeah, I'm just rocking and rolling there.
Rockin' and rollin'. We are at a depth of 4,095 meters. So even coming up here, it looked like there was indurated sediments. So these little guys are probably either blocks of indurated sediments or maybe even chimneys. So there are some other interesting things scattered around, like that big mound upslope. Didn't visit this little cluster, but these guys are clearly chimneys, but just no signal, so. So this nice layering here too. It doesn't look that pokey or anything. Like, I don't know. I don't think it's convincing that that would be chimney still here.
Maybe it's not in situ.
Maybe not, but there has to be something venting to have that signature. It's stronger than it was up here, so it didn't come from up there. Could have come that far, I don't know. It's bizarre. This looks volcanic. I wonder if those are also sheeted dikes. 3743. 4844, maybe not. I don't know. Woo, there's a dike.
Sorry.
That was a good one. Color scheme is really only good for this small height difference. It's okay. What else? I feel like I'm missing some more information. Sheeted dikes, layered material, massive material with the corrugations on it. Oh, this is what I was looking for. So there's some interesting structures cutting through here, all the way northwesterly. Even this whole big scarp here. Maybe kind of falling in half.
It seems like they both kind of go down the needs and the itself. That one and the one that are parallel to it.
These guys?
Yeah, they both runs down and it's like that.
Yeah, so
Both kind of meet these ones.
I'm trying to have context for what could be happening here structurally. So vents are going this direction. It must just be a slope thing. Doesn't follow anything.
Seriously, when I started with that mission,
I guess the other thing is, like, we see this as a trend, but it's maybe just a bit of more of a flat area or something. And we see these two, and we don't know how much material is here or has been lost. So I think it's just the whole fault. Everything is just moving up and finding fluid pathways up this fault. What happens is you have a master fault where there's a bunch of smaller structures, and fluids will go up. I mean, I guess this is kind of in the same orientation as this. So there is kind of just the trend of the slope. And then this is following the trend of the slope. This is where we saw some altered material exposed. Hi!
So I think around here I'm going to start coming back down.
Okay.
If you agree. So
Sure.
we can see all this.
Yes, please. I'm happy with that. How high above bottom are we?
About 40 meters.
So if there is chimney tiles, we might see it on this little step here. No, down a bit. Yeah, so you see the line that goes like this?
Yeah.
So if we could just pop down, take a quick look, and then we can...
I mean, I can go along the bottom the whole time if you want.
Can we just start going to the bottom at that little area there?
Sure.
We don't need to actually stop to look at anything, but I just want to see if there's chimney tiles that we know we look at them all.
Absolutely.
Thank you. Yeah, so we know that they're chimneys. We just don't know if there's anything actively venting. If we see something that's not been sampled that's actively venting, like as soon as we get to that, I'm sure Dave is going to come in and want to survey around. I mean, we've made such good time.
So I guess Doug will probably want the boat to end up if they're on that heading like here.
So if anyone's just joining us right now, we are heading upslope. We are off bottom by 50 or 60 meters because we want to go fast, and it's a steep slope, so it's a bit easier to go fast when we're up. We're heading to an area of hydrothermal activity. We know that there's chimneys. We've seen some active vents, but we haven't surveyed the whole field. So we're going to be crossing the field and seeing kind of what the extent of it is, and if there are any vents that we haven't sampled. And there's interest in looking at diffuse venting, which is kind of the lower temperature leaky warm fluids rather than the really high temperature black smoker chimneys, because animals prefer the warm fluids. They don't want to get boiled alive. So it's very interesting to look at, especially microbial communities living in diffuse flows. We'll be collecting a lot of samples, I'm sure, and we are getting somewhere interesting, so thank you for your patience. We're just transiting right now. We are making good time. We've gone from a depth of about 4,400 meters below sea level to now we're at 4,071. Your depth reading is a little bit off, maybe 70 or 80 meters deeper than the actual depth. So we are not off bottom yet. It is 20 minutes after 9 a.m. ship time, and we will be diving until about noon. So 2.5 more hours after we get to the interesting site, we will be sampling like crazy and hoping our samplers all work today. Where we had been diving earlier, it's kind of a big scarp or cliff in the wall where a landslide originated from. And in this area with this landslide scarp, we have very strong indication in the water column that there is venting nearby. In the bathymetry, we saw some kind of lumpiness that we thought maybe those are small chimneys. When we got there, we saw some really cool geology, but we didn't find any signs of where those fluids are coming from. We went downslope to the bottom of the axial valley to sample a piece of lava. We were hoping it would be young, but they look very old instead. So as we're going, we are testing hypotheses, and we are learning more as we're making new observations. So we are heading to chimneys. Chimneys are coming, I promise. I'm looking at this some more, and it kind of looks, I don't know if I'm imagining it, but it kind of looks like you can still see something at least coming up.
Yeah. Do you think that like little spiral structure is?
I don't know. What it was. Maybe indurated sediments. So, I mean, if you're going to fracture talus, do you want to cement it first at least? This would be interesting to see. Playing a game looking at the bathymetry called What Is That? Is it a volcanic feature? Is it hydrothermal chimney? Is it a broken piece of debris? Sometimes we don't know until we get there and take a look. We are meeting up with the venting areas that we were at the previous dive. We didn't get all the way to the edge of the vent field, so we are approaching it from a different angle. So we're going to see exactly where venting is happening, how large this footprint of venting is on the seafloor. We're going to see if there's active chimneys that we didn't see on the last dive. Preferably, I guess the fluids people would prefer to sample something new. So they sampled 2 chimneys at this site yesterday when I left, right? But not the third one.
All I know is we went to that one twice.
Okay.
The one that we booked.
Yeah, so that was Black Smoker 2.
Yeah, because that was really easy to see.
And
That
Black
was the only one I was there for. So.
Do we remember if it was waypoint 6 that was a smoker?
Well, the big one was like around here. I wanna say.
Yeah.
Remember that really big
Yeah,
fellow?
yeah. It was the leftmost of these.
Yeah, we didn't sample that when I was here, but I might have been out of the zone. We could have to do that.
No, I have the dive map. I'm gonna go grab it since we're coming back to this area.
They definitely want to hit this stuff on the way up.
Okay, so looking at my map, just in case Dave is here, they sampled this one, and they sampled this one. This little extension is inactive, and this is just a bunch of talus. And there was one more black smoker partly up this hill, right around here. That would be, not black smoker 2, but another waypoint on there.
Black smoker 5?
Can you
Is that the big one?
move it that way?
It's right here, it's on the screen.
Yeah, that one is the big one.
So we didn't go to these yet?
No, we haven't seen those at all. So Black Smoker 4 didn't get sampled, and then the one in the top left, Black Smoker 3 didn't get sampled, but 5 and 2 did. Okay. I don't know if that matters to them or not. We'll find out. But some of these little peaks on the side do look... Oh, can we lower down a little bit here? Do look promising.
I'll have to slow down a little bit if that's all right, once we get down there.
Yeah, if you can pop down and then go back up if you want. Okay, our current location is 180 meters from the start of where we see clear chimney structures on the bathymetry. We are getting close. We are heading to the northwest. So we're just downslope of a very large vent field where we have at least 4 areas of black smoke. In one area there was several large chimneys.
Melissa,
Yes?
Julie just sent a message in the chat.
Yes?
She said, could someone tell Melissa that for good diffuse fluids, the sites with shrimp are better? Some of the smokers we saw didn't have shrimp, so that usually means there isn't any diffuse fluid leaking.
Oh, sorry, that's on Slack. Yeah, I can see it here. Sites with shrimp are better for diffuse. Okay. That's a nice little fluid indicator, is the shrimp. The warm shrimp bass. Okay, I don't see any sulfide talus, so we can jump up. So we're not at the vent site yet. We're coming up the hill. What we see is a lot of debris flow. It'll be interesting to see if we can see blocks of cemented talus or debris. Okay, I'm seeing if there's any other questions. So yeah, we will look for diffuse fluids for the bio team. By the time we get to the vent site, Dave Butterfield will be taking over and probably focusing on trying to get his high temperature fluid sample working. We're not going to a totally new area, but we are seeing part of this vent field that we haven't been to. So there's some area of chimneys. I can tell you the distance of it. So, oops. So the area where there's chimney structures that we haven't surveyed is 90 meters by 55 meters in size. So it's not a huge area, but also not super tiny. And there's some pretty large bumps. I see pillows. Do you see pillows? Am I making this up? So we have a lot of old lava flows that happened somewhere way above us and fell down this landslide scarp. These are not lava flows in place. We tend to see the debris a lot easier when maybe it is in place. Wait a minute. How much of this is talus? We're looking to see if there's any indication of like a coherent outcrop, but this just looks like talus so far. And we tend to see the blocky debris material when the slope is particularly steep. So again, big landslide. We're moving up it quickly. We don't need to stop. We're doing fast geology survey. It's good to know that we've seen pretty much just volcanic material all along this. That tells us something about the nature of the material above us. Okay. Other questions or comments? Greetings from Australia. Hi, Australia. What time is it there? It's currently 9:30 a.m. ship time. Yes, so there is a hypothesis that we have this nice long area where we have chimneys forming, and then we have this big landslide scarp. So is the landslide scarp old and then venting happened after? Or did the venting happen and then the landslide scarp kind of tore through and knocked some chimneys down slope? It's not going to be an easy question to answer. What we have seen is a lot of cemented talus near the vents. The vents look like they're kind of creeping on to this landslide debris, but it's a pretty abrupt ending to the chimneys. It doesn't mean necessarily that they were knocked down by the debris. It could just be that there was a big permeability contrast. What are you looking at? What do you want? Sorry, was there a request? Okay, sorry, I thought a biologist wanted to see something. Okay. So yeah, we did see some really cool vents on the last two dives. Last dive? I can't remember. So with our fluid sampler, we have some different people who are going to be looking at the fluids, including our microbiologist, Julie Huber's may still be on the chat, where they will collect some material and look at the RNA, the environmental signature of whatever microbes are living there in those fluids, which is pretty cool. That's a little coral. If we don't move up so quickly, then we don't have time to sample though. Okay, we are closing in. We are currently 115 meters below where there's chimneys. As we get closer, we may see broken chimneys. I think there's probably 1 or 2 more active chimneys that we didn't see. Using my clairvoyant powers of chimney detection. It's amazing that we're on such a steep slope and there's still sediment.
Yeah, it's very different than the last dive still.
Yeah. Getting closer. Still no chimney debris, but maybe it's kind of moving down that little trough that's more to the north of us.
I think you might have to have a little bit more of the south. I think you might have to have their waypoint a little bit more to the south.
I'm just gonna stop. That was the yellow one's you.
Who's gonna stop it?
Okay, there is a question about biology, something about questions for the RNA. Yes, so right now our microbiologists on the ship are in bed. We have an onshore collaborator, Julie Huber, very well-known microbiologist who maybe is on the chat still, who can explain it. As a lowly geologist, I have no idea how to explain it, even though they've explained it to me. So when someone's around who can explain it, we'll definitely get them to. On the last dive, we had Sabrina, PhD student, give a really cool explanation of it too. What?
Just Julie's Slack.
I just asked if you'd seen Julie's.
Yeah, I just saw
Slack
that.
comment. Okay.
I'm sure Dave is going to come and point out, but when he comes, like we have sampled that one, there's a chimney there and a chimney there that are active and not sampled. Does he want a survey or just go straight to a known chimney?
I think we want to pass through the ones we haven't seen yet.
Yeah, so
And
right
just-
now our track takes us through this side. I think that this, you might just want to go that way.
My suggestion was we should look through all of those and just know what's active and what's not active, and then go whatever is most.
So these ones here were inactive. This was all debris, and none of these were surveyed. But these guys look a little bit more peaky down
Yeah.
there. Yeah, we're right below them, but I think that the chimney talus is probably going down this way, and we're kind of coming up this way. We're seeing lots of talus, which is cool. Getting a bit more interesting rugged topography now. Getting close. Okay, so the goal is to kind of go more straight north from where we are to where to where your hand is right there, and then survey over top of them. Yep. So if we can just make a turn and go right to that hand.
Alright, I think we'll probably stop about there if you want to go.
Bridge, are we?
We are 35 meters away from the start of the interpreted chimneys.
Copy that, stopping. Thank you.
If there's anyone on the fluids team who wants to come into the control room, we're almost there. Or we can survey and tell you when there's a black smoker chimney. Okay, we might start getting chimney talus now because we're right below it. Some indurated crust. We're right below it. The crust, you can see the crust. Oh, look, chimneys.
Yeah, we're there.
We're at the chimney site. We have some little tiny chimneys. Chimlets. Okay, let's go on top of them and then follow the trend to the west-southwest.
Sure.
We're looking for the active ones quickly. We're not going to stop to look at these ones unless we see any sign of biology or diffuse venting.
I keep this sort of a view and just.
That's great. Yeah, that's perfect. Crab walk it. So these are pretty small. They're inactive, but they are intact. Okay, we also want to kind of survey quickly too here. We see some iron oxide. These guys look old. They've been falling down for a while. Ooh, that's an ugly looking spire. Ugh. All of the material underneath it looks like we have some iron oxide in this sediment. Some big blocks of cemented material. That's what we've seen previously. All these little lumps so far inactive. We're on the smallest of the small lumps though, so. Oh yeah, timber. Alright. Does he want to wait till we find something hot and active, or does he want to come in now? We're just kind of crab walking to the left here.
I think that's what we want to do. Let's just look through these and.
Can we go up a little bit more up slope?
I'm not actually sure where he is right now. So I can run up to his room.
Okay, how about we just look up slope instead of going all the way up? Do you mind?
No.
Okay. It's kind of up and to the left, I think, is where we want to go. More of this crusty material. Little chimneys sticking up. All dead ones.
Alright, I'll go find him. Bring him down.
Okay. We're almost there.
Carrying on to the left. Following this ridge.
Ooh, my prediction of finding active venting down here might not be good, but I see some yellow bacterial matting. For the diffuse stuff, we want shrimp and a chimney nearby. Wow, that's a pretty big block. That's probably all sulfide. Nice, okay, dead chimney. Big tall ones.
Carrying on to the left some more.
Some broken talus, more chimney mound stuff. We're almost at the end over here. There's some primary iron oxide there probably, so warm fluids leaking out and precipitating iron oxide along fractures, or just the crust.
I feel like the visibility's gone down a little bit too, maybe because of the smoke.
Yeah, it's just where is the smoke? Okay, we'll just go ahead and see what that mound is and then kind of loop around to the next one up there.
You want to go that one basically facing right, that's like a sharp point.
Yes, please.
We'll work our way
This is the excitement of finding a field, and we're on the periphery of it, where there's some old dead chimneys, but at any moment we could stumble across something that's still active. Okay, let's head. Can I move your mouse to the next spot to go to? It's, I mean, it's pretty obvious, but this guy right here, head right for the big guy here.
Okay. Do you want to check out that one in front of you?
Oh, is it still in front of us?
Yeah, you see on the sonar, I got something
Okay,
that I
let's.
can definitely not do if you don't want to.
Oh, let's see it. I think that we're. Yeah, it's hard to see where we are with the big ROV icon there. More crusty. The fish. Iron oxide sediment.
Alright, I'm going to turn towards the other guy then, because this is just not that.
Nothing. Nope. Nothing over here. We are ruling out areas. Zeroing in though, there's a little chimney there. Well, that's that little baby one. Okay. Another little baby one, okay. Look around. Does he want to go to a chimney he hasn't sampled? There's two that we found that he didn't sample.
That's a good bet. Joe is going to bring him down.
Okay. We can pull up some pictures if he has. So we sampled that one, and there's two that we didn't. I don't remember anything about them now though, but we can pull them up.
There was one with more flat ground. It looked a little bit weaker.
Yeah, I think that's
second
probably
last
this one. Yeah, I think this one is a decent size.
Yeah.
But there were also like 3 or 4 big chimneys at this site, so I don't know if he only sampled one of the big chimneys, whether or not he wants to sample more of them. Okay, more intact dead chimneys along this feature here. Yeah, I guess he'll be here soon.
You guys will slide over this to the right.
Yes, please. Just a bunch of.
More slides.
Yeah, there's some broken talus. Pretty steep slope. So this is going to be all talus along this slope. So can you head? Actually, let's just go right to this big chimney over here. Straight to the northwest. Yeah, so I see that this is a pretty big scarp, and anything here is just going to be broken talus. I mean, we could like maybe go over here first, and then.
You do want to go there?
Just a little bit to the north, and then zoom.
Sure, Doug, you can creep along towards me if you want. I don't think we're coming back down this way.
No, there's nothing to see. Sadly.
Ready to RV?
RV, bring us an update.
Yes, please. We're gonna go bring you over there and probably stop you for a little while and do some sampling.
Okay, understood. I'll get in the move to that position.
Thank you.
Just had some coffee today.
Okay, just lumpy talus.
Oh, not the top.
No, we're not. Okay. We can look maybe. Ooh, zoom. Oh, big slope.
I do, right? past that. It's just
Yeah, I think we are. I think we're coming up to the top there, but that's okay. We just climb and then go left. Oops, sorry, I just grabbed your mouse like it was mine. Alright, so we're seeing a lot of broken chimney debris, some iron oxide staining in the sediment. We are now heading 45 meters to large active chimneys. Oh, we have his phone number for his room. It's
We're gonna wait till we get to.
We're 40 meters
We're coming
away.
up on NCS and sample. Yeah.
Okay. Give them a call.
The numbers here. 5. Do we press 7 first? I'm doing it wrong.
Melissa, you're getting a hello from chat.
How do we call a room number?
one and then the room number.
1 and then the room number? Yeah. Okay, that's not working. We're gonna have to go to his room.
I'll go knock on this door.
Okay. Sorry. Hi from Geomar. Hi Geomar. Hi Philip.
He did say something was wrong with his phone.
Yeah, I think so. That's okay. So we've passed these inactive chimneys before. We're coming up to some huge fires. The depth that you're seeing on your screen is a little bit deeper than what we're actually at. We are at 3,965 meters below sea level. We have uncovered the extent of this vent field, at least along the length of it, and a huge amount of it is inactive, but we have found a few spots with some nice, beautiful big chimneys, crazy animals. And we have just over 2 hours left in this dive where we want to go back and collect some more fluids from some of the big chimneys that we saw before. Hello, Germany. Guten Tag.
Oh, starting to see some critters. This probably will be the whopper.
Yeah, it's the 3 whoppers.
Well, we've been to this one.
Yeah, this is where the big chimneys from before were, but there were like 3 spires. So he to send one of the other 3.
This is we're on the other side.
I think it was on that screen, Black Smoker 4, which is just to the west. It's on your screen right here. And then this one up here that's at 8.6. So there's, if we don't sample right here, then it's not too far to the west. We're almost in the red circle of death. Am I gonna explode?
You should be moving more to the south now. So this was inactive?
No, we see smoke right there.
Oh yeah, yeah.
Venting, we have
this
venting.
One. This one too. A lot on the other
Wow,
side.
yeah.
Oh wow, is that just, yeah, that's a little shrimp colony back here.
Shrimp colony, we have smoke. It looks so different coming from the backside.
It does. It does. If we hadn't taken a waypoint, I would totally think this is a different one.
Yeah.
Okay.
Do we remember where he sampled from? Anybody?
Yeah, he sampled from lower down. They knocked over a chimney kind of in between these two towers.
In between these two, okay. Can we move further to the left?
And can we keep the lasers on if possible?
Yep, I think they're on right now, but let me double check for you.
Oh yeah, they are.
They're
Never
on
mind,
here.
couldn't see them.
Yep.
So this is kind of the start of an area of venting that extends about 500 meters to the northwest of us. In this area there's a few black smokers, and then there's a large area where there are, oh that's nice. Yeah, let's take a close look right in here and we'll see what he wants to do when he arrives. You can just perch.
Sure, you want me to go ahead and like get up against it? Like
Let's just float for a second here.
He's coming down.
Okay, we can maneuver easily if we just float.
Sure. That diffuse is coming from way down.
Yeah. So, comment from Julie is that the diffuse flow we're interested in is ones covered by shrimp.
Were there any on the lower field that were?
Nothing, all
yeah,
dead.
that was all the upper field. Right?
Yeah. So we've kind of seen the extent of it.
There's some shrimp. A lot.
No, we want a shrimp bath, but it's okay. Dave will come and make some calls about where he wants to go. Okay. Whether or not he wants to do these structures or go back to Black Smoker 4. Do you remember the temperature? Did they measure the temperature here?
They definitely did. We did with like the HFS.
Okay.
And it was like 137 or something.
Okay. Yeah. The other side it was 338?
Yeah.
Something like that. Okay. Hello, anyone who's waking up and joining us. It is about 10 a.m. ship time. We've got about 2 hours left. We've come back to a site where we have found venting on the last dive because we didn't have that much time to sample it. We're not going to have that much time on this dive to sample it. Today our dive started quite a lot further to the south, about 800 meters to 1 kilometer to the south of us, where we had a very strong signature in the water column for venting. It was indicated by the ORP, oxidation reduction potential. The signature was higher than it was here. But on our detailed bathymetry, our high resolution bathymetry, we didn't really see anything that looked like tall chimneys. We saw some ruggedness that we thought maybe they're small chimneys or chimney boulders. So we spent the first part of the dive exploring in that area without finding any sign of fluid flow. What we did see is a very steep scarp where the landslide, oh that's some nice shrimp. So we saw a very steep scarp that exposed the subsea floor. So along this scarp, that's where the big landslide had originated from. Oh, very cool. And we saw sheeted dikes, we saw alteration along the contacts between sheeted dikes, and the sheeted dikes occur in the subsea floor, kind of very close to the seafloor. And then below that, we saw some massive gabbro intrusions, so we got to see a pretty cool crustal section and see how hydrothermal fluids are moving through that crustal section, and we sampled some altered rocks and some less altered rocks. Very cool geology. No venting though. Then we took an excursion to the bottom of the axial floor near this fault. So we're kind of right on the scarp of the axial bounding fault, a very deep fault. and we thought that we might find young lavas. We did find lavas, but they did not look super young, but we took a sample anyway. And now we have come back to this area. We just surveyed a little bit to the south of it that we hadn't seen before, hoping to find another black smoker, but we only found inactive things. Good morning!
Good morning.
Do you want to, so this is the big chimneys in the south, where you have sampled somewhere around here. I didn't know if you wanted to sample there. You've also sampled there. We have a smoker chimney here and a bigger smoker chimney here that you haven't sampled. So we just kind of paused here to see what you wanted to do.
Okay. Well, let's go to one I think that we haven't sampled yet.
Okay. Can we go to not the one straight to the west? I think that was a bit small, but the one that's called Black Smoker 3? Is that 3? To the northwest of us.
Trees right here.
That one, yeah.
Okay, right next to waypoint 06.
Yeah, pretty much at waypoint 6. Yeah. Do you want this spot?
Sure. That was my coffee.
Okay. I think we're gonna have to move this over.
That was a nice fast moving dive, huh?
We didn't
Yeah,
see
no,
the chimney
they
palace
flew really
for
fast.
Yeah.
We're setting speed records and depth records.
That's good.
So I'm going to pass this over to our chief scientist cruise leader, David Butterfield. And we're just going to switch places, and we are headed to a chimney that we haven't sampled, that we have observed only. I think we probably picked up a rock there. She confirmed if we picked up a rock there.
There? Yes.
Yeah, we picked up rocks everywhere. Okay.
Straight to canal.
You got everybody on the bio team that you need.
We see where the stars do like pop up, and if we see gas drops,
What's that one to the left there? Black smoker. Is it
That was a black smoker, but it was
okay, great.
yeah.
I just want to make sure I'm not going to knock him over with my bill.
If it's alright with you, I think I might go with that.
Something that is logged as movements, like which ones that comes in. Yeah, we are not going to.
Okay.
So I just don't know the best way. The rocks are pretty obvious what they are. So we'll lay them out. And I think
Jeff also might.
they put, I'm not sure, or there was a thought the microbiology teacher. We'll see. I told him he could see, but I'm not positive. But I have not let my Josh these days today, like yesterday.
There's the smoker.
Is that fellow that's 4?
That is a smoker that we have not sampled. That is 4, and there is one more to the northwest of us.
Alright, so I'm going to keep rolling then to that one.
It's up to not up to me.
Sure. Let's have a little zoom on this guy here for a second. Oh, that's a lot coming out of a small smoker.
It's a baby.
What?
Okay, small but lots of output. But let's go on over to the big one.
Okay. Alright, I'm going to carry on then.
Yep.
It's not a huge one though. Just
Not huge.
for
Okay.
expectations.
That's okay.
I'm going to give this guy a wide berth so I don't possibly knock him. Smokers are our friends.
There's.
I'm not doing anything.
It's good to know how much ground we can cover in a single dive.
Yeah, you've already done what, 2 kilometers? More than 2 kilometers? Oh, that's a good view of all the broken chimney spires.
Rainbow colored.
Yeah. It's been a very busy week here. We're getting towards the end of our time at the E-mark area, as it's called, Eastern Mid-Atlantic Ridge Kane Fracture Zone intersection. This is our second dive on the active hydrothermal area that we found. We started the dive looking for hydrothermal vents in an area where the plume was very strong, but there wasn't anything that we found there. So it could be that the plume was just blowing from this area down that way. We're not sure about that. We'll see what the onboard mapper instrument has to say when we get that back.
About a kilometer is what we covered.
Oh, okay. Kilometer total.
Coming up all the time, but struck the low delta there. Hey, okay.
So, story on the starboard arm is not working at all, or is...
Jaw doesn't close.
Okay. So we'll be working with the port arm this time.
I can give you the exact point.
Can you dig in on your map too? Because I don't have that waypoint on mine, though. What I'm trying to achieve. It's actually being behind it.
Then that's just where the marker was put, so it could be off there.
I think you should be able to see it. That is that one. Yeah, you're backing up.
There's... Well, there was something to the left, but...
On the sonar?
A little bit, yeah, I don't know if that's too far away or...
You read them on it.
Pretty much directly over, I'm coming down. And then I'll kind of look both ways.
See anything behind you?
And to the right.
We have been at Smoker 2.
See some sort of little sea life over there, maybe. That big started with that. You want to go see that?
Something there. Yeah, there's a vent right there. It's small.
It's a little baby.
Oh, it's a baby one? Did we already knock it over or something?
No, it doesn't look like it.
Okay.
Doesn't
So
look like we've been there,
The
but we
last
can.
one that you saw had two big ones, and I'm pretty confident that we surveyed the whole rest of it. So those are
Okay.
I think
What is this?
Julie was mentioning that she was interested in an area with snails for diffuse fields.
Okay. This one doesn't have a whole lot of animals on it. It's got one black smoker. We've been to Smoker 2, which is pretty big and has a lot of animals.
5 was the one we were at when we came in here.
Okay.
4 was that kind of skinny one, I think.
Mm-hmm.
What do you think? Do you want to sample here or look for something else? Or? I think 2's the one we broke off yesterday and we got the probe down inside.
Yeah.
Yeah.
How do you?
Yeah, 2 was the first one that we found when we got on this site.
Okay. How do you think it's going to be picking up a gas tight with only one manipulator? I mean, we've got.
Like a handheld?
Yeah.
That's the one we would normally use anyway.
Okay.
I would think. So
We've got the 3 on the manifold also. You're there tomorrow? Okay. What do you think? Would you like to try for one here? Or?
You're not trying with your wand?
Yeah, I will. Yes.
Okay.
We could do a pretty quick sample right here.
Yeah. I would definitely want to sample from here. Question is more like we can use one that is connected to your system.
Yeah, we can do that, right?
Yeah.
No problem. Okay, let's try it since it's a pretty easy. Looks like a pretty easy setup. No.
Okay.
Yes.
Do you think we could also take a filter here?
We can't filter really hot water directly.
Okay.
Because it'll melt the valve.
Gotcha.
So we can take a filtered water sample, but we can't pump a large volume of hot water through the valve.
Oh, do you know what kind of anemones those are? You had like left the room and punched. Why too tired to take attention?
So if I come in right here, you think you'll be able to get it? First.
I have to get
Is that
the wand first.
I'm probably just going to try and rest the porch on this. Just going to turn so it's not blowing into our head directly.
I have the impression that this one is just hasn't grown as much. Might be slightly newer than some of the other vents, but I can't tell for sure if it's just but it's in a different stage. Doesn't have as many animals on it. Got some diffuse flow there. Yeah. Okay. Well, you got stuff behind you? Okay.
Up here. Close to it.
I gotta come across the view.
And we're gonna do the HFS one, is that right?
Yes.
I'm not sure you'll be able to reach that.
I have 1,000 foot shot.
Might be too far away from that side, or what?
It's just too high, I think. So
Too high?
I can come a little higher.
Yeah.
Yeah, let me try to set you up a little better.
Just.
That looks like super problem.
Right there.
I hear talk about the temperature probe. Does it make any difference to your setup if we try the high T probe first, or can you reach that?
A little closer, but we'll see how it goes.
Okay.
I need to actually come around this way.
Oh, yeah.
And you want to set up with the port side, whatever you call those. You call your forward rails. Okay, just the rail. You want that on there rather than the starboard.
If the starboard was on, I didn't play it too far away.
Okay.
But I'm gonna try and brace the Portuguese.
Okay.
I mean, that's coming from the starboard side.
Sampler is, yeah.
Yeah, I can do the starboard side if you want. I just think
No,
you're gonna be pretty far then.
Well, I'd have to grab it where it is regardless, and then
Yeah.
bring it up. I mean, I don't know how much we got.
There's a lot of diffuse coming out of here too.
Mm-hmm.
So I gotta watch out, we don't cook ourselves. Brace this guy. Smoke.
Okay. Okay. Okay.
See,
Good.
I can put the starting rail on it, but I really doubt you're gonna be able to use it.
Or arm. Yeah, this is the thing. The starboard rail on that, I don't know if we can reach the port arm. The port arm on that, I don't know if we can reach the close that far. That's not that done now. Which we have on. And like getting the port arm that high up, that far over, is so unlikely. Getting that hose all the way to the other side is, I don't know the answer to
This will be the first time we've used the port side arm to do the fluid sampler, which is located on the starboard side. So we're trying to balance the length of the hose with the reach of the arm. So we're setting up with using the middle of the front porch to stabilize.
Sorry, guys. This is gonna be a party in here now.
Stay right there. She definitely do. That's a big ask.
Okay. All right. What do you think?
Yeah, that's doable.
Okay.
We're okay.
It's not barbecue.
What's that?
It's not barbecue.
Okay, we're set up with the smoker right front and center. Now we'll see how using the opposite arm works. Might be okay. Make sure everything's working on the sampler here.
3790. But the map of the last
8.6. I think it is smoker 3. So we're going to try taking just a couple chemistry samples here, and then we'll move over to one of the bigger chimneys with lots of animals on it and try to get some samples in some diffuse flow areas. Highest priority for that is taking a large volume sample, 4 liter bag sample.
highest signal that they got.
Okay, got the sampler out.
Okay, do me a favor on the clock right here. You just look to the left, make sure that's safe.
I think you're gonna want to go like this. Bring your elbow in and bring the pitch up so that you're not in the smoke so much. You know what I mean? Much straighter.
Like this?
Yeah. And just keep going like that.
I'll be able to get this in there if I do that.
I think you will, because you'll rotate it, right? Remember, if you rotate it, it's gonna get flat. Right. Keep going another way.
And flip it all the way over.
Keep going, keep going, keep going, keep going, keep going.
There's a
Something like that. And then
titanium ball joint in there that swivels around.
if you back your arm up, we should be able to see the tip.
I see like
Or do a little more elbow and a little more adjust kind of thing. Yeah, I think it's yeah. That's probably not the worst angle, huh? Those hoses and cables coming out of there, that's okay if we get in the smoke tank?
Yes, they should be okay in the smoke. That's
They can be logging your sampling.
okay.
Then can call out the numbers and everything.
Okay, which sample number are we up to now?
we are on sample.
Sample
You
9?
can log it from my computer if you want. Yep.
And then you might be able to come in at the base where we can see it, you know what I mean?
I just didn't know how low it was, so where the top was. So that was kind of
And that's sample sheets.
Okay.
Well, we got a little. Our temperature sensor's not going to be accurate. T1.
Alright, there we go.
So we'll be going by how warm it gets back at the manifold on T2 and okay. Oh, that went that went way up to 140 right away. So I'd say we're in a pretty good spot there.
Happy with that?
Hang on a second. Pump is turning. We are getting some smoke coming out the. We're getting smoke out the back yet.
Starting to change the color in there, yeah.
That looks like a good spot. We're getting a. I think so, yeah. Okay, so we've got the entire sampler sitting here full. I mean empty. So I don't believe the T1 temperature, but back at T2 it's getting quite warm, 51. So we'll do a high T probe afterwards. This is probably already around 300 degrees at the intake.
The smoke is definitely coming out.
Oh yeah, it's
Looking good on the flash pump.
Uh-huh. Cecile, do we have which ones have filters on the bags? Okay. So would you like some filtered particles from this on on that one?
We can try. I think should we try first without filter because it fades.
Okay. So let's try one of the bags. We'll just go for number 23.
Bag 23. You're logging it? Oh, if you want, you can sit there, yeah.
So I had to come around to.
Yes, please.
Oh, okay. Yep. Mm-hmm.
And then I just got the porch light up, that's all that. And we got yours are just,
yeah.
Okay, we are. Oh, you've got your computer for logging. Okay.
The sample numbers. Yeah, then log that.
Our first sample number is 9. So bag 23 is waiting. Get started. And I guess we might as well do it. It looks like it's pretty warm in the back. As long as it doesn't start up. I think it's moved. Hang on a second. temperature's going down. It's slightly out. That's going up. One. That looks.
Did it go back down?
Yeah, it went way up and now it's going down a bit.
Perfect. And it will be 09 and then it will be 3. Yeah. Just so you can see. Yes.
Yeah, don't freeze it, done it. Yeah, I put it in there and it jumps out. Just a little more chance.
Okay. It's going up. That's high.
Oh yeah. So T1 is reacting.
Back down a little. It does. It's just not accurate, but it does tell us if it's going up and down. That was even the hottest that you had just a second ago.
Yeah. All right, so I've got an idea where it is if I have a hold in there.
Okay, it's
I'm gonna try and reach over here.
going down at the moment.
Let me move those up.
It's low at the moment.
Yeah, it's okay.
Cooling off.
Now we keep seeing those little
Coming up. 70, 100, going up fast. I think you're in a good spot.
No, this
Break the side off. See if it stays, but just crumbling as it's trying to get in.
It's still hot. It's good. It's good and hot right there. Breaking again. Still hot. Okay, that's still hot. We're waiting for the back end to heat up. Back end's coming up. Let's try a sample now. Going.
Okay.
So starting at 1333 on 324. 3. We got S0496 09 or HFS 09 and B23. Temperature looks good. Do we see any flow coming?
Yeah,
Yes. Great. Okay. Oh, it even moved the wheel. Good. Great flow on the sample pump. Taking a 450 ml sample here.
Did HT probes it?
We haven't done that yet.
Oh, okay.
This is the harder part. I was going to do this and then we'll get a temperature measurement afterwards. Okay, that one's going well. Goal is to sample here and then move over to the big chimney, one of them.
Yeah.
If you want, we can take a gas tight immediately after this if you want.
Yep.
Whatever prep you got to do for getting the gas tights ready to go. Something about checking the gain.
Yeah.
You check with her.
For the ascent afterwards, I would like to take the boundaries on.
Up to 275 mils now. Got a little bit of variation in the temperature, but pretty good.
What's the starboard is like free?
So
one should be. Three, 4, and 5. Yeah.
Still seeing good flow. That should be a good full sample.
The one closest to us.
That one I'm pretty sure is starboard. Right, that's what it's labeled as. Yeah. Starboard.
After this, we'll do a filtered bag sample and a gas tight.
But do you really want us watching that?
Yeah, that's since
Like you get that sort of-
Just so that's
Okay, we're at volume for that one. Closing that. You got the, I mean, the T1 max is not real. But,
Yeah, no one.
but you can note that the T2 was around 40 to 50.
Okay.
T2. Samara, are you ready for a gas tank?
Yes.
Okay. Let's.
That's gonna be. Oh, now I'm not sure if it's GT, HFS, or HFS, GT, I think.
Do you want me to say?
And it will be gas type 16.
It's GTHFS.
Oh, sorry, GT,
No,
HFS.
it's okay, it doesn't matter.
Yeah, 10. So GTHFS 10 / gas type 16.
Okay, you're
Do you want me to log it? Yeah, sure. Sorry.
ready to fire?
Not yet.
Not yet.
Are you done with your sample?
Yes.
Yeah. Oh, okay.
We finished one. We'll.
Okay, then we can fire.
Ready?
Yeah. Just get on to fire, out.
We did not get the pump shut off.
No, okay. Sometimes it does and sometimes
So
it doesn't.
that's true.
So-
It doesn't always do it.
Yeah.
Okay, that's for
Okay, thank you.
Okay, now we're gonna try filtered bag 16 coming up.
Just a second.
Yep. Just moving the valve.
Gas type 16, tell me.
Yeah.
What was the GT number at the end of that sample?
16.
16.
Sorry for being confused.
No,
I
it's
think
fine.
I'm still half asleep.
No, it's okay. I am also, so it's you know. Do you know the port valve or we don't care? Oh no, I need to put something. Do you know the port valve?
It was 2, the first one, that one.
Okay.
For your input, T2 was 38 degrees when we took that.
Okay.
That's probably more interesting than T1, which is not right.
I will write it down when we do the pro.
Okay.
Okay, ready for bag 16.
Yeah, whatever you want.
Starting now.
Okay.
A lot of smoke coming over the flow indicators, so I can't really tell what's happening on that yet. T2 hanging in there, 36. This should be a filtered bag, so it's collecting particles on a filter before we, as we pull the water in.
If I'm not confused.
Yeah, I think that's correct. Yeah.
Yeah, these are
Can you see water coming out from the sample pump? Oh, there's a lot of smoke, so it's difficult. That stuff was the. Well, we could have put the nozzle in here as well.
Doug, if you happen to see any shimmering coming out of the one, let me know. I haven't seen it.
Pardon? Are other people's scores just built on? Yes.
Too much smoke to tell so far.
Yeah.
Oh, we might need to move it a bit, but not on this sample.
We could put the nozzle right on the front and see. Maybe it's too little. I have no idea of the scale.
Yeah.
Taking multiple samples gives us a better chance at getting an end member of the chemistry.
I can see flow in the
Okay,
just
good.
in the upper right there, right above the bowl. You can see it.
Yeah,
Oh, yeah.
great. Okay, that's good.
This is good.
S0496, HFS 11, BF16, T2. Actually, temperature's pretty good still. It's fluctuating, but you can't really avoid that.
Okay. Between 30 and 50. That's what I put. On T1.
Okay.
So far. Because it went up to 45.
I think we probably have it. Probably don't need to take it. I think we'll stop after this one, maybe. Just because we need to get to the big chimney, and setting up there will probably take a while. We could take one more quick one if we want, but try a piston.
Well, yeah, that's good.
Maybe
But
number
let's take
high number.
P4 or P4 seem to be working. What happened? I'm pretty sure like the nozzle from the this is done? No, not yet.
Almost done. Okay, that's done.
Okay.
We could do 4 or, well, we haven't tried some of those higher numbers yet, but
Oh, we did, but in the previous times. But P4 worked fine.
all right, try P4.
Did you try it? Okay. No, I'm on it.
Going to piston 4.
This is sample 12,
12,
right? Yeah.
yes.
P4. Oh, but you haven't started, right? It's
I'm moving the valve.
Yeah.
Yeah. Temperature went back up, so
What I meant is that I really think that the two first nozzles from P1 and P2, you need to stop the pump so that the valve can actually suck the water in.
you think so? Yeah.
Yeah. I mean, the
We could
first
try
one.
that.
Yeah. I think that would be
Could
nice
also
just
turn
to-
it way down.
But for P4 it's not a problem, but P2 and P1 are very weak.
We can.
So I guess if we want to test this after this, that could be good to make, just to know that if we perform it like this, the cycle will be good.
Gonna do 700 here, starting now.
Alright.
Yeah.
Julie has a question, what the highest hydrogen you had for yesterday?
Oh.
T2 is up.
Yeah,
Seeing any
Yeah,
flow
you can
out
see it.
there?
You can see where the bolts are. You can see it.
Yeah. Okay, good. Good. Got all good indicators that the flow is working, and so we should have several good samples from this site. We'll finish up with this piston sample, and then we'll take a high T probe measurement, maybe another one down lower on this chimney. But I haven't heard interest from team biology or microbiology for getting us a diffuse sample here. They want something from the big chimney where there are shrimp. So if I don't hear anything to the contrary, we will quickly move over to the big chimney after this and take some samples there. You want another bottle?
Yeah, just
okay.
to be on the safe side.
And I'd
Okay.
like to try the piston 1 or 2. With
Oh, you do want to try that? Okay.
With, you fill it with the
Okay, with-
and then cut it or put it very low.
Okay. Like number 3.
60%?
There's more the one and the two that are usually very working fine. So
Okay.
I just want to try whether it works better or if it's just something else that I. Or we can do it in seawater if you just. It's up to you.
How's our time? What time do we have to be off the bottom? Does somebody have a handle on that?
What time do you have to be on deck?
By 1500.
Noon, okay.
1500.
So I'd say 11:30 the latest.
Really?
Well,
Okay.
we're at the same noon, I think. I'll double check.
We can do it in 3 hours. Would be close.
What time is it?
11:45.
4,000 meters.
Noon would be better if we can do that. Okay.
Better if we can do noon.
If possible, yeah. But we'll do what we need to be on time. We're pretty close to where we need to end up to be for the recovery.
Do the gas type. Yeah.
So it's 2 hours and 45 minutes or whatever.
HFS gas type, then that's big.
Where we are.
Can speed up the process.
And add another 20 some odd minutes or whatever. So, I mean,
Right.
All right, I texted him, but I'm done. I heard him say earlier noon. He's going.
Okay. But 2 hour 45 ascent plus recovery, 3 hours.
It's I guess the other question too would be like how much of a disaster is it if we're a little late? Like
It's the AUV just sits on the surface for a while.
But we can still
They
go.
don't like that, but it's not gonna.
Okay. Somebody might steal it that way.
Right. Yeah, I haven't seen any pirates out here.
It's kind of a bad neighborhood.
you never see it.
Knock on wood.
Okay. Okay. So we're trying to hurry up here and
okay,
doing a reasonable job.
I'm setting up for the next gas type then.
Okay, you ready for it?
Not yet.
Okay.
I want one more gas site that is connected to the center, and this time it would be the one in the center, and this is port 5.
Okay, 4 is done.
Okay. What was the end time? Oh, I can read
The
it.
yeah,
Okay.
7.
Okay, that's fine.
You can fire that whenever you're ready.
Yeah.
Just tell me when you fire it, please.
Yeah.
Port 5 is up to 60, so that should be good for you.
Okay, then. Am I looking at the right one? Yes. Okay, I'm ready.
You ready?
Yes.
Okay, fire it now.
Yeah.
T2 is good. 48.
Great. Okay, you can retract.
Retract.
Okay, it moved. Thanks. Did the pump go out? No. Okay.
It did not go off,
Okay. Well.
but still
It looks fine
still
there,
working.
Thanks.
And we want to do. So you said 1 is one you want to try?
Yeah, but with blocking the.
Turning off the flow.
Yeah.
Yeah. Moving to 1.
Okay, so I just. What's the port 5?
5. Port 5.
Okay. Got it.
I'm going to make this one a slightly lower volume just to speed it up.
Yep. Just let me know when you're ready. I'm ready to run.
Okay. Ready to go. Starting sample. At 1349. 1347 for that one.
P1, right?
Yeah, we do. Just want to see whether it works better.
The first time. Last time.
Okay, I forgot I got to turn this pump off. All right, here we go. Stopping that. And what do we got coming out?
See a little bit, but that one's not running.
Oh, that one. Yeah, we shut that off on
Yeah, that's
purpose.
Yeah, you can see a little bit coming out there.
Oh, you see? Okay. Yeah, there's a bit of
See
shimmering.
just a little bit on the outside of the connection.
Yeah.
The wheel is
It
all
looks
down.
like maybe it's picking up. Maybe.
So you're expecting to be here.
We have a theory that some of these pistons are a little harder to pull than the others, and if we turn the big pump off, it removes the suction force on that, so it lets them move the piston a little easier. Otherwise, they're working against the other pump.
I think you might be able now that it's picking up to put a bit of flow on the flush pump, like if you put it again.
A little bit, because it's not.
You can see it just waving, just
Yeah.
on the back side where that first screw is, just waving.
This will be fast, and we're not. Turn that up a little bit.
Because I've seen it by cleaning it. When I clean the rack, the first two nozzles just don't get. I'm sure the turn is too steep.
Okay, this one will be done in a minute. Well, less than a minute, just 15 seconds or so. We're going to go to 500.
Yeah, that's cool. I'm just gonna
T2 did drop down when we turned the pump off, as it does cool off, but we started off about 40.
the flush
Pump off.
and then turn it down.
Okay, that one is done. Okay, we can stow that HFS wand or hang on to it.
I want to hang on to it.
Yeah.
We're going to use that, correct?
Well, actually, no, we need to use the high T probe.
Next?
Yeah, right here, right here. So we don't want to move.
Alright.
So unfortunately, we're going to have to put that away.
Alright, the high top probe is going to be tricky.
Tricky to pick up.
Yeah, but we'll give it a shot. I appreciate that. It means a lot.
So you're going to reverse your rotation and etc. to put it back, or?
I'll cross that bridge.
Yeah. Fortunately, that hose is very, very flexible, and we can see the growth on the end of the nozzle there. Flushing the smoke out of the manifold right now.
I don't know if the wand's gonna make it.
Yeah, you don't want to smack your camera there.
Yeah. There you go. Be clear there, but yeah, nicely done. It's not in yet. Baby steps.
We have the nice new holster that Jason Williams designed. I think, didn't he? Yeah. And did you guys make it out here, or was it made on? It was made on shore.
The parts were made. We just assembled it up.
Uh huh.
Which is the most important.
Thank
part.
you.
Yeah.
Yeah, you guys get all the credit. Yes.
Make sure you tell Jason that.
Okay. You know, we made one at PML as well, so we have two versions of that out here. If you happen to break that one, we can try the PML version.
Oh,
A holster. We
Yeah,
built a flexible holster. Makes it easier to put it back in, and it doesn't, you know, make a hard metal contact.
I'm looking at it in the HD1. Oh, really? So that kind of when I froze it, just sat right there. Well, that's because you did it too. Beautiful job.
Nice.
Dave B,
Yes.
What's our off bottom time?
We're trying to verify that it's noon.
Okay.
So it was originally quoted at noon at a time that we were 300 to 400 meters deeper. So by coming back up here, we might have bought 15 or 20 minutes.
Awesome.
That depends on what they say, not what I say.
No, it's pretty much your call, isn't
I
it?
mean, I'm comfortable with,
Well,
with noon or a little later as well, but.
Well, we want on deck at 3:30 p.m.
Right. I mean, if that's like a hard time limit, then.
Yeah, 3:30.
You know what I mean?
That,
Like,
that's the target. So,
Yeah.
so what does that imply?
Noon is fine for 3:30.
noon is good for 3:30. Okay.
All right.
We got an hour and 3 minutes.
I can't fortune it.
Well, we've probably surveyed this already.
Just the gas tanks you gotta worry about. It's not really able to see anything.
Yep.
Line grab, gas type.
Yeah.
On a T-handle, like
Right here?
Before you leave.
dragging up the bridge.
Okay.
Might as well, if we only got an hour left, we haven't fired
Yeah.
on any of them.
Okay.
I'll bring it up.
You want to just get in the smoke and fire them?
That's all the way up, buddy.
Or do you care? Do you want to fire them right here, sitting next to it?
All the way up.
You wanna put it
I don't know if they can also.
like while we're moving?
Well, we only can't use, well, maybe we can. This- The starboard arm doesn't close, but they may be able to use it for that. We'll ask.
What?
I'm talking about firing in this game.
Yeah, we can probably do that.
You
I
don't
would
need
think
to
so.
close.
No, because we can just use one of the jaws, one of the parts of the jaw.
Okay.
So yeah, in the
It's kind of blowing right up into it, right here. So, okay. So 1 and
1 and 5 or
1 and 5.
6, whatever. it is.
Okay.
See it coming up, over that's the hand.
Chris, if you shoulder it down more and elbow out, will it hit you past those gas lights better?
So this is going to give you a starboard nip.
I'm so sorry, I ended up hitting you.
Okay, we're talking about how to keep things moving as quickly as possible. We've got a good set of chemistry samples right here. We're working on getting the high T probe out. It's more difficult with this arm.
I think we should, if we're really going to try this, we should definitely
Give me a view.
You gotta turn the camera back on too. That's right, we go.
ROV team, for your info, we would like to fire Niskins 1 and 5 or 1 and 6 if 5 doesn't work. Just for right here without moving.
Sure.
So
Okay.
whenever you can fit that in.
Okay. I see a T handle.
Yeah, that's the one.
We are using the starboard arm camera to look out from beyond the edge of the front ports at the temperature probe handle, because it's kind of out of view behind these rock boxes and gas type bottles.
Yeah, so we're pretty much not going to be able to do another. I don't think a handheld's going to work. So we're spinning it all.
Either way, just do the, instead of going the way you are, the other way. Oh, that's fun.
Somebody asked about the material for the bags.
You know what I'm saying? Yeah, like that, and then just come over.
So we have a couple of different sampler types. The pistons are made out of titanium with Teflon end caps. The bags are housed in an acrylic cylinder. The bags themselves are made out of a Tedlar plastic, which is a relatively heat resistant and has low gas permeability. They very quickly cool off when hot water goes into them. By the time the water gets back to the bag, it's already cooled off to less than 100 degrees C, and the bags can easily handle that. We sometimes get extremely hot water back there. Okay, we've got a hold of the temperature probe handle. Just got the end of it. We're going to try to put that up on top so we can get a better grip on it.
Are you guys able to do Niskins?
Yeah.
We're talking about doing Niskins whenever that fits in.
It's caught on that.
So you're on top that day?
Yep.
Okay.
Oh, it's on the other side.
Yeah, I got it.
I already made a plan for the next 5 days, so good.
Try some. I'm gonna hit the camera from this one top.
Yeah.
She talked to me.
You just got like.
Hold on. I don't know.
I'm kind of looking for her.
I don't. Yeah, I don't know if
I thought it was an educational opportunity for her to have a little bit of independence, and I thought that was big, so it's okay.
Alright, zoom out.
Stunning. Stunning.
Hey,
That's
we
good,
go.
that's good.
That's exactly what I meant.
I know, it's exactly what we were shooting right for that.
Okay, now we can see the T-handle.
What's that? Right.
I don't know why.
Maybe, or maybe I know that basically come on, if it's the only one that maybe not actually didn't feel it, and that's
just
viruses. Viruses.
Oh, that's right.
It's highly possible.
I mean, I can, the other thing I can do actually, wait, hold on, wait, wait, so.
Just on the other side with the back side of the dome.
There we go.
There you go.
Nice.
Awesome.
Okay.
You got it there.
No, not when it's like, I'm happy to pay that cost.
Oh, you mean where it goes?
Where it goes.
Yeah, that's fine.
Just a consultation. We expected that we would take a little time to cover it, but what's the backup plan, what's the communication strategy?
Just watch it out.
What? Pretty good at what?
On the back of the cable, right where it goes in. It was yesterday morning, we were from here from that.
It's caught up.
Yeah, it's on the side
Yeah, so, but.
of the gas light. There you go. You got three.
Such a second cable.
I think you can, you just can't support to the right. And the things that go to the right
Yeah,
side.
it's
Somehow that's right on the edge.
Yeah, everything in the way right now. Yes.
Which one's a true color camera?
Well, you don't need much reach because it's already there.
Yeah.
Is there a white color? Is there a white? Did you guys do a white border underneath?
Yeah, I mean,
We get it
we
past that
haven't been
hose.
white balance for a long time.
Did we get in there?
We do them several times in a day if we need to, but we haven't done one in a little bit.
Okay.
We did do something this time.
Alright.
Which
Co-
color is real?
Well, this camera, sides camera looks good.
Sorry,
The sides
yeah,
camera
yeah,
looks a
yeah.
bit pinkish on the arm, but it is a very red looking,
would say right now, for as close as we are, that is the more.
The rusty.
Color one.
Your sit camera? Or, okay.
Alright, zoom in on that. And bring our temperature up so we can see it on the
One mouse.
our sensors.
Okay, temperature measurement.
Okay. Only reading 2.
Is that yeah, okay.
Off the backside.
I'll let that turn on it.
There's some hot. Alright, got up to 98 per second.
Still going up, is it?
180.
It's going up pretty good right there, Chris. It's looking pretty good, buddy. Oh, just drop back.
Alright, I gotta stop for it. Well, now?
Now it's going down. Over the outside.
No, I can see it.
Okay.
Yeah, you can see the end of it, so.
Better.
70, 80, 90.
Still, it's just,
Yeah,
Like
it's
that.
sitting there at 60. It's not
alright, back up the camera so I can see it.
Back
You
up.
able to do that?
You could try one of the small one in front where you can see it, maybe.
There you go, like right there. Straight ahead. Right about there.
What you're saying is no.
Going up. 200, 220, 50, 290, 300.
Yeah, good job.
310. Got 313. Dropping a bit there. That's going up again. 290, 300, 311, 317.
It's right there. Try to accent a little bit.
I think maybe we should just put that aside. Or try one more quick one, and then we need to fire those Niskins and move. So you.
What else?
It's coming back up. 300, still coming up. 318,
20.
20, 25, come on.
325.
325.
326. Okay. That looks stable. That looks
Yeah,
good.
looks pretty stable right there. Alright.
We're good. 327.
Not moving anymore.
Yep.
Okay, 327.
There's two texts.
There's some giving out. Well, there we're gonna put it, I think it's just on top of that basket, put it in.
Things we probably don't. Yeah, you might want to put it where you can reach it, but we don't necessarily have to use it again. We do want to fire the Niskins just while we're sitting right here.
Can I do for you, Chris?
I don't know where you guys are storing everything.
I've got my room, I've got 2 cabinets. I've got,
I'll change it.
I've noticed, okay.
Right arm.
I've got 2 drawers, I use both of them. I use both cabinets.
What's that? See, no more than 20 fish.
We can put up with that for the last hour.
It's on the outside of where it's unfortunate, not unfortunate, but that's
To use both drawers. I use both cupboards.
So we have the
Okay, we
yeah, let me just let him stop.
Niskin firing when you're ready.
1 and 5, you said, Dave?
Yeah, 1 and 5. 5 doesn't work. 1 and 6.
I logged
You
the
log in
Niskins.
Niskins? Okay.
I also logged the temperature.
Nice job, Chris.
Thank you.
Yeah, really nice.
Way to go. I know you probably did.
Okay, moving over with the starboard arm to fire Niskin bottles with the triggers. Smoke is coming right up near the Niskins, so
You're gonna have to elbow in. Okay, see 'em?
What was our lucky numbers here?
1 and 5 or 6 if 5 doesn't go.
1 and 5, got it.
All the way. Okay, that's the reason why. There we go. Okay.
Back up.
For anyone concerned, we're going to probably go to Smoker 2 right after this, unless there's a opinion about going to the other large one.
1412.
You said 1 and
1
5?
fire.
That's what we're trying. Yep.
1 is fired.
Yup. I think it's not.
Yeah, it's not right.
Exactly. Okay. Yeah, 1 is fire.
1 is closed.
Okay.
That's
All right.
That's 1 all the way there. I don't know why 2's flagged.
That's the thing, yeah.
That's 2.
Alright.
Okay. Next is 5.
Zero says for the work guys, appreciate you all.
Such a sweetheart.
Any desires for something other than Smoker 2?
5.
Not for us.
Okay.
Do you see any diffuse flow around anymore?
It's not what people are looking for right here. There is a little bit, but
Yeah, good
at
for
Smoker
5.
2 we've been there, and I know we can just go right in and put the intake in the shrimp area and get some good water.
Got it, but I see the thing. So the same type right there. Is that one? 5 is fired.
5 is
5 is
closed.
fired. Okay.
Okay.
Thanks.
You're fired.
Fire?
Okay, I think that's it for this spot, and we want to move to Smoker 2.
What's that?
no brain was so random.
Let me get our.
Okay.
What's a good lat long for rotor right now? I just want to write that
It's 23.
Yeah.
0.469795.
23, 24 point?
No, 23.4.
Oh, you were just decimal degrees. Okay. Point. Go ahead again. 4.
Good news is you still have 1 remote.
Minus 44. Yeah.
So 1 remote gas tight to shoot. The bad news is the ramrod, the black part, when we were just doing that thing, it was very, very loose on there.
Oh, okay.
My guess is that since we had to use it today for so much other stuff,
Yeah.
it got. I mean, we can try to use it, but I don't know how to.
Okay, I think also given the time when we are going right now.
Smoker 2. Basically turn around and you're there.
So if you take the one, we just take the one that is connected to the one. So we can use the 200 and come back around. If we are running.
All the way around.
Yeah.
left, turn to
Yeah.
right.
So.
Okay. All right.
Is it okay?
What's that?
It's very easy
Found two.
without
20% was stored behind halfway.
Smoker 2 chimney is basically right behind us. We're just picking up from this vent.
So you're saying come around this way?
Yes, that's right. And to go to smoker 2, yeah, it should be basically just right behind you. So just keep
Yeah.
going, take her underneath. Go ahead and let's. I think I recognize one.
Yeah, I can't really.
Okay, so I'm gonna review what we're gonna sample over there. We don't have a team micro person, do we? That's okay. We can, if they're listening, they can come in. If not, I'm gonna go in and take a large volume bag with the intake in a swarm of shrimp.
Yes, I really made sure that's
And while we're doing that, we can look all around at the side of the vent, see what the animals are doing. That sample will take about 20 minutes, 15 to 20 minutes of pumping time.
Julie says, I'm here, ready to help, Dave.
Okay, Julie.
Do you want me to log it?
Sure, but you can log from there, or you could come back on the stool seat again if you want. You can wait a second, but whenever you're ready.
Two.
Or you can stay there if you like.
All right.
Our heading. Heading to. I forgot to write down the depth of the.
3944.
3944.
Yeah, that's the
Okay.
percent from the food sampler.
Okay. Sampling on a deadline. Been in this position before. Our deadline is we need to be at the surface when the Bari AUV hits the surface, or preferably slightly before, so we can track it and see where it is. And it will take roughly 3 hours to go from the bottom to recovering the vehicle.
Yeah, that means we need to know. Did you say my name? You said my name. Okay. That means we need to know. Sorry? Oh, hi, Evolution. I'm still in the room. We found Jimmy's. Yay.
Kind of the most difficult part is just that things aren't set up. We use the left, they're on the wrong side, or they're not next correctly.
I think so, yeah.
Or we want to be taken.
Yeah.
Well,
Oh, wow.
I don't immediately recognize this as the place that we sampled before.
It looks different coming from another side.
But let's see when we get up close.
You thinking the shrimp place?
Oh, yeah, I'm looking for the place with the shrimp. Do we have our... We're looking for shrimp.
Is this the one that we
maybe it's the one down below, behind there.
I don't remember this.
I think it's the bigger one behind. Yeah. Yeah, that's it.
Just remind me first that we have an air travel emission indication.
I know I wrote our heading down for where we were, but I don't have that in front of me. Oh, is that mine? That's your book. Okay. It's in my logbook.
The big chimneys just to the south of us definitely had shrimp.
Oh, maybe you left it next to your computer? Do you want me to go and grab
Sure. Yeah, the one that doesn't have any label on the front.
Okay.
It's just, yeah.
it? The green cover?
Yeah.
Straight to the south of us is where there's the really tall chimneys that definitely had shrimp on them. If that helps. So the big cluster immediately to our south.
Okay, so it's not this one?
I do not remember whether or not this one had shrimp, but the ones
Let's just
to
get
the
a
south did. They
just
were
come
kind of
down and
just
see
at
what
the
we
top
can
of
see.
Before we got that, what is that place where we took a sample right in the middle of a big shrimp pond?
That's right to the. Oh no! So there was a shrimp pond.
There you go.
Thank you.
Yeah, there's shrimp here. Yeah, there's one right there.
496.
Shrimp baths.
They were like the many.
I don't know how this is going to be a sample because it's way at the top of the ship that we're looking for.
Yeah.
We can definitely go there.
There might be more around the base or something though. I don't know. It's up to these guys.
Heading 166.
Got one head down there.
Our heading was 166. And so we would have been on the. There's just a few shrimp here on this side. Looks like we sampled over there too.
Oh, that's the big opening that we were, I think. See this one?
We're looking. You can see that we sampled this one, but I'm not seeing the shrimp. Okay, there's a bunch of shrimp on that chimney behind. You see the tall one in back with the anemone on the top of it? There's a bunch of shrimp on the side of that one. But we might have to be, and then there's some. There might be shrimp on that other side as well, but I definitely see them in there.
Little red shrimp.
Is it further down, further at the base?
There's a bunch of little red shrimp.
It could be at the base, yeah. Let's see.
Julie said she's happy with any shimmery flow. I just can't see it.
Okay. Yeah, we're not. Okay.
We can dive, I guess.
I had depth 39, 30. Where did our depth go? That's not the same. Do you think if we get low on the other side, we might be able to get, or are you trying to come down low in here?
I'm trying to get out of the cloud.
Yeah. Yeah.
I think once again, someone on the right hand side behind me too.
I don't see anything behind it.
No, it's like, good, bumping something. That makes any sense. Yeah, there was one we passed on that side, so I think come around this way.
Well, we might as well put this on the one that we're going to use, because we're going to do that one first. May not do anything else.
Bad news, Cecile. King Charles is not coming.
So yeah.
Dave, did you want us to shoot down to that number 5 where we definitely saw a lot of shrimp, just since we're a little short on time?
We could, yeah, if this looks like I'm not seeing a way to get in here right now.
Seems like kind of not great.
Okay, sure. Go to, yep, let's do it.
So you know where that is? But you it should be downhill from
That's the same, you're looking for the same one we took the 3,000 last time, right? In the shrimp.
That would be fine,
Yeah, so
yeah.
I looked up the sample from we took the shrimp yesterday. That would be the coordinate.
Okay.
But I don't know, that would be the very same thing.
They don't care. That's fine.
Yeah. But the shrimp
Shrimp back. Okay.
So you have the USG at home. That's cool.
Order of operations would be like boat range. Yeah, but focus on stuff.
Which depths are we using? Vehicle real-time nav, vehicle real-time USBL,
CTD, I guess, now.
vehicle CTD.
Zach, what are we talking about now?
I just mean in terms of like.
When you get up there, you're gonna see it's a huge wall of rocks. Well, wherever out. And if you come out your safe side, there was a bunch of nice, like, shimmering water and shrimp and stuff on that side. It's on both sides. It's just really crazy.
The pilots are going where they know.
Even if it's the little dots.
Yeah.
This one?
The left.
Yeah, I think there's benefits.
Look at all those spires.
You just keep coming around with that.
That looks. What we got there? Vent fish. Vent fish on the one spire.
That's the guy, when I was leaving the big vent, but I was like, oh my God, that's right there. That's a good one. You're going towards that one. You see the knife already, the little dots in the background? Straight ahead.
Straight over this one.
Straight over that one. Distance, you start to see the anemones. This is a massive, the second biggest one we've seen here.
See it on the sonar. There we go. This is a big one.
Hey guys, are the scaling lasers on?
No.
Could we have them on,
Yeah.
please?
Thank you kindly.
Oh, no, they are still on.
Yeah, they're just, I think
You're just in the abyss.
They got so much stuff in the front of the porch now.
They're measuring the
They-
inside of the So you just wanna look around anywhere for shrimp and shrimp in water, probably a little bit near the base.
Base, you say?
For sure. I know it's all the water background.
Yeah, it's all there.
Right there.
Yeah.
Right into there, yeah, sure.
Below the,
Yeah.
smoker.
We got it there.
Over there.
It's still
Yeah.
up. It's actually further down.
Yeah.
It is?
Yeah, to the
Nice.
left.
And then here.
Bottom left corner?
Yeah.
They may be blocked. There are. They may be blocked by something on the basket.
We have a lot of stuff.
Yes, they are.
We got a couple different shrimps. All this whole red bed right there has different ones. To the left, to the right. I don't think
Just line up with those leaders so much.
Yeah.
So they're trying to like tie those down.
You can see them here.
You go right down.
So there's no way of changing that now, so.
Okay, so there's some pretty good shimmering right here from this rock. There's not a lot of shrimp.
Is the live feedback? Oh, it works first. Yeah. Yes.
White balance.
What does Julie say about this? Does,
She lost the live stream.
live stream temporarily, but I.
She
We're
said any
seeing-
shimmering is
we're
fine.
seeing some good shimmering flow coming out of
Hold on one second, we'll do a whole.
chunks of sulfide with anemones around it and a few shrimp,
I say she's
not
happy with
swarms.
that.
Yeah, and there are shrimps actually. They're just very small.
Yeah,
Oops.
I think the main issue is she wants some diffuse fluid. So,
I think she will be fine with that.
Earlier on, she said any shimmering.
Any shimmering, okay.
okay, so we'll try to sample this. There's nothing blocking us. There's no smoke in our face, and
She said,
She
"Come
said,
back, go for it."
okay. So, looks like this left side might be a little better.
That looks great, she said.
Julie just is it a recent? Is that a recent one just now from Julie?
Where's gonna be a good spot for you, Chris?
I left my phone in my room, so I'm not getting any messages.
But she's saying that.
But yeah,
and back
everybody
go for
else
it.
is.
That looks great.
Okay.
Guys probably sled to the core side so that I can reach it, but it's not too far for the.
These things,
Dave, you're also gonna fire the skins around here.
We can fire them when we're either when we're done using the manipulator.
Yep. Yep.
Just as we're leaving. You want it up in the smoke as we're leaving?
One of them could be. One of them could be right here as well.
All right.
We're gonna fire all of them. Whatever we can.
All this case.
More water is better. Less.
That's science right there.
That's like it's right there.
We're doing it right now.
Sorry.
As long as you can reach it in this right now.
And no, we got to get in position with the fluid sampler intake
Okay.
in this diffuse flow.
I don't know if it's pulling on you, but,
Yeah.
It's not 10 centimeter ones.
Yeah, a little bit. Oops.
Hold on.
We thought it was a squid at first. It's right.
alright.
Great.
Porch out, Chris?
Yeah.
Porch out. And pushing myself away. Yes. Go slow, I got rock or
Huh.
something now.
Wow. What's happening there?
It just opened up.
You stop at 50.
Yeah.
And this is fine. Now
So much for diffuse flow.
Well, is that just, is that
I
sediment?
think
or
it just
did we-
opened
No,
up
that's-
the path.
Oh, no.
We'll see what the temperature is.
that's why.
Any time program first, you know,
Yeah, that was interesting.
That was
really more time.
well,
I'm pretty like, yeah. It's
It's like
warm
back
it
off,
up until you
down,
open the
like,
pan.
you think we can
It's like
fluid sampler nozzle?
Like there and look at all the pipes.
So it's clearing up. There's it's clear flow right over there on the left
That
side.
disturbed them to receive that.
Yeah, that's all
Should be able
right.
to.
Okay, no, that's all right.
I always felt really bad when we messed up those strips hot today.
No, they're fine.
they're good, yeah.
They're gonna
Wrap
recover
the camera in.
quickly.
Yeah, definitely.
I think they can even do black smoke.
Yeah, they're intact. They were almost in the black smoke. They just got up, in.
There's a, yeah.
Oh. Lights on. I want to get over that.
Okay, if that temp probe T handle is right where you can get it, why don't we try that first? Just take a quick spot.
It should be a lot easier than last time.
Yeah, it's ready to grab. So let's
Yeah.
let's try those two spots or one lower left.
All right.
Then we switch.
Yeah, it's the next time. Yeah, obviously.
Joe, do you want two Niskins here at the base? I'm sure Joe or that Sean would probably be interested in one of those, right?
Yeah, I think do rifle do 2 and 3.
We have 1 and 5 already fired.
What's that?
We have 1 and 5 already fired.
Right.
Okay. What's this? What's this waypoint called? Waypoint. That's 14.
That was my fault. I was concentrating on my cable.
Still dragging on the rock?
Yeah. I'm gonna rack back out. Better be good. No, these fine.
Peter's fine.
Yeah.
Did you reposition the situation where that cable's getting a little bit starting to pull on?
Yeah. Where's the gas tank? That's how we can use it anyway.
Well, we're getting 12 degrees, just kind of waving it around in there. Okay, over on the left side.
Cooler.
Some clear flow coming out from these blocks of sediment.
It's rising up again.
There we go. 15, 16. Okay, so that's right around 16 right in there. 22, 25, 26,
temperature is around.
What kind of temperature are we expecting?
Those are good. 16 to 26 is what we're getting in there. It's good microbe temperature. That looks like a fairly good spot to put the fluid sampler intake. So
We're at
25.
Still climbing? Still climbing?
Almost 27.
Almost.
I think those are fine. We got up to almost 27. So just what's the best depth we have right here? We were going on the big bold numbers that
You
were
have
up
it
there,
here.
so I wasn't sure which sensor those were coming from.
They
CTD?
over there.
Oh, there it is. Okay, that's the official one then. 3956.
How far are we above the base of the,
Our
I'm showing an altitude at almost 3 meters, but I don't
Yeah.
know. We're overhanging, so we're sitting up against the edge.
Okay.
That's just seawater below us is 3 meters.
So we can see the lasers are sometimes hitting the gas type bottles depending on what our camera angle is.
Yeah.
Alright.
Yeah, you can go ahead.
Well, that's quite black from our previous sampling. Okay, turning on the flush pump. Not moving yet, is it?
Nope.
Yeah.
Stop that. There we go.
There we go.
Let me make sure I see where the red is and those are just
Are you picking up anything else that you no, not yet.
Yeah, it's that wrist.
I'm not sure if these are changing. Are they changing?
There you go.
Don't see anything. Could you just
I might have to
close it and restart the program again?
Alright, how's that?
How's that, Dave?
Okay, 1 second.
We have been tracking the AUV. It's running a little slow. We think it's going to be coming up from deeper, and there's a chance we might run out of batteries again. So I'm going to go find Eric Trotsky and talk with him. But the off bottom time might change.
Or earlier or
Later. We might give you more.
Okay, thank you.
Okay, that's
Sitting on that rock a little bit, is that okay? You're gonna bring it up?
let me see what we got here. Oh, that's sorry, the flush pump went off for a second. I have to get that running again. That looks good. Let me just see what our temperatures do.
Okay.
Okay, we're getting
Pumps on. Flush pump heading up.
yeah. That looks like a good spot. So
All right.
let's just see.
I'm ready when you are.
All right. We're getting up to 20 degrees on T1. T1 has been reading a little low. It's not accurate at the moment, but we did get our separate temperature measurement. Anyway, this is pretty close, 22, 23. So that looks good. What's that?
What temperatures are you getting?
Up to 23, maximum 20, there we go, 25. It's still going up a bit. The back end is warming up.
You have other things available? Other?
If we have time,
Okay.
yeah.
How long does it take to fill one?
This is a large one. It takes 15 to 20 minutes to do this large one.
They said we may be getting a little bit more time. We were
Yeah.
checking with the AUVs.
Okay.
The facilities.
50
Should we start then?
coming up. Yeah, that's getting leveled off in the manifold. So, anybody from micro here? I know we want to be a little careful about how much we put in.
I can,
I'll set it to 4,000, but you know, we did have one that kind of broke when we put that much in it. So we'll start that off. Hang on a minute. I want to change our pump
Judy
rate.
said whatever you did last time.
Okay. I think last time was actually
3,000 was last time.
Yeah.
okay. Restarting that. Pump is on.
17.
Oh yeah, the wheel's actually moving.
Hey.
Saw it earlier.
At least for a little bit.
For a little bit, yeah.
Dave, she said, is it really gassy? If not, close to 3,600 or 3,800 should be okay.
It won't be pressurized, so yeah, it is gassy in terms of having a lot of hydrogen and some methane, but we're not getting. We didn't get gas headspace very much, at least in the hot samples.
There's only one more good one.
So okay, we'll go about 3,600 then.
What's the name of the sand? Diffusion, like smoker or
Well,
something?
we are at waypoint 14. I believe this is called Smoker 5.
Okay. And shrimp bath?
Well, I guess there's no shrimp here though, so
Diffuse flow, right?
yeah, yeah, blocky, yeah.
Okay, so we would, instead of asking you to be on deck at 3:30, we would like you to be on deck at 3:50.
Okay.
So that's 20 minutes. You can come up on 12:20 instead of 12 o'clock.
All right. 12:20 work. Get that.
So
Thank you.
it's just a
Okay, no, thank you.
Yeah.
You heard that, Dave?
Yeah, thanks, Dave. It's great.
Okay.
You know what? Giving you the, yeah.
Okay, we just gained 20 minutes of work time.
Used to have, but I thought it was all his.
You didn't like when I grabbed it like this?
It was.
Julie said if we have another 10 minutes, we could do an RNA.
Yep.
Is it possible to focus on some streams?
Oh yeah, sure. Yeah, we can use a camera. Just do that. Okay, that's stable.
What I here I didn't. Yeah, those there.
These guys are back. All
I
right.
think that those are the morphotype we collected with the voice.
Do you want the ones up through the clear water or the ones?
Yeah, the clear water.
That is a little better view.
So I think that you
Water
have
shimmering here.
a mix of juveniles and adults.
I already know what happened.
And I don't know if the adults are the same as the juveniles.
There's a little scale worm down there.
Yeah,
Interesting
can you
scale
focus on the
worm.
worm, please?
Sure.
It's so easy to loosen.
Oh, there are several.
Yeah.
Awesome. Oh,
That's Max right there. Pretty good focus.
yeah.
They tap it just a tiny bit up, so we lose that. Okay.
So before leaving, did we try a slurp gun here with these polychaetes?
Probably.
Oh, and there are some gastropods there. They, oh, that's perfect.
Do you know which suction jar is
I think that
available?
is only one that is working because it's not rotating.
So it's whatever position it's on. None at all?
No,
Or
we can't pick that up really. I mean, maybe with the left arm, but we can't.
okay. Yeah.
We can't rotate it at all. Like we might be able to get stuff in there just because it's luckily aligned. Then we won't be able to rotate it so they can just swim back out or something.
Yeah, okay.
Well,
My
it's-
understanding was that if it was like gastropod or something like that would stay on the bottom.
Oh, okay. Yeah, if it's something heavy, yeah.
Yeah.
We might be able to grab it with the port arm who did this. It's just whether or not they can maneuver.
Okay. Okay. Yeah.
That sounds somewhat unlikely to work, so
Mhm.
I'm gonna put you at the last thing. Then because we'll get these other things done, and then we're trying to fire Niskins, so we want to be. We could either do that, and then you take over and get whatever you can at the end.
If you want to be a little squirrely, Dave, we can do the distance right now.
Sure. That sounds good. Let's do them now.
Can we take the camera? We're gonna need the camera to
Yep.
do it.
Okay. Yep.
I'm right.
That'll give you some time, Juan. But
You're right, Dave. Yes, I'm right. Which ones are we doing? 2 and
we
3.
got 2 and 3,
2 and 3.
and then there will be 4 and 6 left. I think we said 2 here, and then the other 2 would be up in the smoke when we're leaving.
Are we down here, sir? I think it's you can barely
Trying to
see the
see.
2 right there. You can see the 2.
Yep. Did you do an RNA photo as well? I just wasn't.
Just tell me to do it.
Let's see if it fire.
Is it fire?
Looks like it did. Yes, it fired.
That's Niskin 2.
Let's skip 2.
Yep.
What's our sample up to now? Sample number?
That was 18.
18. Okay.
And 3, yeah.
hour.
Sir?
Is this the last one we're doing?
At the same time, we maybe push it to 12.
Did it not?
Is 3 not yet?
So there's enough time.
Well, it's also.
Yeah, it is.
Flag tank down. 3. Yeah, that's how it was looking when we did the last one. 3 was on fire. Right?
I think that's fire.
You guys can let that go.
That would be up.
Yeah, so like I said, when you you have to protect the other day, 3 was fire. Plus 10 was fire.
Yes.
Yeah, that's exactly how it was.
3 appears to be fire.
Okay, good, thanks.
4 is the hard one.
Appears.
We're doing 4 one? No. We're all saying let's see.
I think that's it for right here for the Niskins, yeah.
Alright. To do what? The honest truth, success would be much higher with the suction sample you do that. The bag, I mean, you have to like, put it up and it's not really good.
Did you get the message that the 3,000 milliliter is fine? Question mark?
3,000 is enough? All right. It'll probably actually be more than that. It'll probably come out about 3,300.
Where do you want to be, Ben?
I'll show you. Alright, man. We called this before you did the situation. Yes. So, starboard arm, outward. So everything is going well in the job. We do like something. So everything is port.
Okay, so
not just ramp rock. That's
Thank you, Doug.
Sorry, whatever. So cross. All you need to use the right there. So set that there. Easy to
All right, so we've been very busy sampling here.
You might add to this.
Taking a large volume sample for microbiology, virus work, stable isotope probing experiments. And we took 2 Niskins sitting here for sort of near bottom, near vent environmental DNA and trace metals, and iron binding ligand properties. When we finish this one, we will take a filter for RNA or DNA RNA, pumping water through a filter and then having it preserved with the buffer solution, RNA later as it's called, which is basically concentrated ammonium sulfate.
Sophia, just a reminder to pilot change out?
Yeah.
Thank you.
Yes, because this is what is missing, you know, from the images yesterday, all these small filters that usually are these things, and we are adding these things very easy. So yesterday we had something of the black spot.
Okay, volume up to 1,800. Yep.
Can we check that note here?
You bet. Let's have a look. Say where?
Here. It's pretty much over the.
Okay. Got some things.
Oh, it's good.
Do we want to turn the iris down a little?
It's you. It's in auto right now, so I can't adjust it.
That's good. No, we can zoom in more. What do you want to look at?
Yes, please. If we can zoom in close to the scale rooms. And then just up and to the left.
Yep.
All of these, yeah.
Oh, you got a little,
So we can try to sanction sampler here, we don't even have to work with.
quite a bit of scale worms there, and
There's so many.
So usually
crinoid.
those are very common, including the ophiuroid. Those are very
Ophiuroid,
common when they're on
ophiuroid.
mussels, but if not, they kind of hide in these cracks, so they're not that evident. Yesterday I didn't saw those.
I did.
You saw this scale one?
Pardon? No, the right.
Give you a little more. That's the max zoom right there.
Good job, Dave. Looks great.
Lots of microbial mat in there.
That's why I was kind of like thinking that maybe with the back here could be possible to sample with rust from the behind.
I mean, it looks
like
yeah, it looks crumbly.
yeah, exactly. So
you
maybe
could-
everything ends in the bag and then it could be better than the slurp.
Could be. You'd probably get a lot in a suction sample if you could get it pointed on there.
Yeah, my only concern with the suction is in the way up.
Yeah.
But
oh, that if you, yeah, for mobile animals, they'd get out.
Yeah, especially the scale ones that are kind of light.
Yeah. So we're not able to close it off, right?
Yeah.
Okay.
Yeah. So.
Juan, is there an area where we can get the scale worms, the gastropods, and the ophiuroids?
I mean, the scale one and the ophiuroids here yet. See how much they go. So we will try maybe with the back, like, so collecting with the bunch of rocks, yes, or with the base of the bacteria. It looks healthy. Yeah, it's not that. It seems they are using the memory for such things. Oh, yeah. And do you think they are iron? Yeah, it really seems. Just because they are super clear. Looks pretty much. It's good color and texture. Yeah, it's difficult to say. Ones are polarized.
The ones have eye spots on the top of their backs and the others don't. Definitely different species.
It's tricky fitting here.
I think it's this one's probably these ones that are low hanging fruit. I'm gonna get picked.
Suction sampler is not working at all. It is working, but we only have one jar, and we have the risk that when we come out, it's gonna be constantly pushing, and so. Oh yeah.
Dave, can you hold it there for a second? I'm just
Sure.
gonna flag this as an outreach shot.
Sure.
Thank you.
That's an awesome.
That's an amazing close-up. Thank you very much.
Give you the whole animal.
Okay.
That is what I like when you collect fluid.
Yeah, this is
We can focus in the small and then.
absolutely. Okay, this sampler's ending, so that one's done. The total volume 3011.
And press volume?
And what?
It's
the-
3011.
Yeah, and I got a maximum temperature 32.3 and an average of 20. And T2 has been, say, around 10 degrees.
Yeah. I need to get down. Yes.
So that one is done. Julie wanted an RNA filter.
Oh, the request is for data.
We're going to do starter filter, RNA filter 13. So that's okay. Starting this sample. You're ready.
In a second, I have received the program.
Yeah.
Started the sample.
You can stop it. Yellow is caused by Jonathan gave out yesterday, right? And it's not necessarily so we might, so it needs to reflect. FEOH.
Yeah, these, well, the stuff we're looking at there is some kind of microbial matter.
Yeah.
It's fuzzy. You already
Yeah. The reddish stuff would definitely be iron. There's probably some sulfide in here as well. And so some of those could be sulfur oxidizers. They probably are, given the temperature and what we saw in the fluids. But we haven't measured iron yet, so I'm not sure how high they are in metals.
Sorry, Sean, I thought the other arm didn't work if they were sampling.
Sean knows all about those iron mats, so you should ask Sean what he thinks of these. He's right there.
Sorry, do you want to?
Oh, there's a crab.
2 and 3. Oh, one and 6 and 2 and 3.
Crabware.
Yeah.
Oh, tiny little guy. Yeah. Huh. That's a very small crab.
There is more fauna than what I thought.
You know what time we require?
I have all of the information right here.
I have the feeling there is more species here than black smoker.
Here's whoops. Just like this.
70. Yeah.
Okay. This sample, this was S0496.
7 minutes.
5.
Oh, 7 minutes to go. Okay. Okay, we're running out of time.
This is the one right here. Far end this side. Yes.
Right where they are right now.
Right.
There was this pinball.
Julie, I know you're listening out there. So we are down to our last, how many minutes? 6 minutes. We're taking RNA later, RNA filter 13, but we're probably not going to have enough time to get a full volume on that. So how much volume can get you a reasonable result? Who's got the chat up? I want to see what Julie says about sample volume. We would really like to do a suction sample here as well.
She's typing right now.
Okay.
Any volume is great.
Okay.
It is 12:15.
We are pumping as fast as we can. We're trying to get up to 1 liter.
Yeah, so it is.
I need to fix that.
It's easier to read on the further exportable.
So I'm not even sure that
Ideally,
those
at
are
least one
scale
liter.
worms. Of course. It could be SE08. It's another family. They're kind of, from far. They're kind of similar. I don't know if this is case. See the red one there? Yes. Those are the ones that maybe. Yeah. So
Do we have like a? Sorry, no. Go ahead. You guys are good. I was going to ask the biologist. What's the size of that anemone right there, just for scale? Because we don't have the lasers in the view, so I'm wondering. Did you check that?
That's the problem. Look at the one before.
There they are. Okay. All right. So that anemone is maybe 5 centimeters across. Okay.
Okay, one of them
Oh, no,
wrote
no,
a
that's
comment.
the sample naming convention.
So the ophiuroid is only about 1 centimeter across total.
I was waiting to read the first one. It took me forever.
These are small animals here. The shrimp and the ophiuroids is a tiny little dark gray crab that we saw. Probably about 1 centimeter across also.
Yes, and then with two skins or what?
No comms drop out at all. Yeah. In about 4 minutes.
And nothing.
Well, we can just look at that.
Okay, I would say we're getting down to the 1 liter mark, and then we can pick up the HFS nozzle and try to do a suction sample, and that's the last thing we got.
You're gonna fire off the last miskin as you go up through the water, right?
Up through the water, yeah. We got 2 and 3 sitting here.
You can do 4 and 6 up through the water. Because we've got 'em.
Okay, it's closing that sample. We can pick that up. We got 1,021 milliliters in there. Be a little bit more than that probably, because it pumps about 10% more.
It's even more for you now. At that point. You got the time.
I have it in Geologic.
Maximum temperature on that was 26 degrees, averaged 20.8.
Are you taking them even though T1 is not reliable?
I'm writing them down. Yeah, it actually seems to be behaving pretty well. We did a bunch of connector work on it last night, took it all apart, put it all back together. Ben, who's operating the arm, did a bunch of connector cleaning last night. and cable undoing and redoing.
Thought that would be a lot of stuff.
I do always.
It's a single. Timing is actually where we're
We're going to try to do a suction sample.
Ah, okay.
So we're done with the fluids. Did you have any lunch? Did you get any lunch?
Yeah.
You did? Okay.
Do you want to go? Tamara and I switched. So.
Either that or tell somebody to save something for me, but I guess I can go up there. Juan, why don't you come on up here and do your suction sampling? Unfortunately, you only got a few minutes, but okay. It's been a good dive. Thank you. Over to you, Juan.
Thanks.
Okay.
Joe, you can just. No, you can do it. When they take our
Further down. Okay, try that. Got it. Careful you're picking up the HFS. Try to go out. There you go. Good job, man. We did it.
Good. We are not streaming.
Close up where it hits the wall. So just rotate counterclockwise. There you go. Shoulder up.
Because I don't see it here.
Oh, it hasn't been on.
Oh, I see. Okay.
You're against the wall then? Bring it in.
Oh, right.
Okay.
So,
I think we were going to play.
yeah, so the idea is to try here all these worms here and the brittle star over there. If we can try to, suck,
See that bit?
do a suction.
Okay, so that's what we're going for. So when you're ready for uniform.
With the brittle star as well. Please. Thank you.
Okay, so see this crack?
If we can start from below, that there are several, and go up, I don't know if that would be possible. That would be awesome.
Well, if we throw in the multiple beaming, it's somewhere in the neighborhood of.
You ready for some suction?
Yeah, it's technically about the 17.
That's you touching the wall. I'm going to turn it on.
Are we in the right, John,
I don't know. I was told that we were, and that it doesn't rotate right now. So it is what it is. That's the section on. I'm not seeing anything.
No. Okay, so can we try a back if it's not working?
Probably 2 or 3 hours.
Back.
Maybe 2 hours.
How about a back?
Back.
Up there.
I mean, if we take a bunch of sediment with us, or a bunch of rock with us, as it is, because it's broken now, so probably it's.
I've turned it on.
Yeah.
One of them.
Yeah, but it's not going down, right?
3 days if we find nothing. 4 to 5 in 3 months.
I would try with the back if possible.
No matter what.
Put it down, let's start with that.
That's it.
Where do you think the best spot is for finding something?
Alright, just now, it's ready for the keys to work on the now.
Rotate counterclockwise.
Using,
Oh, yeah.
doing it on somebody else's computer on
There you go.
So now I'm looking at the actual.
I'm going to bed. Well, access.
Actually, I have a license now. Just merge.
You're good for a drop.
I'm getting tired of knowing my layers. Since I get more and more layers, it's more to lose when you start that.
So I don't know which bag would be better. There is one that has a bit of metal that comes out.
That's this one on the right.
Okay, perfect.
Then it's the right one. Number one extension on the starboard side.
Number two.
I like as files I've not really seen it. I'm actually better than Geochemical because you can get it better.
Yeah, I don't want to go to
I'll go for this one.
I find that ArcGIS is very unintuitive and we have changed from the desktop version to Pro at the university.
Let's try that.
It's like I know what I want to do, I want to just change the color of the line and just like
I just like to be able to change the color ramps and when somebody wants a far, be thoughtful about it, put the backscatter and be able to transition in down with it and do a backscatter. Going back to what you're up to, transparency slider. Yeah, which is really good there.
so
But you know,
there's no
last 5 years, the last 6 or 7. Getting back into the is
Perfect.
so looking at the map of where we started the dive, there's no clear source of where this are is coming from the future.
from here. Target.
I think we sit view. Okay, you see the brittle star, you kind of sucked up in that little crack.
Yeah.
And then if you start below, you can see there's a few
Yeah.
worms on the way up. So
Exactly.
try to
Let's see if it works.
I was so sure we would find something, and so there's a second trail. It's going to be big, and it's just
The other frustrating thing for me is I like to collect data, so the data product, is I can interpret data. I can't interpret the data product.
just find some map that I
you need to rotate that to face the wall.
I have to max
Oh, you're gonna do sideways. Okay, let's go. Over.
because I'm also issues already afforded as well. So let's try. Or maybe Jeff is organizing SGIS.
I think further we go, like the IR.
Too far left.
There's all the things, but yeah, I don't prove that this, you asked me about old layers, what you did 3 weeks ago. This might be the first time.
Okay. If we,
Okay, so you're just getting the corner.
Yeah.
It'd be better if you had a face. So if you had that left side, that was going to work pretty good, and then just scrape it.
Yeah.
Yeah, it's looking better. Start a little bit below them. Put a little bit of pressure, and we'll slowly bring it up in there. Start a little lower.
No, you can do whatever you want. I have my stuff
Okay.
safe.
Yeah.
Just kidding. Bring it up,
No,
maybe a little rotate.
I'm very particular about colors. Whatever makes you see what you're looking at.
If they want to get that equipment, you really got to come up on down. Things where we get that enemy, trying to just get that enemy.
No, what's that brittle star and the worms?
And the worms that are around. Let's see if it's possible to scratch them.
Start coming in at
Yeah, I think
0.45.
that
Coming up at 0.45.
Yes.
sometimes it's
Okay, so
deceiving.
the brittle star?
Yeah, the Bretier star and all the worms that are on the cracks is underneath this rock here. Can you see that? It's huge. Yeah. Oh. Ciao.
The guy is flying away?
That one.
This.
It's 12:30.
Yeah, it's okay. If we can get the worms, it's okay.
Right there, the shrimp.
No. No.
See it sit just above your neck.
Get some speed diving and do some speed. Man, the geologic.
Okay. Let's see.
It must take a long time when you go hiking again.
We use.
And what else did you want to grab in that?
So in that crack where the brittle star was, there are some worms there. If we can try to.
Just gonna try to scrape it off real quick.
Yeah.
We got a really good going.
I took them in the field once. We were mapping out the fields on healthcare.
See one of them back over there.
He's a very fit dude. He's
Are we trying to sample animals or sample crust?
We are sampling crust, so maybe some animals first.
Okay.
Hopefully get something in there.
Yeah. Oh, yeah. Ooh, I saw it for a while in the back, but I think that it's okay.
Did you come out?
I think so.
I don't know, there's a lot there.
Yeah. Well, let's see.
Alright.
Okay.
Ben, can you operate the winch? I set the values. Set on depth, I think is what's next.
We just set the bias number.
I'm not.
We have been traveling for.
Are you aware of something like that?
Spring 21.
Yeah.
Are we putting one about?
Yeah, please.
Two sections.
I'm gonna turn on the water.
So that would be.
Yeah. Freeze immediately for you.
Either or, fine.
Everything is one.
Where did you go?
And so it's going to the big biobank.
What do you want?
Let's do really nice.
So that is the Dike number. Oh yeah, no, it's 21, you don't?
Going up. Can you fire off an Iskin?
Yeah, I'm just trying to spell that.
All right.
And I'm gonna get this real quick.
Tell me the
It's
altitude.
back 2 and it's gonna go to
What's
the,
that?
Tell me the altitude as well once you do fire them off. If you're gonna fire off both 4 and 6, that'd be great. 4 and 6.
Are you logging or
You do it.
can you just tell me when you fire again, please?
Coming in for a fire. Which ones again? 4 and 6. 4 and 6?
Yes, please.
Do you want the ones? No sample?
Okay. Separate down here, brother.
Or you can make these, whatever.
No, I can.
You're in the class.
No. I see some in the back, actually.
Yeah.
Maybe back it up a little bit. My delta's 55, but we're fine. Okay, I'm in it.
Alright, I'm gonna hit 60 right now and then we'll have to work on it. Alright, have a look up.
Alright. Oh, there it goes.
Yeah, alright, so. let me go with that. 6 definitely fired.
Okay.
And the altitude is sitting at 30.
What's the altitude, sorry?
30.
30, okay.
If you didn't get 6, don't worry about it. We can go.
6 is good. 4 top.
6 is the one that definitely fired.
Okay.
Can you, airline come out? Camera.
Very hard, but it's the internet maybe refresh.
Does not look like 4 fired, but I'm gonna give it another hit.
Okay.
All right.
We're still in the cloud, which is gonna start yanking up in just a second. Before we go up bottom, before we just, I don't know if you wanna say goodbye to everyone on the street. On español, y I'm gonna miss, y permiso.
Okay, so last operations before we finish this dive.
Would you like to miss a separate effort? What do you mean?
Alright, that's 50 off bottom if it went.
Uh-huh.
We are collecting some water for chemistry and microbiology potentially.
I can't tell, so
Okay.
it's a maybe, but I don't think so.
All right. I put this as a comment. Huh?
Okay. Sorry about that, guys.
No
No,
problem.
it's okay.
What's that? We're already on Encore. Alright, yeah, the winter's been, yeah, the winter's been going up. Yeah, John, do you want to do a sign off?
Yeah. Okay, so until here, this dive. Thank you very much for being here, and see you on the next dive.
¿Y en español? ¿En español? No. I speak Puerto Rico.